more like connecting to each other or having a few meetings either in Xilinx, Qualcomm, or Moschip. So we were very kind of an informal, know each other, good friends in the industry. But I think this last 2 years, I think a lot of new things. I mean, we have new entrants coming in, a lot of energy and enthusiasm into IESA, and I'm sure this is infectious and makes it more and more going forward. And also, I see the topic is really, really very apt for the semiconductor business, because this is something which is what has taken up the artificial intelligence, like what both Venkata and Satya have kind of talked about, has been mostly in the papers and discussions and research papers, and more in the university professor type of discussions to reality, has really been possible because of the kind of trends that have happened in the semiconductor industry. What I mean, the processing, the horsepower in the processing, the processors, the dedicated GPUs and NPUs that have come in, the AI inference chips which have been introduced by many semiconductor companies. So I think that's clearly the trend, I think. And also, one other thing as part of Qualcomm is, I mean, I do have to say that it's very exciting, because a lot of it is not, most of the AI, if I look at it in the last 7, 8 years or 10 years, has been more on the cloud, and more processing happening in the cloud, and more of the client devices are more dumb terminals or dumb devices, taking the inputs and passing it on to the cloud, and a lot of that processing happens in there, and the directions come from there. A lot of that training data, all that was residing in the cloud. But with the, like what I said, with the advent of all these new the speed, the technologies, and the NPUs and GPUs, a lot of it is kind of moving down to the client, which is very exciting to companies like us and many of you guys as well. This adds a lot of these distributed AI computing is what I would like to see, saying that it's getting distributed between the cloud and the client devices. I think that's really exciting to many of us, as well as a lot of startups. There will be new use cases, new business models which might come in, and then a lot of new algorithms to be done. I mean, just picking one example, like, I mean, maybe your security camera was just taking live video and sending it back to the cloud to get processed. But a lot of that intelligence can be pushed into the security camera now, saying, I mean, the data doesn't have to be sent every time there. It can process itself. It can check if there is any movement, generally make some kind of, I mean, events, send it back. Or even you can just go check that into the Facebook or into your phone directory, if it has pictures in that, and see if there is somebody who you know is coming, and it can tell you who is coming in. I mean, just kind of a simple example, but what you can push information to the client instead of pushing it, I mean, making all the processing there. The other big thing is the automotive. I mean, that's something, a whole big discussion. I don't want to even go into the details, but that's another great opportunity, as more and more automotive side of it is becoming digitized, because I mean, Tesla leading it, but there are a lot of auto companies. I mean, even from government, people are looking at electric vehicles. Once you have more semiconductor into those cars, lots of different opportunities will evolve. And then a lot of artificial intelligence, I mean, driver assistance. If not, I know, imagining a driverless, I mean, a driverless car in India might be a real big thing, but at least driver assistance, a lot of the different driver assistance, like what we have in the ADAS at different levels, can start be implementing, and that also adds to a lot of opportunities for the semiconductor ecosystem, as well as software players, a lot of embedded software players, and folks who work on AI, ML algorithms. So I think this is a really apt subject for us, and I'm sure there will be a lot of intellectually stimulating presentations in the next 2 days to both young and old, the audience, and looking forward for feedback as well to the committee, like what we can. I mean, this is something we have done now, and I think definitely we would like to improve. Myself, I mean, obviously Venkata, myself, and Ajay, Srini, everybody. I mean, we look forward for any of the feedback to improve it going forward, and maybe add more topics there as well. Thank you. Welcome to the summit, and thank you again for attending this. And thanks, Venkata, for thank you. And
thank you, Shashi. Thank you so much. It's been so much a pleasure to have you with us today morning. And your wonderful insight into what Qualcomm is doing. As people know, Qualcomm is in the top 5 leading semiconductor companies in the world, and they've been investing heavily into 5G and AI type of applications and both hardware and software, and they are going to be one of the key players in bringing artificial intelligence to the home. And with that, I invite our next speaker, Mr. JSG. We request you to address the delegates now.
Good morning to fellow panelists. Good morning to all the attendees. Let me begin by congratulating IESA for putting together this very important conference that focuses on AI. As we have been seeing in the last so many years, and particularly last year, which has been very devastating for all of us, the importance of AI for different sectors of the society, different sectors of the economy has become very, very important. And I see tremendous possibilities of AI playing a very important role in the post-COVID economic recovery also, not just in India, but all over the world. So therefore, I'm very happy that lots of domain experts are participating in today's conference. They are going to share some very valuable insights. Telangana, as many of you would know, is also considered to be a very technologically advanced state, a very progressive state. Whatever we have achieved in the last 6 years, and 6 years has it been since the new state of Telangana got created, the results have been absolutely marvelous. We have been one of the pioneering states in adopting AI. In fact, we were the first, literally the first state in the country to develop a separate policy for AI, which we call our AI framework. We also created a dedicated institution that is called TAIM, the Telangana Artificial Intelligence Mission, which was tasked or mandated to look after AI rollout and support the government in various facets of AI. And of course, we have taken lots of very talented people to be a part of the TAIM and be a part of all the programs, etc., that we have rolled out. So when I mentioned that we were one of the first states, or perhaps the first state, to come out with a dedicated AI framework, let me share some broad contours of that framework. So there are different pillars on that framework, and I'll touch each of them very, very briefly. That will be a very good context for remaining speakers in the conference also, to look at how AI rollout is happening in different parts of the world. Now, the most important and the most critical requirement of writing strong AI algorithms is availability of data. And obviously, while data sets are available in different contexts, but definitely the government itself is the repository of a huge and humongous pools of data. So in the AI framework of Telangana, we have also committed that whatever relevant data that is available in different government departments, all that will be made available to AI researchers, AI practitioners, startups, companies, and all this data will of course be cleansed, annotated. It will be made available in a machine readable form, so that people can use that data and write good algorithms based on AI and ML logic. So that is one very important responsibility on the government. And We are supported to a great extent by the fact that in Telangana, much before the AI framework was introduced, we already have a open data policy. In fact, I would encourage participants to look at www.opendata.telangana.gov.in, and you will find more than 150 plus data sets which are absolutely ripe and ready to be utilized for various AI usages. Other than data, the next very important requirement would be where are high performance computing infrastructure available. So sometimes we do realize that the lack of this kind of an infrastructure becomes a very important bottleneck in developing solid algorithms. We perhaps have access to huge quantities of data, but do not have the computing tools to make use of that data, and therefore the government has also started looking at identifying opportunities to provide HPC in different forms, and I'm happy to share with you that with the help of private companies, with the help of private partners, we have been able to identify 2 academic institutions, one Hyderabad IIT, and the second one is a local university called the JNTU, Jawaharlal Nehru Technology University. So at both these 2 locations, with the help of NVIDIA, we have been able to install HPC or high performance computing facilities, and the one in IIIT is right now open only to students and researchers there, but the one which is there in JNTU, the government is working with JNTU to make it available and accessible to everyone. So we will have some basic HPC facilities, but obviously in days to come we need to supplement much more of that. The third very important thing is about skills. In fact, I remember I was a part of some other conversations also. As many of you would know, there is a very important national goal which our Honorable Prime Minister has set before us, that India should aspire to become a $5 trillion economy in the coming years. And McKinsey had done a study for NASSCOM incidentally to find out how much of that can come through artificial intelligence, and they were able to give a very strong case, provide a very strong justification that 500 million of that can come through artificial intelligence. But there was a caveat, and the caveat was that all this potential can remain unfulfilled if we do not nurture and create the right kind of talent for that, and obviously that is one very, very important government responsibility. So in Telangana, in the past 2 years, we have done a large number of programs. We have this agency, a government agency called TASK, the Telangana Academy for Skills and Knowledge. So TASK has conducted multiple courses, short courses, medium duration courses, and of course very high level, sophisticated, deep courses on AI. We have also partnered with other kind of institutions, private technology firms who also have a deep practice in AI, and with their help we have created AI resources that students and other practitioners can access to improve their skills and knowledge. In fact, I mentioned about JNTU a while ago. I also happen to be the officiating Vice Chancellor of JNTU for the last 20 months or so, and while we could have done or could not have done so many things, but one particular decision of JNTU which was taken some months ago that I feel very happy about and feel very proud about is the decision to make one course on AI compulsory for all students. So regardless of which course you study, and JNTU is not just an engineering school, while the name indicates that way, but there are also management courses, pharma courses that JNTU offers. But what we have decided is that regardless of what course you study under JNTU, you will have to compulsorily do one course on artificial intelligence, and of course that will be a course with lots of seriousness. You will have to study for that course, you have to pass that exam, it will be reflected on your grade sheet and so on and so forth. So that is the importance we give, that every student must have basic familiarity, and of course if you want to learn more, there are senior level courses that you can do. Hyderabad IIT, again I mentioned this institution, has become the first IIT in the country, the first institution of higher learning of any kind which has introduced a dedicated BTech program on artificial intelligence. So fortunately in Hyderabad and in Telangana, we are working on creating huge quantities of skilled manpower, which tomorrow will drive the agenda of India becoming a $5 trillion economy using AI tools and solutions and products. Of course, when I speak about these kind of skilled courses, an impression goes that these courses are only for engineering students who speak English, who live in cities. But we also note that there is a range of AI related jobs and tasks where sometimes a lower order skills can suffice. So for example, I spoke earlier about making data available, but as I said, the data needs to be organized, data needs to be annotated, data needs to be cleansed, and so on and so forth. And we found that all these can be done by young people who need not have very high levels of education or formal training, etc. Even rural kind of candidates who are living in smaller towns and villages, we can train them properly and they can be very good in doing these kind of things. So that is also something that we are working on. So the skill sets range from very high level PhD level skills to basic data related skills. The next very important component in our AI framework is AI's usage in within the government itself. And I'm happy to share with all of you that the last year, that is 2020, was celebrated in Telangana as the year of AI. Now we all know that 2020 has been a very, very depressing year. Nothing really has worked in this particular year. But I'm happy to again share with you that while we started the year of AI activities on the 1st of January 2020 and this pandemic hit all of us roughly around the middle of March, but we did not get deterred by that. In fact, almost 80 to 85% of what we had planned to do in this year of AI was well accomplished. In fact, COVID gave us new opportunities to do other things as well. For example, we used a very strong predictive analytic tool, AI based tool, which was put together for us by a NASCOM based consortium, and we were able to use that to do very effective COVID management. So that particular tool, since I have mentioned it, I would like to explain in a minute what it did. So the tool was able to give us a very good understanding, at least 15 days in advance, on which are going to be the new hotspots where the cases will spread much more. And obviously, if you have this information 15 days in advance, you can move lots of equipment there, like ventilators and other oximeters. Similarly, you can alert the health professionals, you can supply more medicines. And fortunately, as all of us know, during the entire 2020, the number of infections, the number of fatalities in particular in Telangana was far, far below the national average, etc. So AI was of tremendous help in our COVID management strategies as well. But we have been doing so many other use cases of COVID in different government verticals. In fact, as a part of the year of AI 2020, we focused in particular on the agriculture sector. Agriculture remained a very shining spot for Telangana in 2020 and will continue to do so in future also. And we have again identified large number of use cases in the entire agriculture value chain where there are very, very productive AI solutions and tools. And we were doing some back of the envelope kind of calculations the other day. If we are able to show effective results through the application of all these AI technologies across the chain of agriculture operations, then this national goal that we have been speaking about, not now, but almost since more than a decade or so, almost 15-20 years ago, which is of doubling farmers' income, that can actually become a reality, and Telangana will show the way on how that can happen. So I feel very optimistic about how AI is going to make a very big dent in agriculture and in so many other spheres also. So this particular vertical, that the government will lead by example, government will bring lots of AI oriented solutions and tools and technologies into its own processes, is something that is happening quite satisfactorily over a large over the last let us say 15 to 18 months or so. And the last component in our framework is about the governance structure. So I mentioned earlier that AI requires lots of data, AI requires high performance computing, you require manpower, government should take the lead, we should work in a partnership model, and so on and so forth. But eventually we also have to be very, very conscious of the fact that there could be, and we know in the past that there have been cases where people have impinged upon individuals' privacy and confidentiality, and certain ethical lines or certain ethical boundaries have been crossed. So it is also very important that if the government does these kind of things, or if it spearheads a large scale AI related programs or campaign, the responsibility to be very ethical and proper and in complete compliance with all the laws, etc., those are very mandatory. So there is a body which is called the Center for Responsible Use of Emerging Technologies. Telangana government has chosen to partner with CRET, and with their help we are kind of developing a proper framework or a proper template under which all these ethical issues, governance issues are not just imbibed, but there is also a monitoring mechanism and a self correction mechanism to take it forward. So as I said, I am very happy that IESA has has decided to also champion the issue of AI in the semiconductor industry, in the VLSI industry also. We know that software balances the advances that are made in hardware, and amongst software, as I have been repeatedly mentioning, AI is the one which is appearing to be the most transformational. So I do hope that we are able to showcase lots of AI oriented solutions, opportunities, etc., in the conventional areas where IESA is extremely strong, which is on semiconductor and VLSI. I look forward to listening to other domain experts, and as I mentioned a while ago, all the AI work that we have been doing in Telangana has been in a partnership mode. Our role, the government's role, has been to create that enabling environment in which private companies, niche companies, startups, research institutions, academic institutions, even global partners, they all come together and work along with the government in taking the AI agenda forward. So I again would welcome any IESM member or any other individual participant or attendee who would like to join hands with us, who is impressed with what we do, to just reach out to us, and I am very confident that we can together create something that will be really very, very useful. So once again, thank you very much for inviting me for this seminar. I look forward to a day of very rich engagement and productive sessions. Thank you very much.
JSG, thank you so much for taking the time and joining us today morning. As I mentioned, Telangana government has putting so much efforts, and we really appreciate the vision the government has. And as I told you earlier, we took the cue from the government when they declared year 2020 as the year of AI. That's where we got also the motivation to do this summit. So with that, I request all the chief guest and the other speakers from today morning to light the lamp and inaugurate the exciting today event here. Let's go ahead and light the lamp.
Shubham kurutvam kalyanam arogyam dhanasampadah. Shubham kurutvam kalyanam arogyam dhanasampadah. Shatru buddhi vinashaya deepajyotir namostute. Deepajyotir namostute. Deepajyotir parabrahma. Deepajyotir janardanah. Deepajyotir parabrahma.
With that, thank you so much for joining us, Satya and JSG and Sashi. We will go ahead and kick off the session. We'll take a quick few seconds break and start with our first speaker today, Mr. Dado Banata.
Is it my turn?
Yes.
Oh.
Good morning, Dado.
Good morning.
So let me give a brief introduction to Mr. Dado Banata. Dado doesn't need any introduction. Anybody connected with semiconductor industry and Silicon Valley, they do know Dado. Dado claims he has silicon in his blood, and I do strongly believe that we don't need a blood test. Dado is a very successful semiconductor professional and a serial entrepreneur from Silicon Valley. He founded successful startups like S3 Graphics, Chips and Technologies, and Mostron. He held engineering positions at National Semiconductor, Seek Technologies, Intersil, and Commodore International. Dado pioneered the PC chipset and graphics acceleration architecture that continue to be two of the foundation technologies in every PC today. As an engineer, he is credited with developing several key semiconductor technologies and is regarded as a Silicon Valley visionary. Dado is currently the managing partner at Talwood Venture Capital and chairman of the board at Blaze Inc. Talwood invests in unique and hard to do semiconductor technology solutions for computing, communications, and consumer platforms. Prior to forming Talwood, Dado was a venture partner at the Mayfield Fund. He pioneered the PC chipset and graphics acceleration architecture that continue to be two of the foundation technologies in every PC today. As an engineer, he is credited with developing several key semiconductor technologies and is regarded as a Silicon Valley visionary, as I mentioned earlier. Dado holds a bachelor degree in electrical engineering from the Mapua Institute of Technology in Philippines and an MS in electrical engineering from Stanford University. With that, before Dado could address the delegates, we like to play a small video for you.
My name is Dado Banata. I come from the north. My father was a farmer. I am an engineer. I grew up in a typical barrio in Cagayan Valley. Back then, there was no electricity, no telephones. I was taught math by moving bamboo sticks. There were no luxuries. Almost all of my classmates stopped going to school after 6th grade to help in the fields. But my father never asked me to help him. He wanted a better life for me. He made it clear his job was to keep food on the table. My job was to study. I went to high school far from my home. I felt inferior to the other students. They were from the city. I was the son of a farmer. While my friends played basketball, I studied. I fell in love with engineering. I wanted to build things. But when I graduated from Mapua, there were no design jobs for engineers in the Philippines. So I moved to America. I applied for a master's in engineering at Stanford University. I was excited, but I was also so intimidated. Everyone seemed smarter than I was. So I studied twice as hard. I saw an opportunity to design better computer chips, and I started a company. That company failed. No one told me that I could do it. I had to tell myself that I could. And so I tried it again. This time, we succeeded. My success is a direct result of my beginnings. It is the same will and determination that every Filipino possesses. Our country is one of the fastest growing economies in Asia. But over 30% of our people still live like I did growing up. But my life shows a different path is possible. It is why I started PhilDev. We imagine a Philippines where every school has internet, where deserving students are given scholarships, so they never have to stop learning, where thousands of young Filipinos start companies that hire millions more. We know hardship. It's time we learn success. I am not so special, but I am determined. My story could be your story. As Filipinos, it must be our story.
Yes, Dado, please.
Okay. I'm going to read my speech here, just to make it easy for me and for you guys. And I guess it is morning in India now?
Yes.
So good
it is.
morning.
Thank you.
Okay. Well, I am pleased and honored to address this first of its kind online Iesa AI Summit. The focus of this event on driving the next generation of innovation is a rich and timely subject. The age of AI is upon us, bringing with it potentially the most expansive and transformational opportunities for innovation in the history of the electronics and semiconductor industry, opportunities to create and recreate companies, opportunities to transform how technology can solve real problems for businesses, governments, communities, and societies, and new opportunities as a result to enable economic growth of the developing world through technology-based innovation and entrepreneurship. 10 years ago, we, our group, established a foundation called PhilDev, Phil as in Philippines, Dev Development, to work with government and industry to understand and implement solutions for economic growth in the Philippines. PhilDev creates synergy between government organizations, the academe, and the private sector to establish programs that advance knowledge, to utilize the latest developments in science and technology, and inevitably create sustainable and inclusive economic growth in the Philippines. My view on innovation and entrepreneurship as the new foundation for economic development is the result of extensive meetings and discussion with entrepreneurs and friends from venture capital in Silicon Valley business community and industry and academia in the Philippines. This thinking applies to other developing countries as well. The new technology landscape that AI is facilitating opens opportunity for further based economic growth particularly in countries such as India that already have a solid technology industry. This opens doors for innovation, entrepreneurs, and job creation. Take Blaze as an example. Blaze, started by engineers from India, in fact, living in Silicon Valley. Blaze has innovated a new processor architecture, a new way to compute AI workloads. Blaze now has 200 plus employees in India and is one of a small but growing number of pioneering companies doing advanced processor design in India. The company was founded by 4 engineers with a better idea for how to compute AI workloads. AI is demanding both hardware and new software from which users will derive value. It is predictable that a large, good number of AI technology companies are emerging worldwide and will eventually consolidate, as has been the case historically during technology transformations. Large-scale adoption of AI technology as a tool to propel progress and solve long-standing problems is tremendously exciting, both in terms of the betterment of the way we all work and live, but innovation and entrepreneurship to achieve vision for eradication of poverty through sustainable high economic growth based on inclusive innovation. Economic inclusive growth is achieved when companies, capital, people, and ideas converge globally and digitally with government, academics, and private sector programs. Let's take a look at PhilDev, path forward to achieve this goal.
In 2019, there were still 17.6 million Filipinos that lived below the poverty line. They receive a monthly income of 10,727 pesos for a family of 5. That's just 71 pesos per day per person. This means that our journey of eradicating poverty is a continuous commitment, because in spite of the progress, we still lack pathways for the underprivileged, and every Filipino should have the means to succeed. Since 2013, we have created pathways for more than 200 STEM scholars from all over the Philippines. We founded Technopreneurship to give science and engineering students an option to explore the entrepreneurial career paths. Over 539 universities are now offering this course all over the country. To support technopreneurship, we have also built 10 highly functional tech hubs to pave the way for a new breed of engineers who would like to produce and commercialize their innovations. Tech hubs not only enable innovation, but foster collaboration with 74 more cohort universities, industries, and communities. As centers of ideas and entrepreneurial endeavors, budding startups spawn new jobs that help drive economic inclusive growth. Experts from all over the globe were able to help us provide the best support to our university-based startups. Now, what's next? In this ever-changing world, we have to make sure that our future generations have equal access to opportunities and remove obstacles to paths forward. There is a call for bigger and better solutions in education, innovation, and entrepreneurship that are not only scalable, but also sustainable. We will create opportunities where companies, capital, people, and ideas can converge wherever they may be. We will do this by going global and going digital. We envision a world where Filipinos are recognized and represented for their leadership, advancement, and success. This is how we will unlock the global combined power of Filipinos. Donate and become our partner to help us establish long-term, meaningful impact. Let's invest for a better future and continue to build endless pathways for more Filipinos. In
Developing countries with significant enrichment over the last 200 years accomplished it not because of institutional accumulation of wealth. It was accomplished through accumulation of ideas by common people, most of them without means or capital, but liberated from constraints of society, government, or rulers. Essentially, it is a concept of liberty that enabled them to think freely. In present-day language, they are entrepreneurs without capital, but rich in ideas and are free to innovate. Another great concept added to liberty is equality. Both rich and poor were given equal rights to freely pursue development of their ideas. Early on, countries from the West instituted the rule protection of intellectual property rights, and the availability of capital enabled entrepreneurs to take risks, resulting in economic growth that had not been seen before. The capital became productive because of ideas for betterment, ideas enacted by any common man or an engineer with an idea that a search algorithm is valuable, or that a tool for people to get in touch with friends and family would be useful. The coupling of ideas in the minds of common people yielded an explosion of betterments. The enrichment of the poor since about 200 years ago has come not from charity, but from a more productive economy. As important, we must embrace a culture of change and scientific inquiry. These well-proven simple concepts continue to thrive in developed countries today. In full implementation, it will eradicate poverty. Innovation and entrepreneurship are such powerful union enabled by leveraging the technical capability of human capital in all forms of knowledge and expertise in technology development, product creation, enterprise building, and wealth creation. It is therefore the best tool for inclusive innovation where technical knowledge, creativity, or design are valued more than money. The betterment of the next generation is enabled not by politicians, but by engineers and entrepreneurs rich in ideas for innovation. Thank you.
Thank you so much, Dado. It's such a wonderful pleasure to have you with us today morning. Ever since I moved to Silicon Valley, you've been such an inspiration to all of us, and you laid the path for so many successful entrepreneurs in Silicon Valley, and you are such an inspiration to all of us. Once again, thank you so much for taking the time to joining us. With that, we will take a quick break and go on to our next session, very exciting session from a startup called Blaze, which is founded by Dado as well. Thank you.
Thank you for inviting me.
Are we ready? Good morning, Dinakar.
Hi, Venkata. How are you?
Yeah.
Morning.
So I would like to, introduce our next speaker, Dinakar Munagala, and also their company, Blaze. Blaze has been shortlisted as one of the top, semiconductor startups focused on AI. One of them, I think they were rated number one, and they do have an office in Silicon Valley and Hyderabad. So Hyderabad is playing a very key role in their success. And then let me introduce Dinakar as well. Dinakar co-founded Blaze, and he is the CEO of Blaze. And as I mentioned, they are rated as one of the most promising startups in AI space. And we are very proud to have Blaze with us in Hyderabad. Dinakar has more than 22 years experience in the industry, and his experience in successfully leading global teams, building graphics chips for multiple, more than $10 billion programs with recognition for technical excellence, new initiatives and results focus. Dinakar started Blaze with a bootstrapping effort, and he started with creating a more energy efficient processor architecture for the needs of new generation of AI computing. Dinakar has led Blaze in delivering a transformational compute solution that unites silicon and software to optimize AI at scale. Under his leadership, the company has brought together marquee investors to back the vision of the founding team, grown to ship products to multiple customers across automotive and other sectors. Prior to co-founding Blaze, Dinakar spent 12 years at Intel, and he was involved in programs for Intel's next generation multi-core, multi-threaded graphics chips, and the architecture for Intel's first integrated CPU GPU product family. I'm also proud to say that Dinakar is a Hyderabad product with a Bachelor's of Engineering degree from Electrical and Computer Engineering from Usmania University and a Master's degree in Electrical and Computer Engineering from Purdue University. He is actively engaged in community service activities. Dinakar has for 10 years taken a leadership role in fundraising for CRY, Child Relief and You, Vibha, a Sacramento Action Center, a non-profit that supports education projects for underprivileged children, and is an active supporter of Kiva and Vitana initiatives, empowering students and entrepreneurs globally to achieve their goals via non-profit microfinance loans. With that, I invite Dinakar to address the delegates.
Venkata, thank you for the introduction. Let me share my screen. I do have some slides. Please tell me if you're able to. Are you able to see my screen?
Yes, we can see the screen.
Okay. In the presentation mode, right? Just making sure.
Yes.
Okay. All right. First of all, thank you to the organizers of the Iesa AI Summit. Pleasure being here. Good morning to all of you, and thanks for the opportunity to present. Today, the topic of my talk is AI in the real world, how it is beneficial, how it's transforming the world around us, some of the impediments that we face in productizing AI, and how innovation can come together to solve the problem, and then the huge amount of benefits, and also I will contextualize it to India, right? Some of the use cases, some of the huge impact that it can happen to society. So first of all, right, why is AI a big deal, right? If you look at it historically, there have been key inflection points, and those related to revolutions that happened in time, wherein new ways of doing things came up, old ways went away, new opportunities came up, new new industries came up, and created massive impact on economy at each phase, right? Be it the industrial revolution or the electrical revolution. In the more recent past, several of us have been part, of course, of these, which is the computer revolution, the mobile internet revolution, and finally where we are here is the inflection point of AI. And AI is coming. It started in deep in the data center. It is now proliferating to every walk of our life, be it education, healthcare, smart cities, you name it. And it is real and it's huge. We're talking about a $13 trillion kind of an impact on GDP by 2025 worldwide. So let's examine, what are some of the common trends, right, across PC and mobile, and why AI is an equally big, if not bigger. And this is bringing a little bit of, I'm a Rajni fan and a movie fan, just bringing in a little bit of humor into the presentation. This is the common thread right across Rajni using a PC, a mobile phone, and then finally getting AI into our lives. But keeping humor apart, right? Let's really examine what is the key innovation that happened in each of these revolutions and why it's applicable to AI. So if you look at it, fundamentally, the PC revolution happened because of a couple of main reasons, right? The first one being affordable compute, the whole x86 processing power, and making it affordable in the form of a PC. Ease of use software, right? Be it Microsoft Windows, Office productivity tools, how it really helped people to use computers. And then the birth of the internet, which connected all the computers, and that led to huge impact in a way. If you look at mobile revolution that started off, again, it's the common theme is an easy portable device that's in your pocket, having natural UI, easy to understand, easy to use with a touch screen, having low-cost software, right? There's an app for this, an app for this, an app for everything, and how all of this is connected via social networks. You connect to your friends and families, etc., or business circles, right? So those were the key aspects. Now, taking a piece of this and applying it to AI is the most obvious thing to do, and that's how AI will grow. So the first thing is affordable AI compute is a necessity. The second one is really ease of use of software, right? It can't be, it has to be easy, intuitive, and graphical in nature. The third one is keeping your data private to yourself. Data is what drives AI, and how do you protect it and make it private? And having a whole bunch of intuitive, easy to use AI applications so that it truly benefits end markets and use cases. That is a requirement. And finally, there's this notion of self-customizing AI apps, right? So, for example, for healthcare, right? It's not necessary that the same medicine that is good for me is good for a friend of mine, right? It's possible our body types are different. So can AI come to the rescue there? Those kind of things are actually happening right now as we speak in AI. So taking it to the next step, looking at what does it take to develop and deploy an AI app, right? And the steps involved. The first piece is getting data and training, preparing it, and then deploying it to edge computing devices that make AI happen at the edge, and then deploying it into a field. It could be a supermarket, it could be a factory floor, wherever else, a smart city, and using it there for months and making sure that you refine it as you use it, right, based on various local conditions. So that's the nature of the development cycle and the problem. So in order to make this happen, what is needed, right, taking from our previous slide, is an affordable AI computing plus ease of use software. So the equivalent of a personal computer. I mean, the personal computer need not, it's not as important whether the computer is on your desktop or whether it's an instance in the cloud or in a server. But the idea is that it needs to be affordable, and you power it up just like a laptop and it just works. right? Just open it out of the box. That kind of a user experience, and making sure that the user experience is completely automated, code-free, easy to use, and it is connected to model marketplaces. Nowadays, you have a whole bunch of model marketplaces. How do you connect your efforts into developer communities, peer-to-peer networks to get help? Are you connected to things like AWS, Azure, etc.? All of these things are a requirement. So having, again, well-connected software plus an easy-to-use software on top of affordable hardware is going to be a key requirement. Now, take, for example, a retail company that wants to teach some in-store cameras, right, using neural networks or AI to detect potential buyers. And if they're stuck on an aisle, how do you send a coupon or something to help them close a sale? This is a real example that we worked with a retail giant. And there are key areas because of which AI adoption is slowed down. The very first thing is data. Where do they get data, right? So this organization is a brick and mortar entity, and they know the value of AI and how it can benefit them, but they don't have data. How do they get that data is one key impediment. The second one is the programming languages and the UI is highly technical, right? You do need an army of data scientists and machine learning engineers to solve such problems. The third piece is lack of explainability of an AI model. You did, let's say, create something. How do you actually audit it and make sure that it is truly behaving the way it should, right? And finally, somebody high up in the value chain in the organization, like the finance function, before they cut a check, they look at, hey, what is the ROI on this? I invest all this money. How do I recover the costs, right? So these are some of the practical problems that are slowing down AI. So breaking it down into individual pieces, the very first thing is affordable compute. The challenge is that today the hardware that is out there is expensive, right? You do need almost a $200,000 kind of a box in order to train and build AI models, whether the box is on premises or in the cloud. If it's in the cloud, you're paying roughly $1,000 per to develop an app. That's the amount of time it takes to train a model, and it's pretty expensive. You can opt to a lower cost GPU, right? But the challenge then is that it takes a long time to train a model. So these are some of the practical problems. And then once you're done, how do you deploy it to an edge computer that is capable of doing real-time actions, right? Be it a smart city, be it an autonomous car, right? You do need low latency, low power solutions, low thermal that can fit in a certain time envelope and power envelope and act on a certain decision to maneuver around a person, etc. Right? In the case of an autonomous car. So there needs to be this element of low latency, low power, and fully programmable to do a different wide set of use cases. So that's the problem with hardware that we face today. Coming to user interfaces, they're actually quite intimidating. So of course, if there's a programmer who's actively working in the Linux space and they're building AI applications, this is easy, right? You fire up a Linux terminal and do what you want. But think of if AI has to proliferate to different use cases, education, medical, ag tech, industrial use cases, and so on. It's not necessary all of them are familiar with coding in Linux and data science, etc. Right? So this environment can be pretty intimidating. So we need to figure a solution for this. The third piece is data. In AI is completely data driven, and it takes about roughly about 75% of time building an AI application really is because of data prep, data cleanup, making sure it's relevant, and then training it. And very few companies have access to majority of the data. Smaller companies don't even have access to the data that's meaningful through which they can create an AI application that can be helpful for them. And finally, the explainability, as I mentioned earlier. So this is an interesting example. there was an AI model that was used to qualify credit card users for Apple's credit card a couple of years ago. And a husband and wife living in the same roof, paying taxes on the same income, right? So identical. And they apply for this credit card, and the husband gets 10 times more approval to spend than the wife. So and they couldn't explain it. So New York actually got into a lawsuit regarding this, and of course the rest is kind of history. But the point is that there was no way to explain why the AI model did this. So they had to go and manually intervene and change this. In fact, it's not just the couple. I read somewhere that Steve Wozniak, the Apple co-founder, had the same problem. He had, I think, a very different credit score and a limit compared to his spouse. So having ability to actually audit an AI model so that you're sure of the results and is absolutely key. Many companies, all the big companies, are actually working on removing biases like gender bias, race bias, etc., out of AI models. So, of course, we're a young company, and we're doing our part. We're excited about the space, and really proud of our team that we actually have now product out in the market, and this is based on our first generation processors that are commercially available and shipping, and we do have affordable hardware compute that can do low power and high performance AI. Right, what you see here is a palm-sized supercomputer that can do edge analytics. There's also a PCI Express accelerator card that you stick into server chassis for different kinds of AI needs. And the best part is these are all affordable, and they do solve real AI problems in a low power manner. And we didn't stop at innovating at the hardware level. We thought through the whole entire value chain, and how do we make adoption of AI easy in everyday lives. And we went ahead and invested a great deal in the whole ease of use of compute, ease of use software tools. So we built something called AI Studio. And what this is a code-free, completely automated interface where if you have some data, it'll prompt you and figure out what you would want to do with that data. How do you actually create an AI model? How do you deploy it? And the whole ML ops piece of it, wherein you're operationalizing AI for a specific need. It helps you with that whole end-to-end application development in a very automated fashion. And the best part, it's all code-free with a mouse click, almost like a Macintosh experience or a Windows experience, that you could do all of this easily. And there's also the whole data part, and how we're solving it is we're doing many things, but at high level, majority of the AI applications will be pre-trained models. So it's been trained for something, and then you're deploying it and customizing it right at the edge for a specific use case. So we're making all of that happen. These are transfer learning techniques, and so you customize it for a local store or a local industry or a shop or whatnot. Right? So we're providing all the tools to make that happen in an intuitive fashion, and also we're making sure that we're plugging into the ecosystem, right? All the model marketplaces, so that anybody can import models from or data sets from different marketplaces, be it GitHubs of the world or Model Zoos and so on. And we're making sure that the best part is all of this is explainable AI, right? This was the auditable AI part. With a mouse click, you can actually understand how, with a certain data set, a certain model was created, and make it completely transparent, built on open standards, and make it easy to understand and explain, so that the customer actually knows why a certain decision system was built the way it was. So the end of the end result is typically to build an AI application and deploy it out into the field, right from the data to train to optimize, deploy, and ML ops part of it would take months. We're talking about 1+ year to 2 years. We've literally cut it down with the use of affordable hardware and ease of use tools. We've cut it down to days to weeks. Right, fire up the AI Studio, drag and drop, create a certain use case with certain data sets and certain models, and deploy it out, and then manage it. Right? The whole part, we've made it very intuitive, easy to use. You need not be a data scientist, right? It's as intuitive as firing up an office productivity tool, right? Microsoft Excel or Word, and using it. We've made it that simple. So now taking a few real life examples. This is a company that we're working with, where they wanted to examine and understand plant disease, right, at crops. And the way they were doing it prior to us entering, working with them, was they were capturing with multiple cameras images, the project manager, and shipping it back to the back office, where there was a team downloading the images, and there was yet another team trying to apply analytics to the images. Right, so it was a long process, many people, etc. What our AI Studio product did is just with mouse clicks, the product manager himself could rig a single camera with our hardware and our studio to the tractor, and take images right there and examine, customize it, and understand the plant disease real time right there. Right, so there was no more multiple teams. It cut short time, the cost, everything, and made it a reality. Right, so this was possible because of the combination of our technology. Similar situation, applying it to a retail security application. This was a pretty large retail giant that we were working with, and they were traditionally they used security guards to man stores, and then they went to recording videotapes and sending it to a cloud and trying getting people to look at it, right, whether there was a theft or whatever, right, which is very retroactive. What they were able to do without hardware and software is really add the camera real time, develop and deploy an app wherein they could understand theft or people behavior, buying habits, etc. Very easily, right, within an affordable compute, easy to use software. So yet another example how this could happen. And the best part is they were not even data scientists, right, and they could make this happen. Smart city is another use case where everything from recognizing humans to number plates and so on, everything, we're part of such engagements. Now, so the big deal is, it's not about, hey, yesterday at 2 p.m. a car hit a person and trying to investigate the event, but rather we now are able to, with technology, prevent such an accident, right, based on using AI techniques. So that's a pretty huge life-changing benefit that can happen. This is another one which I'm really proud of. Our team at Blaze built this. This was roughly about 1 year ago when COVID was just breaking. And the problem, the challenge was that the sooner you identified a COVID situation and you isolated the case, that was the best way of succeeding. And there weren't as many test kits in many countries. So our engineers were wanting to contribute to the cause, and they came up with this method with just using X-ray images, very simple application where they trained X-ray images to be COVID positive or negative. So you just uploaded an X-ray image from your phone into the app, and it told you whether, and with a click of a button, whether it was a COVID positive or negative. And the best part is they did this within 1 week. Within 1 week, they had this whole thing up and running, right? So such a huge, and we of course offered it up to about 4 different governments to take and use it. But this was pretty spectacular that there was a real problem to be solved, and there was a motivation to solve it, and then there was ease of use hardware and software just to make it happen within a week. Now coming to India, India is a huge country with a massive amount of opportunities, and I'm really optimistic that this will impact us in a big way in India. So for example, the way I think about India is they're all about creative solutions economy, right? That's the acronym I keep thinking in my mind. If you recall, when there was the whole mobile revolution was happening, the concept of a missed call, right? That you'd give a missed call, and that meant some data transmission, that meant a signal to different people different ways. So another example I can think of is during the whole demonetization phase, how all the vendors, or small and big, small shops even, began taking mobile payments. And so where there was a situation and there was a solution to solve a certain problem, it took off in a viral way, right? So there's a lot of creativity that went into it, and ease of use, and that led to huge amount of mass uptake, right, and solved a real problem. So the Indians are inherently very creative at making such things happen. So I'm optimistic that with all the problems that exist, and AI being a technology that can help any of the problems that we have in our everyday lives, creative solutions will come up. Take, for example, agriculture, right? Helping farmers with better crop yield, etc., is a very obvious one, right? And all the farmers are not sophisticated in terms of technology, but all of them have smartphones, right? And remote connectivity is there pretty much in every end of the country. So can there be a way where better crop yield kind of applications are, some research institute or even a college grad in triple IT, for example, in Hyderabad, doing some work and proliferating it in the form of an application to all the farmers, right? Such things are possible. Coming to smart cities, again, this is huge, right? Government has announced a massive amount of investment towards smart cities, and everything from energy conservation to making it safe, preventing of any terror attacks, right? Catching terror ahead before it actually happens, detecting those things. Water conservation. So many benefits are bound to happen. Healthcare. In India, right, all the major cities have stellar healthcare, right, in the form of super specialty hospitals. But the moment you go to towns or villages, there are no specialty hospitals or super specialty hospitals. So can AI come to solve this need, right? Potentially, a junior doctor with the help of an AI model diagnosing a certain disease, right, doing majority of the work that they can do right there. Helping the AI model even help with prescribing the right amount, medicines, etc., taking care of as much as they can right there. And what they cannot solve and what requires super specialty hospitals are what is sent back. So really, healthcare can be benefited in a huge way. Families can be benefited, I believe, because of AI models and techniques. So the whole power of this transformation and impacting society is you could be a doctor, you could be an educator, a biologist, a financial advisor, or whatnot, any other field, and you have your problem to solve, right? Decode X-rays, to using robotics, to analyzing your stock portfolio, whatnot. But you don't know how to program, right? You do not have 200K to spend towards AI, a hardware box doing AI, right? Not do you have the time, right? So we believe all of these can be solved by having affordable computing, and ease of use software tools to adopt AI and make it very intuitive, very easy, just like a code-free environment, drag and drop, build applications, develop and deploy, and solve a real problem that matters. So we are really excited and feel blessed to be part of this momentum. And I'd like to, again, thank IESA for the opportunity.
Thank you so much, Dinakar. It's been, it's such a wonderful speech, and we are especially, excited about the opportunities you've been talking about, the kind of AI applications that can be, used within India, and so it's definitely a very exciting and educative speech from you. We have some interesting questions from the audience. And we do have time to take a few questions here.
Sure.
So how critical is the software for AI and ML company? I mean, you are supposed to be a chip company. That's how you started. I think you were making your own chips and getting them fabricated. So how critical is the software portion to your company?
Extremely critical. Right from day one, we chose to invest deeply in software. So let me back up a second. So we had this vision all along that in order to solve multiple problems in diverse use cases, first of all, you need a programmable hardware processor. So we did that, and then after that, we made sure that there's ease of use software on top of this, right? So to make sure that the software, because software is ultimately the piece that customers and different industries, different people actually experience. So we made sure that we invested quality time into tools and made sure that it's really easy. And so we believe truly having a programmable approach with ease of use software is key, and that's why we invested there quite a bit. In fact, vertical solutions to specific industries is something that we're partnering with other end system integrators or companies. But yeah, that's how important software is, right? That's where the value extraction happens significantly.
Thank you, Dinakar. Thanks for the clarification on that. So I have another interesting question, actually a couple of questions. Let me see if I can club them into one question. So how do you make money as a company? Do you sell systems or you sell chips? Or how many chips you've been selling? This is a question from one of the audience, but I don't know if you can really answer that, being a startup company.
Sure. So we are a systems company. The products that I showed in one of the slides earlier are accelerator cards and modules. The end products are that. Into some automotive applications, the business models are slightly different, how you actually get integrated into the car, because there you cannot really sell a module, but rather you're integrated into a powertrain or whatnot in different ways through our automotive partners. That's a different business model. But by and large, we're a systems company, hardware plus software to make things happen.
Thank you so much, Dinakar, on that. And I have one question from IESA. Naturally, you have a large operation in Hyderabad. I believe you are around 200 engineers now and still planning to grow. And we like you to be successful, very, very successful, and pave the path for many startups like yours in Hyderabad. So what kind of role either IESA or government of Telangana can play to make you successful?
So first of all, thanks for the kind words. We look forward to being part of IESA and growing the local ecosystem. We're part of the team, right? It's as much as we want to do for IESA that we expect from IESA. But I think the whole idea is about how we make it easy for companies to grow in the region, and which a lot of it is already happening. There are a few things that come to mind in terms of I think we should definitely have a longer conversation, but things like fostering programs for innovation, getting more maybe research from different universities worldwide, etc., right, and making things happen here, because the combination of research, investment, right, private investment, and entrepreneurism, it's like a circle, right? One fuels another. So it will be great to see how we can make that circle happen in India. So I want to be part of that. And IES has been great ever since we joined IESA. I get a lot of information from all the programs that are being put together. So really, good work that the committee is doing. And yeah, that's pretty much it, I guess.
Thank you, Dinakar. We will continue to work with you and provide you whatever support we can. And
sure.
We wish you the best. And
thank you very much.
With that, we like to take a quick break and invite the next panel discussion. Thank you so much, Dinakar. You have a wonderful day. Bye-bye.
Rockwell Collins is a leading provider of services for the avionics and defense industry. What we really provide our customers is safety. The end markets for Rockwell Collins are to provide radios for our government customers, for the warfighters, as well as navigation products. On the avionics side, for commercial services, we provide flight controls, flight displays, as well as radios for commercial aircraft. Rockwell Collins is known for being a trusted supplier, so that when you know you need to make a call go through, when you're on the battlefield, that it'll get through. We also provide safety and reliability for aircraft. These aircraft fly 7 days a week, 365 days a year, 12 to 16 hours a day, and they always have to work. Under the DARPA Arrays at Commercial Timescales program, we're revolutionizing the way that arrays are produced and fielded. So instead of having very specific layers that are tailored for specific applications, like radar or communications or EW, we've developed a common module that can be used for many different applications and over a wide range of frequencies. We've recently completed development and testing of our Phase 2 common module, which covers 2 to 18 gigahertz of bandwidth and has up to 8 beams of digital beamforming. The Advanced Technology Center at Rockwell Collins looks at technologies 3 to 5 years ahead of our product developments. As part of this, we work with government labs such as DARPA, Air Force Research Labs, the FAA, and NASA. So one of our philosophies on our approach to the DARPA ACT program is to leverage leading technology like the RF system on a chip and pair that with custom devices that we develop like the SIGI transceiver for the ACT program. What makes the RF SoC a game changer is that the A to Ds and DACs are integrated along with the programmable logic. So we don't have to spend a lot of extra time using JESD 204B to get all of the data back and forth between the converters and the fabric. We're pushing almost 300 gigabits of data per second under our solution, so this greatly reduces the amount of design time required for integration. Having the data converters integrated with the programmable logic allows us to focus on our algorithms for beamforming development rather than integration of the data converters and the programmable logic. Another advantage of having the data converters integrated with the programmable logic is the reduced power consumption necessary to get the data off of the converters into the programmable logic. Something else unique about our approach to the DARPA ACT program is not only do we intend to put the common module in our Rockwell Collins products, but we want to work with other customers to integrate it into their products as well.
Okay. Are we ready?
Hi, Venkat.
Hi, good morning, Sambit.
Good morning. Can you see me?
How are you doing?
I'm doing well.
Hi, Mohammed. Good morning.
Morning.
Tushar, good morning.
Hello, good morning, everyone.
Good morning.
Good morning, everyone.
So let's, do we have more panel members to join?
No, I guess 5 of us. All excited, I guess.
I only see 3. Okay. Okay.
We are excited.
Yeah.
Like, okay. Good morning, everyone. Good morning, Gopi. Now I see everyone here in the playlist. So let's get started, and I will start with a quick overview of the very exciting and very interesting panel discussion we have today morning. See, the artificial intelligence applications, right? They need a lot of computing and memory. So there is a continuous debate on what is the best way to process AI workloads, whether we do it in cloud or edge. Cloud computing. Okay, I'm getting a resound here. Cloud computing means using remote servers or data centers for storing, processing, computing, and analyzing massive amounts of data. And panel discussion will focus on challenges and the best solutions. So I'd like to introduce our chair for the panel discussion, Mr. Sambit Sahu. and Sambit will in turn be introducing the other panel members. Sambit is currently working at Intel Bangalore, and he is the VP and GM of IoT and High Velocity Silicon and Platform Engineering Group. And his group is spread across the globe at Intel Corporation. Sambit has been in the semiconductor industry close to 30 years, and Sambit has held a number of technical and leadership positions in multiple areas of SoC design. He led teams delivering dozens of products in various market segments, including smartphones, modems, IoT devices, small cell products, and intelligent routers. Before joining Intel in 2016, Sahu worked at Qualcomm as a vice president of engineering at their Bangalore design center. Sambit spent close to 13 years in US before moving back to Bangalore, and he started his career at Intel and worked at other companies like Sun Microsystems, Rocket Networks as well. Sambit has broad experience in EDA tool development, IP development, and large SoCs. Sambit earned his bachelor's degree in electronics and telecommunications from the University College of Engineering, Barla, and master's degree in computer engineering from the University of Louisiana at Lafayette. So I request Sambit to kick off the panel discussion. Thank you, Sambit.
Hey, thank you, Venkata, for the kind introduction. Good morning, good evening, good afternoon to all the people worldwide. Very excited to be part of this panel discussion, Edge versus Cloud. And Venkata, as you said, this is a continuous debate, and this will continue for some more time. And I would like to take this privilege to introduce the very illustrious panelists. First of all, I want to introduce Mr. Tushar Kant, a co-founder, Global IIT Artificial and Machine Learning Forum. Tushar has more than 20 years of industry experience across Silicon Valley and Wall Street at Amazon Web Services, VMware, Facebook, Intel Corporation, Sun Microsystems, Bank of America Securities, and G Capital. He has worked in diverse fields spanning across product management, software development, investment banking, private equity, and venture capital. Tushar has a BS in electrical engineering from IIT, MS in computer science from US, and MBA from NYU Stern School of Business. He has publications in artificial intelligence, high performance algorithms, and bankruptcy and reorganization. Welcome, Tushar, to the panel. Next, I would like to... Sure, welcome, very warm welcome. The next panelist I would like to introduce is Professor Muhammad Sabri. Muhammad M. Sabri Alai is an assistant professor at Nanyang Technological University, Singapore, and the founder of EMAS. He received his PhD degree in electrical and computer engineering from École Polytechnique Fédérale de Lausanne in 2013. He was a postdoctoral research fellow at Stanford University from 2014 till 2017. His current research interests include system-level design and optimization of computing systems enabled by emerging technologies, with particular emphasis on computing systems for artificial intelligence. His work on system-level analysis on data-centric emerging systems has led to a $75 million DARPA program. He is currently the program manager of the Singapore flagship AME programmatic project, which is a hardware-software co-optimized for deep learning. He's an active close collaborator with top industrial and academic partners such as Stanford University, TSMC, and Samsung. Dr. Alai is a senior IEEE member, and he is a recipient of the Swiss National Science Foundation Early Postdoctoral Mobility Fellowship in 2013. Welcome, Professor Muhammad, to this panel.
Thanks so much for that kind introduction. Thank you so much.
You're very warm welcome. Next, I would like to introduce Kavita Prasad. Kavita is the Vice President of Business Development and Systems Application at SEMA.ai. Through close collaboration with customers and partners, Kavita is responsible for defining the system-level architecture for SEMA AI's machine learning SoC. She has experience across system applications, system architecture, business development, and engineering to deliver AI and machine learning solutions to computer vision platforms in smart vision, robotics, and autonomous systems and automotive markets. She's a technology leader with over 22 years of experience in delivering multiple successful products in ASICs, SoCs, FPGAs, and servers across multiple process nodes. Prior to SEMA.ai, Kavita was responsible for system solutions across embedded market segments for the Intel Platform Solutions Group, among other positions in Intel. Prior to Intel, she held multiple technology roles at Xilinx and Philips. Kavita holds a Master's of Science in Electrical Electronics Engineering from San Jose State University. Welcome, Kavita, to the panel.
Thanks a lot, Sambit. Thanks for the introduction.
Very warm welcome. And last but not the least, I'd like to introduce Gopi Srineni. Gopi Srineni is the CEO of Axiado and a Silicon Valley veteran with over 25 years of experience in the semiconductor software and systems industries from companies like Qualcomm, Marvell, and Applied Micro. As a senior executive, he has demonstrated exceptional skill at building highly efficient, cost-effective organizations, managing rapidly changing environments, and bringing industry-changing technologies to market. Welcome, Gopi.
Thank you, Sambit. Thank you for introduction, sir.
Hi. Okay, great. And I'd like to take this occasion to thank Iesa for really giving us this opportunity to do this panel. And I'd like to request the audience to post their very exciting or challenging questions for this panel. We will reserve last 15 minutes to take on the audience questions. So please keep posting. And with that, I will just introduce this topic, and I will let the panelists jump into it and have a very good debate. So as all of us, probably all ramping up and probably very excited about this AI growth. This is the biggest revolution that is happening as we speak. I think the biggest revolution I have seen in my 30 years of my life. It's pretty much touching every aspect of our lives. It's so big. And the good thing is that it has its infancy of the revolution. I mean, next 30 years, people will all be speaking about AI, and AI. And today, as far as I know, practically every technology company is investing a lot of their effort and energy into this AI growth. And according to market research, this combination of AI, IoT, and 5G or next generation communication technologies is supposed to trigger a $17 trillion economy worldwide. I mean, that's the magnitude of this AI. And this AI, it has four aspects. I mean, that's what today's AI, it may evolve later on. It has four aspects. One is, how do we ingest meaningful data for AI processing? There is so much of data, and how do we get meaningful data? The second is, how do we use the data to train and generate a good model? Okay. The third piece is that once you have the model, then how do you infer and get some intelligence? There's the inference piece. And the fourth piece is actions based upon that inference. So these four pieces. And this AI requires a lot of processing, requires entire systems to be built, a lot of innovations to happen, a lot of technologies to be built, and a lot of aspects like security, privacy, ethics, all kinds of things. And the other phenomenon that is happening is, traditionally, we have taken data to the compute. We have taken data to the compute. But in this AI world, we have to bring compute to the data. You have to bring compute closer to the data. Now, to do this AI, there are three significant paradigms. One is your end devices like your sensors and actuators, your smartphones, your wearables, which is very close to the data, but they have very limited processing capabilities. On the other side of the spectrum, there is a cloud, which has huge computing capacity, but it's farther away from the data, and may not be suitable for mission critical, latency critical applications. So now something called edge is evolving, which is between these end devices and the cloud. And this edge is supposed to bridge the gap that exists between the end devices and the cloud. Today, end devices is a no-brainer. We need end devices. We need things to sense. We need things to act very limited way. Okay. But the debate is about whether it is for the future, whether it's going to be cloud, is it going to be edge, is it going to be both? What is it going to be? What is that going to be that will revolutionize this AI for the next 30 years? That is going to provide the quality of service, that's going to improve our lives. That's the debate. And with that, I'll open up the panel for discussion and their perspectives. I'll start first with the order that I went through the introduction. I'll start with Mr. Tushar Kant.
So, Sambit, thanks. Go ahead.
Yes. So what are your perspectives about this cloud versus edge? And what do you think will be the future? Is it going to be cloud only, edge only, or a combination? And why so?
Right. First of all, Sambit, good overview of the overall topic. And, right now, the way we stand, it's a combination of cloud and edge, right? Good part of training for the models, one of the 5 steps you said happens in the cloud typically. And, a lot of inference happens at the edge. The interesting part is, there's a lot of companies, including some of them which are sponsoring this conference, like Qualcomm, who spent a lot of money trying to build technologies for the edge. On the other hand, you have companies like Xilinx, which is again a sponsor for this conference, which builds FPGAs, which are bought by cloud providers, which is used for model training, right? Along with GPUs from NVIDIA, Intel CPUs, Ultra FPGAs. Now, one interesting paradigm which is happening is, with a lot of data getting generated at the edge, good part of inference and maybe some training or what is called federated learning may happen at the edge, where you basically have models getting trained or getting updated at least at the edge. Now, what is preventing from edge to be very, really robust or very active right now? 2 things: compute power at the edge and the network bandwidth speed between edge and the cloud. So let's see how that is going to transform over the next 5 to 10 years. The compute power at the edge is improving slowly and slowly with new processes coming in, better capabilities coming in. And the network bandwidth is going to go through a revolution through 5G. So the combination of 5G and improvement in compute capacity at the edge will change the dynamics. So there are some underlying technology forces which is going to change the dynamics to some extent, where it would be still a combination of cloud and edge. We'll still have centralized training of models in the cloud, but we'll have much more federated learning, federated training of models at the edge. Inference will become better. And that's the way it's going to evolve over a period of time. So that's what my, what you can say, an opening gambit in terms of how I feel systems are going to evolve and why they're going to evolve that way. Thank you.
Excellent, Tushar. Really great perspective. And I'll now go to Professor Mohammed with the same question. What are your perspectives of cloud versus edge? What will be the future? Cloud only, edge only, combination, why so?
Right. Okay, thanks a bit for it. And Tushar gives actually been a very concise answer to this question, but let me try to see if I can add to his really succinct answer. So there are aspects in the cloud that you will not find in the edge. Which is basically you have the ability to collect data from like millions and trillions of these devices. That surpasses a lot. So there will be use cases that the cloud will always win, which is basically in training really sophisticated data. And also when the cases like you have models that are very large. So if we look at language translation models and all that, they require parameters in terms of billions. So talk about like gigabytes of memory just to load the model itself, not to perform computation. So this is a place where the cloud would still have an edge for the next 5 years. The cloud, sorry, yeah, have an edge over the edge, yeah. So if you look at the other side, right, if we're trying to apply now, where an edge is benefiting nowadays is actually in infinite learning and in inference more often than that. What is limiting nowadays that the edge takes full-blown power, right, is that you cannot really run really sophisticated models on it, right? And the reason, there are two things. One, you are mostly limited by the battery power, right? So you cannot really put processors with high performance, right? Because they will just deplete your battery in no time. The second, even if you put that, your problem will be also in memory. So if you cannot really put large amounts of SRAM, you cannot put really large amounts of DRAM. If this, I mean, small footprint, so you're going to be limited with flash, and flash is slow, so you're going to be hurting the performance. And the idea of putting inference at the edge is not functionality, but actually more in latency sensitive operations. So for example, you're doing autonomous driving, you don't want to be sending your video feed, right, through an unrobust network, and then when the detection comes, it's too late to detect a pedestrian and you already have an accident that's happening there. So for now, so there's a fundamental problem in how to really unlock this true potential of the edge. So to find the solution to make the edge really achieve its full potential would be in innovations across the software and the hardware stack. So in the software, like the models that we have right now, if you look at the progression in time, previously models would be like in hundreds of millions, right? For, let's say, for image classifications. Now it's been dropped significantly to a couple of million parameters. So in time, you will be able to get this down to a really, really small networks that can do really sophisticated things. So that will take its time. And you want your software to do not just simple image classification, actually do even more sophisticated aspect and become more efficient in doing so. So that part, but also you want the technology support to help you with that. And this is where it comes in, like really new cutting edge devices for processing logic and for storage and for integration. You need to work on the three aspects. If you see the foundries that nowadays they're pushing, like when Moore's law is running its course, we're talking about 3 nanometer coming up very soon, and then people are asking what's next, right? They're looking into aspects of 3D integration. How can we increase the footprint? We're looking into how can we get some of these really fast non-volatile memory, right? So it plays a nice gap between the DRAM and flash, something of that sort. We have seen the Intel Optane DIMMs, I mean the 3D crosspoint, but they're trying to get it on chip for edge devices. You're looking at also, like, for some people look into like what kind of logic devices that we can use apart from silicon CMOS that can bring in like more performance at the same power budget. So once you're doing all this, right, the edge device would be unlocked, and then you'll be able to do a lot of more sophisticated applications there. You'll be sending more even relevant information for the cloud. So that makes the models on the cloud even more sophisticated, right? Because now they're dealing with not just with raw data, they're dealing with processed information that they get deeper insights if I'm having trillions of these sensors together. With the help of the network, the whole cycle of doing inference at the edge, sending it to the cloud, getting an update of the cloud, sending it back to the edge, getting more insights will be much faster than it is nowadays. So I'm still, I'm agreeing with Tushar on that front that it will be cloud and edge, but we will see more of the edge than we see more of the clouds in the upcoming years.
I see. Great insight, Professor Mohammed. Now, Kavita, what's your perspectives on this cloud versus edge, and what's the future?
I do agree with Professor Mohammed and Tushar a lot. I think I do agree with their perspective. But let me add my spin to it. If we look at the AI landscape today, training to a large extent is a very well understood problem, and to a great extent is a solved problem. But when you look at inference, it's not there yet. Deploying the trained models at an application level is more than just running one benchmark and publishing the KPIs. It's a combination of trained models, one or many, running together concurrently or serially with other application logic like pre-processing and post-processing to make it a holistic application. It could now be a computer vision application, or it could be recommendation systems. And now with also the advent of 5G and the number of sensors that are being deployed in the market, and also the smart devices that are being deployed worldwide, the amount of raw data that is being generated is vast, actually nearly almost zettabytes worth. Now imagine sending all this data to the cloud to do some compute and get meaningful analytics out of it. I do see some problems, significant challenges with this. One, this is going to be expensive. Connectivity, storage, infrastructure, all that is going to cost. Two, some of these applications are latency sensitive and safety critical. By the time you send this data to the cloud to process, analyze, decide, and communicate, compute and communicate back to the remote locations, the ground truth could have just changed. So whatever actions you want to take on the ground truth is no longer valid. Three, and some of these remote applications like say oil rigs or you're in battlefield, they may not even have the connectivity to send the data to the cloud. What will happen then? They have to collect all the data and then they have to go to a base station where there's connectivity available and then download that data for analytics. So if you want to do any predictive analytics or any real-time applications and real-time decisions, that makes it impossible. So if you ask me what is the right answer, cloud or edge, I think the answer is simply both. Like, for example, there are certain tasks that are very well suited, say like training or running power-hungry workloads, or like Professor Mohammed said, workloads that require lots of diverse data from multiple sensors, like say, for example, genomics, or non-latency critical workloads. That's where cloud will continue to play a huge role because we get flexibility, scalability, and general purpose compute to run large models. But then there are other certain tasks that are well suited for edge, say autonomous driving, drones, or re-identification, which are latency critical tasks where the decision needs to be made locally, and only high fidelity data based on those decisions gets sent back to the cloud, where you can do more analysis to create a continual learning loop as the cloud can now fine-tune these trained models based on the new set of data. So with edge getting immediate data, with edge we get immediate data processing, security and privacy, and better customer experience. But having said this, Sambit, what I really see is that there are many challenges today in deploying trained models to edge devices. The number of models that are getting generated today using various frameworks is only exponentially increasing. And also the different kinds of edge devices are also growing. Now, deploying these trained models from the edge seamlessly on various hardware platforms is not an easy task, and it may lead to performance degradation, productivity hits, and also portability issues. And that's where I see a lot of these industry, well-known companies in the industry like Amazon Web Services or NVIDIA or Microsoft, they are pivoting to creating a seamless path from training in the cloud to deploying at the edge. And that's where frameworks like TVM are also helping with optimizing and auto-tuning these trained models before deploying them on the edge devices. So how do I see the AI landscape playing out? I think cloud and edge will have their own roles to play in AI. They are going to be complementing each other. Cloud has scalability and flexibility, and for latency sensitive and safety applications, edge will play a huge role. Exponential growth of sensors will necessitate moving a lot of these workloads to the edge. And the key for any of this to succeed will be to build a seamless integration infrastructure where trained models from the cloud can be easily deployed on the edge, and meaningful data from the edge gets sent back to the cloud to enable fine-tuning of the learned models. So creating a continual training and inference loop. So that is my view of how this whole AI is going to play out in the near future, Samit.
Excellent, excellent perspectives, Kavita. Very nice. And now I'll move to Gopi. Gopi, the same question. What are your perspectives? I have got 3 agrees. I hope you disagree.
Yeah, we need an opposition for a functioning democracy, and both India and US are democracies. So.
Okay, so I'm not saying I'm going to be just for the sake of the changing the other party. That's not the case anyway. But as everybody explained, I'll be short. I think you guys covered mostly already. We don't need to repeat any of that. I think it's going to coexist. But let me give you the little bit different perspective of what we work on. Right? Everybody so far talked about, and pretty much the world talked about, AI means it's nothing but a computer vision base. Everything is a vision picture, inferences are based on that, how much fast you can do it, and all the examples, how the presenters talked about. What I've been doing almost my career is whether you call this is today the AI or not. It's technically word AI is just decision making and all that rather than just a computer vision based. So I'll give you an example of previous company, and I'll tell you based on that how this combo works. Qualcomm, if you're using a Wi-Fi mesh, that is, if it doesn't work, you can blame me. That's my brainchild to do it. If it works, okay, thank you. But when we started doing this, if it was a simple router at home, people were paying $100. That's good enough to be working. Even sometimes it's $20. But the word of what just Kavita talked about, right? By the time the decision goes to cloud and come back, an enterprise AP and access point deployed to the world, and mostly something called spectral analysis means you have to be able to survey that how many clients are out there already and what channels are they sitting there, which channels are open for me. So we assign the particular user. That's why in olden days, compared to the home network Wi-Fi versus the cloud enterprise-based network will work better because that's a managed one. So he's managing to the cloud. But the problem is if you have 100,000 people at a train station, there's no way the model is going to go to the cloud and be able to do by the time the guy moves coming out of the train. Like take a VT station. People coming out of the station, everybody's phone is going to start connecting to that AP, trying to figure out, and you got all the channels are already gone. By the time you decided, everybody's gone. So that's never going to work that way. So he has to be able to do. That's what the distributor Wi-Fi, which is a mesh today, means everybody at their own, and you have to be able to cover in own proximity of that. And then all you need to know is exactly around you. That means you take a 6 diagonals or a 4 diagonals, however you're going to take it. All you need to be aware of those 6. And then you cover this and then hand over to them. And then all this is kind of mushroom out to be, and all this data collected to the cloud, as everybody said. We can take the models on the cloud to try to say, okay, what is the default is going to look like? That starts with, but its self-training is mostly going to work. That is the biggest one to do. I agree with Kavita. There's a lot of models need to happen. This is an exponential. I'm actually inserting something. There is a 0 models exist today, which is everybody worked on all universities worked only on a computer vision base. Nobody worked on a network element base. We had to build from ground up. Literally every packet we need to be able to build. So hopefully that will also innovative comes up, and then we'll be able to make. Maybe the next round I'll talk about security and all that stuff, but an agreement for me is saying that it is going to be collection of data has to happen on the edge. Some local decisions has to be done. Compute powers, I don't know whether I agree that that's not there enough. Battery is not the edges we're talking about. That's not a tiny AI or tiny ML. We're talking about a little bit bigger. The edge we're talking about are power boxes. So when you say power boxes, computing is exponentially increasing, including Kavita's company is also doing that. So a lot of people, once upon a time, dual core, quad core CPUs are, that's greatest, biggest thing is our PC. Your phones are bigger than that now. And every end devices, and one of the Belize or whatever the company was showing a small packet that must have 100 and 1,000 cores in there. So it will be, compute is coming to the end. And I think somebody, you said that too also. And with that, I believe a lot more data additions has to happen local. Doesn't matter if 5G connectivity or 100 gig connectivity comes up, you still need to be able to, you will be exploring that data. So it'll coexist, but I think we're all saying same thing. Bigger models has to go cloud, and then maybe initial models comes from the cloud.
Okay. Excellent. I think somewhat there is consensus that both cloud and edge will coexist for at least the next few years that we can envision right now. And there needs to be a lot more action, a lot more innovations on the edge, as I see, because of the latency, the security, the quality of service, a lot more innovations to be done there. And yes, we are all riding this very exciting journey, which is going to be there for next 30 years. And with that, I will jump to my next question. Because so many companies are innovating every aspect of this whole AI thing, edge, cloud, sensors, everything. I mean, I read some literature that the amount of compute that AI needs is, the demand is doubling every 4 months, whereas your Moore's law can deliver double the compute every 2 years. That's a huge gap. And that gap I don't see coming down anytime soon with the explosive AI growth. So my next question will be, what are the top 2 or 3 disruptive or really big technologies that we should all be investing into? What are those really? I heard things like federated learning. I heard explosion of sensors. What are the three top few big areas that we should be investing into? We can start with anybody, and then
I can
others
say the first thing.
Yes.
Sorry, maybe I start talking. So okay.
Yes, please.
I can start saying the biggest thing is ignored in the market right now is the security. That's why our company started working on. So doesn't matter whatever you're talking about, whether it's a cloud or edge, there's lots of data. Okay, some other critical data, some are health data. We're talking about personal data. Is there biometrics itself? Is there banks, finances, everything? I mean, my grandfather has to now forcefully do online banking. He doesn't even know what that means. Okay, and people can steal his keys, words. All it needs is they are so much sophisticated that just a link comes up. You just need to click it enough for his authentication. That's enough. The one weakest link comes to the whole bank is opened up for the guys to do it. So what I think innovation need to happen in security. What we are doing in a piece, I can tell you, I can give you an example. All this cloud, so-called zero trust, has an example is something like a badge. You have this badge, you see all this white badge. There's a small number in here, it's assigned to Gopi. But even if you put a bigger security guard in front of the building, all he cares about is saying, I got a badge, actor normally coming in, and then this badge can be Gopi's today, but maybe tomorrow Sambit comes out, he can be able to do that. He's not even checking and all that. So that's exactly what's happening in the security world. All this zero trust and all that sort of cloud authentication happens based on something called platform, something called root of trust. So it's kind of, I consider that as an ID for each platform. Unfortunately, that is become a default. Earlier days, network side used to be the MAC, but this time it's a platform root of trust. And one, they've been programmed wrong, and the other one is somebody stealing it or bypassing it, all kind of combinations, you'll be able to do that. So it doesn't matter how big of a computing engine you put it on the top, if somebody already got the badge in and it's inside out, he can open the door he wanted. So in that particular case, you do need on the edge, definitely every platform has to take care of itself, just like Kavita talked about it also, all the computing, all the models enabled to. So the badge example I talked about, you don't need to know, the platform will know you coming from the door. Gopi normally comes up whatever the time. So it profile build up already in a door number 1, and Gopi only comes up at this time of the time, and he walks in this way versus somebody coming as a Gopi doing it differently, different time, different things. So you can be able to complete anomaly detection, able to find, and at least you start with the double authentication to go and make sure that that is right, video authentication, picture authentication, etc. And then that data goes to cloud to be able to do. So I can give another example. In olden days, you had to get the operating system as Windows. You had to download or whatever, you put into your CD drive and then install onto your laptop or PC, and then it goes to next to the Windows Word and all that. What changed with Office 365 is there's more of a business model. Went to the cloud directly. Every time you turn on, he goes to authentication into the cloud for Microsoft Server and gives you an authentication. But that changed a lot more. Now every session gets an authentication rather than a one-time authentication for your laptop. But I can tell you, what does it trust? It trusts your platform, means that laptop is yours, and laptop says it is what it is. And the same way the other side. I can kill that whole process by simple way. Put a simple malware in the laptop, telling that every time our laptop is trying to go connect to something in a cloud server to get an authentication, I can tell it to go to a fake server, and then always gives an authentication. So laptop thinks I got the authentication. The other way around, and now the cloud server thinks like my laptop is mine, but it's actually Sambit's. And it's always things that are given authentication. So both places, you need a security, you need an authentication to protect those. That's what we're doing, not just a fixer one, it's a behavior also. I don't think we see any company spending on money at this point. I think it's a hardware based. Exactly what the edge AI need to work on a computer vision base. I think the security side also need to come in. I hope more companies and more innovations will come up. We're just a beginning on that part.
No, excellent point. Yeah, I just want to give one. Yeah, excellent point, Gopi. I'll tell you, I'm facing the same situation as you said about your grandfather. There is a lot of old age population in India, including my father also, and they have to do things online. And but they don't feel secure. They don't feel secure. So I'll go to Tushar. Tushar, go ahead.
Yeah, first of all, I'm really jealous of both of you that your grandfathers are around. Mine is not. So that's one thing. But second, Gopi, you brought a very interesting point. You talked about security for AI, and then for behavioral model, we needed AI for security. It becomes a loop which goes on, which is very interesting perspective. I'll bring a very different perspective. This is more from the software side. You all must have heard of something called GPT-2, GPT-3, GPT-2. These are very powerful artificial intelligence models for natural language processing being built by a company called OpenAI. The key point there is over a period of time when training these models becomes really tough, and it requires a huge amount of compute, it will go more towards what is called utility model. Everybody does not produce power in their home. Similarly, every company will not be training models. We'll have pre-trained models like GPT-3, which Microsoft has licensed, and most of the people will basically use these pre-trained models to build on top of it. That's going to bring down the compute needs to a great extent. That's the reason me, you, Kavita, Gopi, we do not have to buy, or Muhammad does not have to buy a generator and a turbine for our own homes. So that's the fundamental shift. The interesting thing is, remember, AI became so democratized and popular because of cloud computing. Let's not forget it. Cloud computing and AI paradigms have been always going together. Cloud computing made storage and compute cheap. That's why AI became so pervasive. I did my undergrad and master's thesis in AI 20 years back. Nobody was giving me a job in AI at that time. So same cloud computing will basically now come in form of pre-trained models, which will be owned by some of the bigger cloud providers. Others will basically be tying to it and leveraging that to build things on top of it. Now, with edge becoming powerful, you can basically do that. And as a matter of fact, to continue Kavita's thought process, we won't even need to send this back to the cloud because that's a pre-trained model. We will download our own version of the model and work with our own applications going forward. And that will bring down the necessity of communicating back and forth. I'll have my own, because think about this. GPT-3, for example, is trained on everything which is on World Wide Web for natural language processing. I don't need to basically go and, again, improve that loop. My application may be only focused on retail or manufacturing or healthcare. I can take that model, develop something on top of it, work with the edge. That paradigm is really going to move forward, and people will be focusing a lot on developing AI applications which are focused on their own needs. And they will be different for different industries. That's the way, that's another paradigm, which is basically a combination of pre-trained models with cloud computed, pre-trained models with cloud computing, with a lot more specialized models developing on the edge. That's how I'm looking at it.
Yeah, excellent, Tushar. Yes, this GPT-3 is very exciting, and hope it solves the compute capacity problem that to some extent. And Tushar, by the way, 30 years back, I did my master's thesis on neural networks. I also didn't get a job on neural networks, and now it's
exactly me too. Yeah, I interviewed with Motorola in '99 and explained them my master's thesis in artificial intelligence pattern recognition. The guy listened to me and said, "Do you know multi-threaded programming in Java?" Yeah. I'm like, dude.
Excellent, excellent. Any other perspective?
I can add a little bit of color to what also to add to what Tushar and Gopi mentioned. The key thing, if you really look at the AI, it's a very interesting area. The number of sensors, let's just take a look at the number of sensors. You have radars, you have LiDARs, you have cameras, you have depth cameras, you have 4D LiDARs now, you have all kinds of cameras, all kinds of sensors. And then you have all kinds of frameworks. Somebody says PyTorch, somebody says MXNet, Onyx, you name it. There are all kinds of frameworks. Then there are all kinds of models that are getting generated, some object detection, object classification, semantic segmentation. So if you, and then the applications are all, again, a computer vision applications, some of them are recommendation engines, NLP-based applications. So if you really think about it, it is a wide variety of variables that you're talking about. And now let's look at the edge devices, right? Blaze has its own product. We are creating our own, SEMA is creating our own product. There are so many of these edge devices in the market today. So you trained a model with your own framework. A data scientist has no idea what the hardware underneath it is. He used his best knowledge with his data and trained it. Now, how do you actually deploy it for inference? That's why there are so many trained models. But when you look at the actual applications in the industries, not many companies are able to actually deploy it and get meaningful applications out there in the market. And also what I see is, sometimes people think that ML is a solve all. It's a new terminology. AI is something cool on the block. So we are doing AI. But what sometimes we fail to think is not everything is, AI is not the holy grail for all the problems. If you take computer vision, for example, there are certain functionalities like, say, Kalman filtering or Fourier transforms that are still best on DSPs. It's not good for machine learning or your neural networks. So how do you partition it? So the key where I believe the investment needs to be made is in that infrastructure, in figuring out how do you take it, how do you make your software stack so hardware agnostic that you can use the trained models, you can customize it because your end application requires a completely different model than the trained model. So you have to tune it. You have to tune it for your applications. How do you create that seamless infrastructure and software stack where irrespective of what is done on the hardware level or all the sensor agnostic or the framework agnostic, you are able to take the pre-trained model and adopt it to your application and seamlessly get it deployed. So your development to deployment time cycle reduces. Only then we will see inference actually kicking off in a big way. And it's not there yet. It's going to take some time. It requires a paradigm shift.
No, excellent points, Kavita, and I hope this auto ML terminology or this concept will help in some of these things. Maybe we need some auto schedulers also. Okay. So
AI for AI.
Let me give a different spin on this. So I'm going to put in my academic hat on this. So when I say investment, what would people would like to invest in 10 years, 20 years from now? So I think I was split into three categories. One is actually on the application side. People need to work on into generalized AI, right? Since right now, if you look at computer vision, CNN's got a massive boost, right, of that. And then GPT is not CNN anymore. It's a different model. So like and then there's DLRMs that's done by Facebook for recommendations. So they all are different models, right? And it seems that it's just like there's not a unified framework. I think if we can get with a unified framework for all of AI and that it could be spun off into like subsets of that, that would be a really like we reach the, like say, the end target of AI. Then on the second side, I mean, we need a lot of investment. How can you make these models affordable from the hardware perspective, such that you don't mean like the GPT-3 model, right? It's billions, 180 gigabytes, right? Imagine if someone a couple years down the road, hey, I managed to get this with 1 gigabyte. A couple years later, I got it better with 1 megabyte, right? Yeah. So the innovation on how to make this model more compact, removing all the unnecessary fat in it, right? That is also another way that people would work with this. Finally, I think this is like a much longer route. The hardware itself that we're working on, it's still based on the idea that you get data, you do compute, you store data. You get data, do compute, and you store data. Slowly, we are shifting away from this, but I think the world of brain-inspired computing and neuromorphic computing, right? This needs a massive, massive push because right now, while they show massive promise, it's extremely hard to get them integrated in any existing system, right? So this needs a massive work, a massive investment, so because they can provide the closest thing that we know to how brain works to a certain degree, right? So that when computer and memory are intertwined together, you would be able to deploy really sophisticated model at a very low power budget with high performance. So
excellent.
So that's the different perspective that I wanted to.
Yeah, I have excellent perspectives, and I think to do these things, I feel as you talk about the framework, I think the industry and academics, they have to collaborate better. Today, this somewhat silo approach, okay, I will be the winner. I don't think that will fly. I think we need to collaborate better. And the other piece of it is, I know there is research happening of how do we make a compute closer to the brain. It's not easy. But
so if you see, like, quantum computing got a massive push because industry started working on it, right? We need the same thing, but more into into AI.
Very good. Sorry, I'm just losing a little track of time here with all these exciting viewpoints. But I just want to ask one final question. Venkata, please don't stop me here.
No problem. Go ahead.
Okay. Before I go to any audience questions, if there are anything critical, India has a vast technical talent. We have been doing good in software for many 30 years or so, and there's a lot of excitement in India. A lot of excitement among the engineers, among the companies, the academics, and even the government. I know. So, how do you think, what kind of a role India can play in this whole evolving AI ecosystem, cloud, edge, and what advice do you have for the engineers, the academicians, the government, the companies in India? We can start, anybody can.
Right. So, Sambit, there is a very interesting perspective. Certain areas where when you think about AI, you have to think about applications. And some of the areas which needs huge amount of application development and model training are healthcare, financial services, retail, manufacturing. Healthcare is a very important area. The last speaker was talking about it. With the Western world, the challenge is because of the privacy rules and other stringent regulations, it's tough to get hold of data to train models. Whether you want to do model training in software, you want to embed it in hardware, that's a separate question. But getting access to data itself is a challenge. India, with its vast number of population, with a little bit more relaxed regulatory regime, can be a great place for training some of these healthcare models and deploying them, kind of proving efficacy of different algorithms and become a forefront in solving some of the more technical challenges which Western world will not. And then these proven models can be taken to the Western world for training them on specialized pieces of data and stuff. So basically leveraging India as a place for training models for high impact applications. And that will benefit India right away in terms of healthcare and other challenges that we have. That's one approach which I see, where I see India can play a big role, and accordingly regulations, government, companies can basically go from there.
No, excellent point. India, of course, with its population can generate huge amounts of data that, and the good thing is that the government is very supportive of the AI revolution and the digital revolution that's happening as we speak. Any other perspectives on advice to people in India?
I believe India has a boatload of talent, Sambit, that just the raw talent with regards to the engineers it produces and the technical talent. If we tap into it and the brain power that it's just going to generate, I think it's going to be huge for AI, solving the problems for AI. That's one thing. Data sets, to Tushar's point, is really true. If you get the data sets for, say, autonomous driving, right? A car, if it can drive in India, it can drive anywhere else in the world. As simple as that, right? So not just data
that
sets.
I agree with.
Even a person.
Not just data sets, right? Even the testing of it, testing of the deployment of these solutions, if you test it in India, because corner case testing is going to be impossible. How do you test autonomous system will work exactly to your specific specifications in all scenarios? It requires a lot of validation, and it's not easy to validate it. So if you test the testing capabilities in India, I think it's going to really help bringing autonomous, making autonomous systems a reality. So India can play a huge role in all of this.
We'll invite Elon Musk to do his testing in India.
Yeah, that's a way to do it.
Yeah.
One side I could say that is what country abundance of talents. What he talked about, we're just expanding it in Hyderabad. Around 20 people we're going to hire in the next 3 months. The team is going to expand. One, governments and all this is helping us. That would be one beneficial. Item number 2 is where we're talking about data sets. Security, we just talked about a grandfather thing, an example. I'll tell you, that is the biggest data point we can collect, how many ways people can make mistakes. And then that part of the security data sets, actually, some of the academy guys, maybe Dr. Mohammed in here can help on that too. Also, people working on not just computer vision only, but again, I'm preaching to the choir from this one too. People start focusing that there is a lot more data we can do. And this data is a lot more, volume-wise bigger. Maybe the capacity size not a zettabytes, but the even number of events happening, because network element is a smaller in a size compared to a picture. But you have a lot more data need to be able to crunch. And all that examples and testing also what she's talked about, field testing, allowing the governments and allowing that to also will make much better security.
Yeah, I think there is a question for the panel. That our Indians are expected to do testing only. I think the comments was more for that. Okay, India has a great infrastructure for any, like the driverless cars to do the AI testing. But India has lots of talent that can develop applications, technologies, lots of startups.
I think we all said first is the talent is there, including Kavita said that too. Yeah, no, testing was generally because it's a complex environment, what she was referring to, not anything discriminating is, that we all agree that, there's complete chaos on the road and the streets and anywhere in the world. If you can drive in India, you can drive anywhere. It's same for the machine too.
Yeah, and that's why we are opening a branch in India too. SEMA is
Very
opening because just the brain power is, I think, is enormous. Development, testing, any aspects of AI will benefit.
And testing in AI is not an isolated phenomenon. You have to first train the model. The training will happen in India as well. So that certainly requires our people.
And my urge, just want to say is that to all the India leaders and engineers is you take charge of your destiny. You have the talent, you have the brain. Take charge of your destiny. Go ahead, Mohammed, and we'll.
So it is like has the richest engineering background. I mean, they go to be successful. I think that from what I'm seeing, observing globally, right, as AI nationwide, everyone is having its own national strategy, right? And I'm pretty sure that India has its own AI national strategy as well. Maybe the idea is that to focus on one particular field that India can excel in easily and very quickly. And then India becomes a world leader in a subfield of this, right? For example, AI in medicine, AI in agriculture, right? Now it's India's #1 there. That automatically will bring in a catalyst on improving all other aspects of AI where India can easily become a competitor, right, with the world's being top nation in this field.
By the way, I just want to share some data. When I was in Qualcomm, we used to do 80% of SoCs of Qualcomm in India. So just to give a perspective.
Yeah, it's true.
So excellent, Venkata. I think I'm sorry I probably run over time.
No problem, no problem. When we are having an interesting discussion like this, we don't notice time.
So
and I didn't feel like interrupting you either.
No problem. I think really great discussions. I just want to summarize and thank the panelists for really a very lively discussion, and Iesa for really the opportunity. I think we concluded that we need both cloud and edge, but we need a lot of innovations, particularly the edge area, the security, ease of use, framework, and GPT-3 kind of thing. So, and India can play a big role. India has lots of talents, lots of engineers, and a lot of support from the government, and India can play a big role in development of this AI infrastructure, AI solutions. It's a great infrastructure to try out some of these applications. So excellent points, and thank you everyone. And Venkata, I think we should wrap up. Really want to take this occasion to thank all of you, the panelists, and all the audience for patiently listening to the comments.
Thank you. Thank you
Thanks
so
a lot,
much.
Sambit.
I'm sure it's been a great education for audience as well. I'm sure they're delighted to be part of this, panel discussion. And once again, thank you all for taking the time to joining us. It's been a wonderful discussion, and we look forward to having more of these discussions in the future.
Thank you for the opportunity, guys. Thank you.
Thanks a lot.
Thank you so much.
Thank you.
Thank you.
So we will take a quick 5-second break and move to our next speaker. Please stay tuned. Thank you. Start. Welcome back to our exciting AI Summit. It was a very interesting, panel discussion. Excellent points made by our panel members. With that, I'd like to introduce our next speaker from Xilinx, Xilinx is the leading FPGA company in the world, and they are investing quite heavily in artificial intelligence, developing the platforms for AI applications. And I'd like to invite Dr. Ishan from Xilinx. He is a senior director focusing on AI engineering at Xilinx. Ishan achieved his bachelor and PhD degree from EE department at Tsinghua University in 2008 and 2014 separately. He attended Imperial College in London. He was awarded with IBM PhD fellowship. Within this is like 80 PhDs among the world forever. Awarded to by the IBM PhD fellowship. He joined Baidu Research as senior engineer in 2014, then joined Horizon Robotics as FPGA team leader in 2015. As co-founder, he joined DP Technology as CTO and led an experienced engineering team with more than 100 people, focusing on high efficiency AI processor design, targeting mostly autonomous driving was acquired by Xilinx in 2018. Dr. Ishan has published more than 30 academic papers, including CVPR, ICCB, AAAI, and FPGA. Welcome to the summit, Dr. Ishan. I request you to address the delegates now. Thank you so much.
Thank you for introducing. So is my signal stable? I'm not sure.
It is stable. We could hear you.
Thank you. Okay, I'm very glad here to introduce the AI trend and the solution. And like the introduction, I'm currently the AI Senior Director in Xilinx, but previously I'm the CTO of DeFi. DeFi is a startup company in China. We work on building the specific AI processors on targeting for FPGA and also ASIC. So after 2 years running, we are acquired by Xilinx. So I and my team joined Xilinx after that. We have about 120 people in China, Beijing, working on the AI solutions on Xilinx FPGA after the acquisition. So I'm very glad here. I just heard part of the panel discussions, very exciting. And I totally agree that there is a trend that recently we don't tell the exact difference between the edge and the cloud. They are unified actually. And for edge side, we have more scenario, for example, the autonomous driving, the health, the Internet of Things. A lot of scenarios happens there, so we need to capture the data by a lot of sensors. But after that, we still need to use the cloud for more complex computing. In there, a lot of complicated tasks happens, like the vision processing, voice processing, or the natural language processing. Take an example, if we do the smart city, we need to capture the people and got the high resolution of his face and the body, and then transfer back the high resolution part of that image to the cloud. But for other background, we don't need to do that. So the edge side, we also need AI to do detection, segmentation, but we need the cloud to do more complex, like the recognition, and also to compare that with database. Also, similar things happen for the autonomous driving. We also need the cloud to help the cars to be more intelligent with a lot of online learning data and models. Okay, so the second trend, I want to go deeper into the vision, into the speech and also the NLP, to to see what happens about the algorithm architecture there. So for vision perception, we found that recent years, mostly the recent 8 or 9 years, the networks starting from shallow to deep. And also it's starting from the plane to some skip connections, more complex architectures like from BGG to the DensNet. And also we have complex operators like the spatial attention and the deformable convolutions, and also some low efficiency models. People firstly found that the accuracy is very high, but later they found the computing is too slow. So we need more high efficient models like the ShuffleNet, MobileNet, and EfficientNet. They are more friendly for the platform deployment. So our company, Xilinx, we focus more on these kind of more efficient models. And we also found the trend that the handcraft thin models that become past. And nowadays we need to use the NAS to automatically to search of the model topology. And also we need to combine with the platform's features, like for FPGA for our processor DPU, we need to combine the architecture features and search the best model for that. And also we found that the transformer not only becomes efficient for the LRP or the and it's also very useful for vision perception. And so we could find from the table in the bottom, from about 6 years ago, even we use similar amount of computation times, computation ops, the flops, similar flops. Our model's accuracy is from the 70% to 75% for the lightweight models. And for the heavy models, we even got higher improvement. Today with the transformer or EfficientNet, we got 84%, comparing with the 77% several years ago. So the same models are keep evolving. And we also found that the single image processing is there from a single sensor. And we also got the multi-sensor fusion requirement. And that could help a lot for the autonomous driving, like the combine the camera with LiDAR or 4D radar. And even for industry, for robotics, we got the combine the image and the TOF to get more information from the physical world. So for this kind of multi-sensor fusion work, we got some special OPs like the merge and convert operations. Like the figure show that no matter the early fusion or late fusion, and even we got a deep fusion, that we need a lot of computing besides the two sensors processing pipeline. So that will heavily affect the computing architecture and make the latency be very challenging for us. And also the software, when you got the real-time processing limitations, it's hard for our software to be written. So besides the vision part for speech, the models also improved a lot recent years. About 10 years ago, the Microsoft scientists and others, they starting to use the DNN to instead of the Gaussian mixture models for the speech recognition. And then about 2 or 3 years later, we got the end-to-end deep learning models, which combine the CNN with RNN, that the DeepSeek-2 models, for example, to do the ASR. And then we got the attention models, which improve the accuracy by a large step. And then we got the transducer, recently the RNT models, and also the conformer models, which combine the convolution and the transformer. So for the speech part, the models, they are from hybrid to end-to-end, and also from simple CNN or RN to attention models. So the accuracy also improved a lot. We could see the ASR example. And also for the NLP, I have heard a lot of discussion for the GPT-3 models, but it's too large. No matter for the model size or for the training time, it will be hard to be accepted. But the trend is also similar. We're starting from a long short-term memory, and then we got the transformer. And transformer also beat other models in the NLP task. And also we have some lightweight models. For example, the bird-based and also the tiny bird, mobile bird. So that is more friendly for the embedded device. So we got all this algorithm trend. We found that the algorithms keep evolving. The scientists, they no longer stopped their development. And on the other side, these very good models, one side gave the high accuracy, on the other side gave more challenge to the computing platform. Like our company, Xilinx, we put a lot of effort in AI computing. So we have designed several versions of our AI processors. So when we do that, we could see that for the AlexNet, starting from AlexNet, very simple, the plain network, and to the GuLaNet, we got some forward data from the layers and the layers pass and pass. And we also can have the DenseNet, which has the depth-wise convolution instead of the point-wise. And also the data may coming from a lot of layers, and the data output data from single layers will transfer forward to many layers ahead. So this kind of architecture evolving will cause problem for the silicon. When we think about the ASIC, when you prepare to tape out an ASIC, you design the RTL and do front end and back end, a lot of simulation, and then do the tape out in TSMC. But at that time point, when you got your samples, almost 1 year and a half or 2 years has passed since you have designed your architecture. So if you imagine, if you design your architecture targeting for AlexNet or that time point networks, then when you have DenseNet, either you will get a very bad efficiency or you cannot run that on your architecture. So we need to find a way to keep up with the rate of the AI innovation from the silicon side. So we need a DSA. So what is a DSA? DSA is a domain-specific architecture. That means we're targeting for a vertical domain, and we design architecture targeting for that domain. And we also could be adaptive to that domain's change. That means from the AlexNet, we could design architecture like this. And when you have the GuLaNet, we could have the architecture like that. And also for the DenseNet, we also have the architecture fit for that. So if you are using ASIC, you will need 3 generations. If you are using GPU, I believe you could use early version of GPU to run that. But the problem is that when you run new models, you'll get very low efficiency on that. So the solution is we could utilize FPGA, utilize Xilinx platform to for this kind of adaptive features. We could program the hardware, and also nowadays we have the AI engines, that is a software programmable DSP array that should help you to tangle for this AI innovation. So the adaptive device will allow the DSA to be updated without the new silicon hardware tape-out. And what is inside the DSA? I said that it is very flexible and could fit for a certain domain, and we got high efficiency. But how we did that? So the first thing is about the customer data path. Even for the convolution, we got several types of that, the point-wise, the depth-wise. And if you design one kernel for that, then the efficiency will be variance across different types of convolution. So you could design the different type of IP using the inside the DSA. you could design a different customer data path. And the second part is about the precision. When we do training, we always hope we could have the floating point data format, even the double. But for the inference, sometimes we found that the fixed point could work. And even when we limited the bitwise to 16-bit or 8-bit or even lower, it also could give us the similar precision, similar accuracy. So with this experiments observation, so that means we could change the precision from the floating point to the fixed point. So in our design, we always use the 8-bit and also 4-bit or even 2-bit for our AI processor architecture design. So that will reduce the resource occupation a lot and help you to initialize many more parallelism processing engines, which could help you to improve your throughput and help with the latency. The third one is the memory hierarchy. So for CNN, firstly, we think that this is a computation bound task. But after several years, we found it is also the memory bound problem. And for the LRP or for the speech recognition, it is naturally the memory bound problem. So we have the memory hierarchy. You could load the weights and the data from the off-chip memory, but that will be very slow due to the memory bandwidth. And you could also initial the buffers in on-chip, but that you will have limited size. So how to organize your data path, how to distribute the memory to fully utilize of the on-chip memory to reduce the off-chip memory access is a very key issues for your AI processors efficiency. So for our the Xilinx platform, we have relatively large on-chip memory, and we do a lot of work to optimize for that. For example, we will do the batch processing and share the weights and store the weights data in on-chip memory. And for the intermediate data between layers, we could also store part of that in on-chip memory to avoid the memory load and store to the off-chip memory. That helps a lot for the efficiency, for the computing efficiency. So I have talked a lot about how we use the DSA, domain-specific architecture, based on Xilinx platform to accelerate the AI computing. But when we think about a real system, the AI is only part of that. Although it's a key part of that, but it is still part of that. We need some pre-processing like OpenCV, and maybe we got some post-processing like the planning and some decision-making work. So what we need to do is not only to accelerate the AI part, we need to accelerate the whole flow. For example, for the autonomous driving, you need to do that all the things in real time. You cannot only do AI in real time. So how to deal with other part? If you are using some ASIC, some AI processors, which is ASIC-like, you could only accelerate the AI part. But for others, you need to run that on some very relatively slow ARM cores. So, but in our platform, our DSA could also support the non-AI part. We have the OpenCV library, which is accelerated on FPGA. We have other interface, which is also hardware embedded, and also the accelerated version. We have a lot of things which are accelerated. So you could easily, starting from our library, starting from our reference solution, to build up your total solution. So I will introduce the Xilinx proposal. So the Xilinx has a branding called Xilinx AI. Our Xilinx AI is a full stack of the software and the DSA IPs, targeting for no matter which generation of FPGA, starting from 28 nanometer to the 7 nanometer. We could support them all, and using the unified flow. In this flow, we're starting from the frameworks, TensorFlow, Caffe, PyTorch. We all have the support for that. And we even have a model zoo. In there are almost 100 models across the classification, detection, segmentation tasks, and also targeting for the ADAS and smart city and healthcare vertical domain applications. So starting from that, you will find the models that is running smoothly on our platform. And you could, starting from that, to change the model topology to modify and optimize that from there. And how we run all these models on FPGA. So inside FPGA, we use the logic and to build a DPU. The DPU is an AI processor architecture. We build several flavors of DPU, the CN DPU, RN DPU, and also the BERT DPU. And inside the CN DPU, we have several versions. Some are optimized for the latency, and some are for the throughput. And with these DPUs, we define the instruction size, and we also have the compiler combined with this instruction size. That means you have a model topology, and you're using our compiler, and we will compile the models into the instruction sequence. And then the sequence could be run on our DPU, and the DPU is placed inside the FPGA logic. So starting from the 7 nanometer, we have a device called ACAP. In ACAP, besides the programming logic, we also have an AI engine. For that AI engine, and you got the DSP arrays to accelerate your AI processing, and that could be run about 1 gigahertz. That is much faster than the FPGA programmable logic when talking about the frequency. So our flow could also compile the work to that ACAP platforms. We automatically separate the data paths in the logic and separate the computing intensive convolution layers into the AI engines, all by the same flow. And on top of the compiler, we have the runtime. And inside the runtime, we not only support the deployment of all these DPU IPs from the models, and we could also allow the users to register their own OP. That means if they found some model cannot be supported by the DPU, then mostly it will be run on the ARM core inside our device. But on the other way, if some customer, they already have some FPGA IP in the logic part, they could also register that IP and using our flow to combine the DPU IP and their IP to do the whole application acceleration. And we could also support that. And even they don't have their IP, but they have some special OPs, and we also could help them to register that into our software library, and they could use runtime to run that in the ARM core or the CPU, hosted CPU. So we also provide the compiler and the optimizer, which is the pruning tools for users to use that to help to optimize your models. So some key takeaways of our Vertex AI flow. This is a unified AI platform. No matter the cloud application or edge application, no matter which generation of the Xilinx FPGA chip device, you could all use this unified flow to deploy your models. We have comprehensive models in the model zoo and the related library to help you deploy of all these models within several minutes. And also our hardware IP, the DPU IP, will keep evolving. We have several generations, and we'll keep building the new generations of the different DSA for different algorithms. Like we got the BERT in last year, and we will have something new this year. So we are not only targeting for the AI. The Vertex is a larger concept. Inside Vertex is part of that is Vertex AI. Besides Vertex AI, within the Vertex, we also have the OpenCV acceleration and other accelerations. that could help you to build an end-to-end solution with the AI plus X. The X module is what you previously have, or you start selecting from our libraries. So this will help for your whole application acceleration. This is quite different with other platform you could choose to use. So I will, at last, I will give you 3 examples how to use the Xilinx solution to optimize your AI task. So the first is the multitask perception for automotive. This is the optimization only mostly from the algorithm level. So in our model zoo, we actually in my team, I have about 30 algorithm researchers who keep doing the state-of-the-art models, and also find the FPGA-friendly models and have customer to utilize that. So when we do the automotive customers, we found they always they need several tasks running together, like the vehicle detection, the pedestrian detection, lane detection, and the segmentation, and drivable area segmentation, and also the depths. Some automotive, the tier 1, they also want to use the camera to do the depth estimation to save the cost. So all these tasks, they are all deep learning models. Why not to combine that into single models? So the multitask models, we spend a lot of effort to do that. So you could find the first generation, we combine the detection and segmentation tasks together. And then we found that the latency is better and the throughput is much better for the multitask. And for the multitask version 2, we also do some models combination work. Besides that, we also use the NAS to search the best architecture, which is friendly for our DPU design. And we combine the 3 tasks together. And for the 3rd generation, we use single model for 5 tasks. And we when we see the tables, you could find that for the when you improve the task numbers, and the time consuming is not linear increase, it will help you to save some time. So this is from the algorithm level optimizations, and you could always find that in our model zoo. And we will cover the we already covered the automotive and the smart city and healthcare, and we will cover the robotics very recently in the summer of this year. And another example is how to do the optimization from the compiler side. So I'll take example of the image resolution. This is from a customer who want to use the low resolution to display at a very high resolution for the more friendly display. And of course, this is very heavy deep learning models, CNN models. So the state of the art is the RCN models, but the model is too heavy. And we found that if we want to run that in real time, we need more than 100 tera operations per second. So the first thing we think about is to prune that, to compress that, to make the model be much smaller with similar accuracy. So we do a lot of work in the pruning part. And second, we found that there is an issue. If we using the larger model, you will have more possibilities to explore the parallelism. But if you shrink the model to a relatively small size, then you don't have that much of parallelism, and you need to do some optimizations in your compiler. So we are using some layer fusions and some rescheduling, and also some the weights preload to reduce the off-chip memory size to tackle this problem. And we also found that we could, when you deal with the image, you could also partition that into several batch, and we could use the batch parallelism to increase the possibilities of parallelism to fully utilize of the so many computing elements. So when we do several operations, several optimizations, you could find that the frame per second improved, and also the latency are improved a lot. So this is a case to tell you that when you use our flow, you could do the algorithm optimizations, the compression, and you could also do the compiler optimizations. So the third example is about LiDAR. So LiDAR is a very important sensor for the automotive, but also for the industry, for robotics, for a lot of things. LiDAR is important. Xilinx is always the very key vendors for the LiDAR products, because we are very good for the DSP processing to generate the point cloud. That is some traditional algorithm to help you to generate that using DSP method. And recent years, those LiDAR vendors, they want also to use the chips to do the AI part after the point cloud generation. And one naturally thinking is that to utilize single chip solution is always better than the multiple chip solutions. So they want to embed that AI also in that FPGA chip. And our advanced AI flow could help them to do this whole application acceleration. But the key thing is that we need to demonstrate that Xilinx FPGA could also run the LiDAR processing. So this is a case for LiDAR, and but we could do much more than this. This case is the 3D object detection. We are using the point pillars, very popular models. And when you go deeper into the pipeline of the point pillars, you will find there are some pre-processings, and there are some feature net, the point net for feature extraction, and the scatter, and then the RPM network to do the detection. And inside that, there are some backbone, the 2D CNN backbone, and also the detection, the SSD detection framework, and also some post-processing. So all this flow, you could tell that this is not a thing only care about single AI models. There are 2 AI models there, and there are also some other non-AI operations there. So for our solution, we combine with we work with this customer and help them to tune from the algorithm part at first. And when we do some dimension reduction, and when we do some voxel number reduction, it could also satisfy their accuracy requirement. So, but that model becomes lightweight for the platform. And we also do the 2 AI models in single DPU that could utilize that by the time multiplexing method. And we also do the model compression for the backbone models to compress that by 7 times to 1/7 size. And also there are some software end-to-end flow optimizations. So at last, we accelerate more the 13 times compared with the non-optimized version. So there is a demo videos could show the real time, close to real time. It's about 20 frame per second for the point cloud, for the point pillar 3D detection. And we also released the model for the 3D segmentation for LiDAR data in the most right bottom figures. And you could see that with the, we do a lot of work for that, besides the model compression, and we also do the multi-thread optimizations using the software flow. And of course, we context that model to run that in our DPU. So that are the examples, and I want to give a summary of my presentation. So the first thing is that AI algorithms are evolving very fast, no matter the vision perception or the language processing or the speech recognition. the models, they are all evolving a lot. And even more, the multiple model will make that even complex. And we found a very interesting trend is that the transformer is dominate the language processing and also the speech recognition. And nowadays, even for the vision perception, it will become the state of the art. So the second thing is that this innovation requires the domain-specific architectures to meet for the new networks, latency, performance, and cost. So, and also another observation is that AI application is much more than AI only. It's also need the DSA to accelerate the non-AI part. And our Xilinx solution, our Vertex AI solution, could help you to build your system from a software developer's point of view, and to support a lot of frameworks and make the developer very easy to deploy your models within minutes. And I also give some examples to show how to optimize the AI system from different levels, from algorithm level and from compiler level and from the architecture levels with our Vertex AI flow. So thank you. That's all for my presentation.
Thank you so much, Sean. That's a wonderful presentation from you. It's a great insight. And we have a couple of questions from our audience. The number one, as we all know, the computing power and the memory that's needed for artificial intelligence applications, it's like the needs are growing pretty fast. And how do you see, again, also the latency between the CPUs and the memory is also becoming a bottleneck in some applications. So how do you see Xilinx scaling up their hardware platforms, their FPGA platforms, and what kind of architectures they're investing into?
Okay, so as I mentioned in the presentation, we found that the memory is the one of the key things for the computing power. And we have some device that has HBM. So with those HBM device, you will have a very large memory bandwidth. So no matter what kind of AI applications you want to do for the inference, those HBM almost could satisfy your requirements. But HBM also have some issues like the power and also the cost. So we know that if you want to have a chip to have HBM interface, then the chip will be much expensive than which don't have that. So with the chip which don't have with reasonable price, reasonable cost, and power, what we do is that we fully utilize the on-chip memory in our DPU design. And we do a lot of optimizations between the layers. The intermediate data, we treat that very seriously, and to avoid frequently load and store to off-chip, if we could, we will store all the data into the on-chip memory. But sometimes you will have some large image, large resolution, and large models. It's hard for you to do that. So you need to make decision which part of the data is mostly used. So to tackle this problem, we also have the pruning technology and the condensation technology. The pruning could help you to shrink the model size. Of course, the data size will be smaller, and that gives you more chance to store more hot data into on-chip memory. And the condensation could also reduce the transfer bandwidth requirement, and also could to help you to store more data into on-chip memory. And we have a white paper released early last year that is talking about the 4-bit solution. And we also have the 4-bit IP. With that, it will ease the challenge of the memory bandwidth also. So we have a lot of techniques to solve that problems. Yeah.
Thanks for those inputs, Dr. Sean. One more quick question. So we had a very interesting panel discussion before your presentation, edge versus cloud computing. And where do you see Xilinx FPGAs playing the role? I mean, more on the edge computing side or on the cloud computing side?
Oh, for Xilinx, we focus on both sides. We know that our CEO Victor Peng said that the data center first several years ago, and we proposed the ACAP platform, which are very powerful platform for the data center side. So we treat these two things at the same level. For the edge side, we think that Xilinx is very good there for the sensors, inside sensor processing, and we could do the front end AI and to scan the useful data and transfer that back to the data center. And in data center side, we have some flair to do smart NIC, and we could also do the data, do the AI inside the data exchange in the data center together with SolidFire. And also for our the AI computing capability, our recent ACAP platform could reach to hundreds of tera operations per second. So that is also very powerful solutions in the data center. So I see them at the same level, and I think they will help each other. For some customers, some hyperscale customers, they will have a lot of sensors there and the data acquisition channels there, and they could also have the data center to process of those data. So imagine they cannot accept to use too many different platforms to do the edge and the cloud. They want to unify that. So that's why we provide the Xilinx AI, which is unified for edge and cloud. Yeah.
Thank you so much, Dr. Sean. You know, and once again, we really appreciate you taking the time to join us today morning. It's been a wonderful session, and we look forward to having you on similar sessions in the future with us. Have a nice day. Thank you so much. And with that, I'd like to address our delegates quickly. And, I thank you all for joining us today morning, wherever you are. I think we have people joining all over from the world, from North America, from India, from Asia. It's been an interesting morning session. And we have some more exciting, topics and group discussions lined up for today afternoon. Please take a good break and join us for today's evening session. Thank you so much once again. Great. We look forward to seeing you all again. Okay. ఓకే ఓకే అది మన స్వామి కదా స్వామి పంపిస్తాను జస్ట్ వెయిటింగ్ వాట్ టైం హౌ మచ్ టైం యూ
Unmute, okay. Let me see. You can hear me? Let me put the phone off, maybe. Okay, okay. He can hear me. He can hear me through the Zoom, right? Yeah. Okay, okay. Thank you. Yeah. Thank you. Bye. Thanks. Bye.
So Microchip is currently located both in US and in India.
Microchip has about 300 associates in Semicon Design Services BU, 100 in RTL design and verification, 100 in physical design synthesis timing, and 100 in analog layout. The layout team at Microchip is one of the largest layout teams that any company has in India.
Moschip is very proud to be associated with Indian Defence, catering their requirements.
We also executed multiple defense designs under the Make in India campaign.
Moschip is one of the largest smart lighting solutions provided in the country today.
The uniqueness of the Moschip is the product development experience, working from spec to silicon, delivering working silicon into the market. We offer end-to-end solution.
An employee joins Moschip. The advantage is the learning. They would be looking at right from the requirement document all the way to digital design, to verification, to system and evaluation boards in terms of system bring up and eval board bring up and ASIC bring up.
So Moschip provides a very balanced work life. We value our employees.
We actually place a large amount of value on individuals' growth.
Moschip having its own training and development division that helps in building good teams.
We want to encourage employees to have the freedom to explore, experiment and learn.
So over the years, Moschip was recognized for their achievements. We are the first fabless semiconductor company listed on Bombay Stock Exchange. The main advantage Moschip has currently, our production proven SerDes technology as well as our IoT products that are proven in the field.
When a client looks at Moschip, they should look at Moschip as the go-to partner for end-to-end turnkey solution.
We want to become the preferred vendor for a lot of semiconductor companies globally.
You know, at AMD, we really are about high-performance computing, and I always talk about how important it is for us to be ambitious in our goals and really try to solve some of the world's toughest challenges. So when you look at Frontier, and when you look at participating with the Department of Energy and Oak Ridge National Labs and Cray in building the fastest supercomputer in the world, think about it. Over 1.5 exaflops, using our CPUs, our GPUs, our technology, our software, really is the epitome of high-performance computing at AMD.
We're incredibly proud of our long partnership with Department of Energy. It goes back over, really a couple of decades, our work on previous supercomputer programs. And then in 2012, 7 years ago, our focus with Department of Energy on exascale programs. There was Fast Forward, there was Design Forward, there was Path Forward. And so when you look at what we've been doing at AMD, driving a modular design approach, driving a very high performance CPU and GPU technology and enabling software, it was the perfect basis and alignment for what Department of Energy Frontier System was looking to do. And in partnership with Cray and DOE, we're able to apply that same broad strategy for high performance that we've been working on at AMD to squarely go after the greater than 1.5 exaflop target for the upcoming Frontier system.
At the heart of the Frontier system is the combination of an AI and HPC optimized AMD EPYC processor and a purpose-built Radeon Instinct GPU. The Radeon Instinct GPU also contains HBM memory, high bandwidth memory, for very high bandwidth while still very low power. Connecting the GPUs and the CPU in each node is the AMD Infinity Fabric, which allows the two to collaborate at a very close level. We believe that supercomputing is at the forefront of computer architecture, and the innovations and technology that's driven into systems like Frontier wind up defining the standard for the data center.
When you look at how Oak Ridge has historically used the supercomputing capability that they have for advanced analytics, our engineers are proud that our technology will be used to help analyze and progress the analysis of advanced weather modeling, of advanced disease research, understanding molecular genetic disorders. This technology will be used to advance many areas.
Frontier is a huge moment for AMD. When you think about the amount of computing horsepower that we're putting into this machine, it's the best of everything that we have, from hardware to software to system design. And every one of us should be extremely proud of the fact that we are contributing to something that has such a profound impact on the industry. It's really an opportunity for AMD to change the world.
Background. ये तो चलेगा. Okay. Good afternoon. Welcome to Iesa AI Summit. I'm Sridevi Devi Reddy, bringing you the product showcasing product demos of participating companies. The first one being Microchip. Microchip is the first fabless semiconductor company from India, which has been designing chips for the past 20 years. We have with us Mr. Swami Irinki, VP of Marketing and Business Development. Mr. Swami is a marketing and business development executive with over 25 plus years of experience in high technology companies and public companies. He is responsible for Microchip's long-term strategy for growth in semiconductor and embedded systems business units, along with North America business development, sales enablement for turnkey SIC and design services. He will enlighten us today on ASIC platform for AI-enabled edge devices. Welcome, Mr. Swami. Sorry for disturbing you at this middle of the night as you are in US. Now over to you. The stage is all yours.
Thank you, Sridevi, for the kind introduction. Please share. Should share my presentation. Yes. Thanks, Sridevi, for the introduction. You can see my screen, right?
We can see a screen.
Okay, thanks, Sridevi. I want to go in a presentation mode. Let me see one second. Yeah. Yes. So with this, as Sridevi mentioned, I'll be going over the ASIC platform for AI-enabled edge devices. As you heard from the in the summit so far. Why can't I go down? One second. Why can't I navigate to the next slide? Looks like I should be in yes, it's working now. So the main agenda for the topic will be to cover what's happening, how the AI is enabling edge devices, and why there's a need for ASICs to develop edge devices, and what Microchip is doing in creating these ASIC platforms, both for silicon development and for software development. And I'll conclude with some topics, with the conclusions, with the Q&A at the end. So as AI is definitely migrating to the edge, initially the AI, a lot of training is still happening at the cloud and at the edge of the network, but the inference has moved to edge devices, because the processing closer to the data improves the latency, bandwidth, energy, and use, and it reduces the stress of the network. So that is actually driving many of these applications like automotive, consumer enterprise robotics, and drones, and AR, VR, security cameras, and security speakers. So there's expected to be a 2.5 billion devices in this AI edge device shipments by 2025. I'm giving a little background prior to showing why ASICs are important for edge devices, so that I can show the ASIC platforms enabling these applications. So what's happening in the embedded AI and security is driving a new renaissance in silicon development. All the people in India, all over the globe, who are working in the silicon industry should be very, it's a golden era for silicon development, either in the hardware design or software design, because the many new applications are driving, is going to be tremendous growth in semiconductor industry. For example, in IoT, there are several applications in IoT driving these edge devices for embedded AI and security. For the AR, VR, there are many applications that are driving this edge devices, which are going to be smart and secure. Automotive applications and mobile that we're all very familiar with, plus the industrial applications and security and the smart surveillance. So all these applications are coming. They all need embedded AI and security devices. But what's happening is these devices are not made equal. And that's where the beauty of the ASICs will come in. It's not necessarily, it's not possible. Some devices, as you see on the left-hand side, some are very cost and power sensitive. They depend on battery life. They want low cost. They want always on sensor hub. Whereas some applications like AR, VR, or a dashboard for automotive application or drone, they're more compute intensive and latency sensitive applications. So it is not possible a general purpose CPU or a GPU or ASSP will cover all the applications, and one chip will not be able to cover. That means you need a domain specific application SoC, and that's where the ASICs are better suited for providing a domain specific for a given task and the best optimized solution. So that is where many companies are developing ASICs, and Microchip enables We don't develop our own products. We develop ASICs for using our ASIC platform. Other companies develop their products. And ASICs are better suited for high performance processing with a low power consumption and form factor, which is extremely critical for edge devices. And ASICs are optimized for a specific application compared to GPUs and FPGAs. And ASICs can deliver AI functionality at a low price point for the unit price, but it requires some upfront NRE investment. And most of the edge devices can be developed in mature process nodes of 22, 28 nanometers and above, whereas the cloud training, etc., you need to go to 7 nanometer, 5 nanometer. For edge applications, for inferencing, you can still leverage the older process nodes. So with that background, let me now say that sets the stage why ASICs are important for edge devices. Now, the ASIC platforms that Microchip is enabling enabling our customers to develop their solutions for inferencing and security edge devices. As I mentioned, Microchip enables our customers to develop their products. So we want to develop platforms so that we can lower the risk and faster time to market and etc. The first platform that I'm going to talk about is our platform called Matrix One. It's a platform for multimedia handheld applications that we developed in 40 nanometer. It's fully silicon validated for all the multimedia type applications. All the interfaces are fully validated, and all the software development we have the complete reference platform. Our customer can leverage it to develop their edge ASICs in 40 nanometer. But this platform, it was developed about a couple of years ago, does not have an inference engine because AI is, as we all heard, it's pretty new. So this does not. It has security, but it doesn't have an inference engine. So what we're doing is we're upgrading this platform to 28 nanometer, and we call it as Matrix 2. In 28 nanometer, we leveraging all the work that was done in 40 nanometer because a lot of interfaces are fully validated and vetted in silicon. And we are upgrading that platform in 28 nanometer to add a Microchip's internal IP for mixed signal SerDes IP and CEVA's neural network engine and secure IC secured IP, so that this platform can be leveraged more for smart and secure edge devices for set-top box applications, smart metering, and handheld applications. So the key IP blocks for this platform will be Microchip's internal mixed signal IP, because most edge devices are actually they will be towards the real analog based for sensors. They talk to the real world voice and audio. So mixed signal IP is going to play a critical role in this applications. And Microchip has a protocol agnostic SerDes PHY that supports up to 16 gig. That will be part of this Matrix 2 platform in 28 nanometer. The other key building block we're enabling in this platform is our partner CEVA. It's a very well-known company based out of Israel. They have a very strong portfolio of neural network engine, and this engine it talks for a single core. It supports about 12.5 tops. In a multi-core, it can go up to 100 tops. And this neural network engine can be configured for a given application. As I mentioned, each domain is different. A drone application is different from a security camera. So it can be configured for a custom domain application. We can customize this neural network IP into our platform so that we can develop a domain-specific NNP IP through our platform and enable our customers to develop that ASIC for that application. And another critical IP is security. The reason I think the original IoT assumptions the market had did not proliferate because the edge devices were not secure, and there are many attacks happened that the people got attacked through the weak edge devices which are not secure. So now industry is all the customers are focusing on edge device has to be not only smart, AI enabled, but secure. So for that, our platform will have a Securizer IP from our partner Secure IC, and this Securizer IP it plugs into the system interconnect and provides all the security for all the critical AI protections for the confidential the data, authenticity, secure boot, runtime integrity, and tampering solutions. And it's a hardware solution. The hardware security is much more secure, and it works, it runs faster. And there are some software angles, optional features available, but the critical functions are implemented in hardware through our platform on the Matrix tool. So that is the second platform I covered. The third platform that I like to cover is that we developed with our customer in 22 nanometer, which is a platform with our embedded MRAM. So what's happening is that the on-chip memory-based emerging non-volatile memories is actually providing a better access speed and lower power, which is very important for some variables type of applications. So we actually developed this platform fully silicon validated in 22 nanometer with a full software development track, with a custom embed RTOS, etc. So we can leverage with different derivatives. We can derive but for MRAM based edge ASICs from this platform for the customer. So I covered 3 platforms: one in 40 nanometer, 28 nanometer, and one in 22 nanometer. And these are all for silicon platforms. But as you heard from this conference to date, another big puzzle or equation is the software. The software and the firmware is extremely critical for these edge devices, right? So that's where a lot of these models come in. So Moschip also provides system design services for the firmware software development and the bring up, etc. So in that area, our capabilities are, we have 3 capabilities in that area that we're expanding more. One is object detection classification. We've actually implemented that project for a customer. You can see the GUI here. And we also have our Moschip pre-engines can provide data augmentation to enlarge the data set, because you may not have the larger the data set, you can do better modeling and better accuracy. So we can enlarge the data set with our pre-processing engine. The third capability is a face detection and recognition solution is developed by the team in Hyderabad. This team you see on the screen, they developed this capability. And that is the case study that I'm going to show today as a demo. And that case study is, if you see the case study, it's a face recognition. It has 3 steps. You face detection, then you extract the information with the features, then you classify and you identify the person. And of course, with that, the way we set up that to demonstrate this capability is with the server configuration with the Intel i7 with the NVIDIA graphics card, and with the edge configuration with the thin client with the LAN and camera interface. And we worked with different models, different frameworks that you heard from Xilinx Talk and Blaze. The software is enabled so that all these software models are available as an open source. So our teams are familiar with these frameworks and various detectors like YOLO and RCNN and classifiers, FaceNet and ResNet, etc. So we use these models and using a data augmentation algorithms to enlarge the data set using Moschip pre-processing engine. We actually developed this capability of the face detection. I like to run that demo as a video for that today. Let me run that video. So that is the audio. That's the demo for the face detection, and we're continuously evolving more models and developing AI capabilities so that our platforms can support our customers' development. The idea of a platform is to eliminate the risks so that we can develop this custom ASIC for our customers in both silicon and software and systems to meet the time to market advantages. So to conclude my presentation, On-device embedded AI and security and non-volatile memories will drive the need for ASICs for edge devices. A domain-specific ASIC platforms will dominate the development associated for edge applications. And Moship ASIC platform and system design solution will enable customers to develop and bring up these custom solutions for emerging consumer and industrial applications. With that, I'll take few questions from the audience.
Thank you, Mr. Swami. It was an amazing presentation. There's a question from the audience. With massive growth in the need for with the massive growth in the need for software development for AI SoCs, does the ASIC platform approach that was presented also help to improve efficiency of firmware? I mean, software development effort?
Yes, Sridevi. Yes. It's a good question. That's the whole idea. The platform is supposed to help both silicon development cycle time. So both in the, because we are validating all the peripherals and the bring up. So a lot of these applications for a given domain, the interfaces are common. So if you have the common firmware software developments developed for all this software development developed for a given platform, any derivatives you derive from the platform, you can leverage that software already developed. So definitely it improves the software efficiency also.
Thank you so much. So there don't seem to be any more questions. Thank you so much for your time.
Thanks, Sridevi. Appreciate it.
Thank you. Have a lovely day.
Thank you.
Our next company, which is showcasing their product today, is Microchip Technology. Microchip Technology is a leading provider of smart, connected, and secure embedded control solutions. The company's solutions serve more than 120,000 customers across the industrial, automotive, consumer, aerospace, and defense, communication, and computing markets. Its headquarters in Chandler, Arizona, Microchip offers outstanding technical support along with dependable delivery and quality. Today with us, we have Mr. Deeptesh Nandi. He is a product marketing manager in Microchip's FPGA business unit. He leads worldwide technical marketing activities for smart embedded vision and vector blocks AI for Polar Fire FPGAs. Hi, Mr. Deeptesh. Request you to take over.
All right. Thank you so much for the introduction. Let me go ahead and share my screen. Is my voice clear? Is it audible?
Yes, it's audible.
All right. Thank you. All right. So can you confirm that you can see the screen? Is my screen visible?
Not yet.
Oh, just a second. Let me try again. Yeah, is it visible now?
Yes, it is.
All right. Thank you so much. Yeah. So good afternoon, everyone. My name is Deeptesh Nandi. I'm part of the marketing team in the FPGA business unit for Microchip. And in today's discussion, we're just going to go over very briefly how do we sort of define and design a small form factor anti-tamper fanless AI machine learning algorithm using FPGAs. So we've heard our previous speaker talk about ASICs. There was I believe, a presentation before with another FPGA. For Microchip's point of view, our FPGAs are extremely small form factor, extremely low power, and we target AI inference applications that demand the requirement of having extremely small power consumption and many other features. So we're going to basically go over at a high level what those challenges are that our customers typically sort of come up to us with. So we are really extremely successful in the smart embedded vision areas, which demand sort of extremely small form factor solutions that do not have a lot of space to sort of include a thermal fan or a heat sink, but they also require higher resolutions. I mean, they're not happy with 1080p resolutions anymore. They want to go towards 4K. They want to sort of target 8K kind of resolutions. And when you drive systems at that high speeds, and essentially because FPGAs have high-speed transceivers that enable you to drive those high bandwidth requirements, power is a extremely tangible concern that faces our developers. Security, again, it was mentioned in the previous presentation. Security has been important, especially in edge applications, because they're typically deployed outside the purview of the traditional physical security. You do not have any guards or barriers protecting your installations in automotive, in remote installations, maybe in drones. So you want to ensure that, let's say a drone crashes and it gets into a hand of someone else, your IP that you use to sort of implement the drone system, the image processing, everything is protected and it's not easily hacked or extracted. So our objective today is the following. I mean, we're trying to get an FPGA, a traditional FPGA, to essentially run a machine learning algorithm to sort of come to a solution that is more applicable towards the edge. We're going to see how different problems with respect to power, with respect to changing environments, make it absolutely essential, at least for the first build of customers, for them to at least start their prototyping with an FPGA platform. Not going to spend a lot of time over here. I think what we're trying to say is that whenever we are talking about inference, there are 2 or 3 things that are extremely important. The need for inference on the edge is driven by the need for latency. And because edge systems do not have the kind of power and performance that is required to, which is typically necessary for traditional AI and ML algorithms, you need to have essentially some features that enable your algorithms to be able to sort of, first of all, convert into lower resolutions, and that is essentially something what we call as model conversion and model processing before they can be deployed into edge devices. So power and space are constrained in embedded devices, and obviously we talked about how it needs to be secure as well as reliable, because often installations might be completely outside the purview of general security. So let's talk about power. It essentially becomes important to have a thermally cooled system whenever your system power goes beyond 5 watts. That is when we've seen customers actually come to us and talk about the requirement of a heat sink or a requirement of a thermal fan to essentially cool the system down. While some of this can still be sort of mitigated for certain applications, maybe like a drone. But if you talk about portable medical devices, let's say endoscope camera, which is looking to sort of increase the resolution from a traditional 1080p to like a 4K resolution. If you do not control power, you cannot actually put that device into an invasive sort of medical instrument. And in an invasive medical instrument, the size of the instrument is at a premium. You cannot really put heat sinks or thermal fans. And then when you try to drive a 4K image processing workload, it becomes extremely important to ensure that the power is controlled And then your system also has the additional bandwidth to run AI algorithms. So power does not only mean battery life, it means heat dissipation. In thermal imaging cameras, for example, the stray heat near the enclosure will cause interference, and the image quality will get degraded. And in order to get rid of those image degradation, you might have to sort of implement additional ISPs. So if you have a lower power chip, a lower power FPGA that is immune to sort of high energy temperature spikes, that really solves the customer's problem. Functional safety is becoming extremely important, not only in industrial, but also in automotive. Suppose you implement a very simple design like this, where your camera is interfacing with, let's say, a receiver, can be MIPI CSI, can be LVDS, can be SLVSCC, and then you do run different processes of dumping the data out into DDR, and then doing some image processing, doing scalar applications, color space conversions, and finally getting it ready for an AI engine to basically run itself and provide inference results. And then maybe at the end of it, you want to essentially merge the inference results with respect to drawing boxes or text to the original image, which was captured in the from the frame, and then sort of dump it out through a display, dump it out to another ECU in an ADAS. And essentially what we're trying to do in this case can become extremely difficult, let's say, if you are trying to make a safe design. Now systems can fail because of processes, systems can fail because of random events. There might be transient events where, let's say, a bit flips in causing a soft error that needs to be mitigated. So in order to make the systems, really critical systems, operate in an automotive or an industrial kind of applications, we do have to ensure that the embedded processors follow the industrial functional safety, as well as ISO 26262 for automotive, thereby essentially ensuring that at every stage of a image processing function or an AI function, you are able to detect errors up to a certain level, correct some of the errors also. But essentially, if anything goes wrong, let's say during the MIPI CSI receive cycle, maybe a link gets corrupted, or maybe CRC fails, you need to be able to know that something has gone wrong. And if you can correct it, that's fine. If you can't correct it, you let the ECU know that, hey, let's not use the input from the camera because there might be something wrong. So it becomes important for embedded processors to have, for example, ECC, SegDet, single error correct, double error detect functionalities. Some memory controllers might not support ECC. You might have to create inline ECC to sort of enable error correction codes. You need to ensure that your soft processor or hard processors, the cache is monitored right through flush and have another ECC functionality. So there is a lot more that goes into creating a safe design, and that needs to be sort of provided through industrial and automotive functional safety. That also becomes extremely important for an edge embedded design. The third challenge is what we've seen are evolving requirements. AI is, I believe, there's a long way to go before it becomes saturated. It's still what I would say classify as a nascent sort of market where more and more customers are evaluating it, figuring out what works for them, what are the flows that are important to them. And what we've seen is that algorithms will change and can change from time to time, not only during prototyping, but also in production. So your system has to be smart enough to support online updates, over-the-air updates. Your image processing techniques can change, your compression techniques can change, and then your network interfaces can change. You might choose to use HDMI output for prototyping, but eventually you might end up using an Ethernet interface or maybe a co-express interface, who knows. So we have had customers having a multiple options of using different interfaces as per their device requirements. So a challenge is to be able to enable flexible designs in AI today as well. Security is something that is coming up right now. I think originally we did not have a lot of customers who were interested in security, but suddenly there's a spike. And whenever we talk to our customers about security, they are interested in learning more. They are interested in learning how different vendors, for example, use different techniques for the challenge of security. According to me, there are like 2 or 3 points for security that we need to ensure. First of all is, can you protect your device from running unauthenticated code? If someone hacks into your system, someone hacks the non-volatile storage where you're maybe storing your weights of the neural network. What happens if unknown code is being sort of somehow maliciously put there? That's number one. Number 2 is, what happens if somehow your code is being extracted because a customer can buy, a person can buy a device on the market. They can use many techniques to sort of take out the IP that you've developed. And number 3, what happens if you have taken out the IP? Can you, for example, create a sort of duplicate part with original FPGAs, by the way, with the same FPGAs, but from a different vendor, because it becomes aftermarket, and then program the FPGAs or embedded processor using the extracted IP. So there's 3 different processes, and there are many ways in which the companies provide these features. For example, Microchip's FPGAs have protection against side channel hacking. There have been absolutely no reports of any hacks that have happened due to differential power analysis. We are licensed by the Rambus Cryptographic Research Institute. We have womb to tomb kind of security. Essentially, you can identify every die because we put in private keys at the time of wafer manufacturing, and you can use those IDs. Even if something happens, someone extracts your IP, they cannot actually program the IP if, let's say, they have a tie-up with your system vendor or your contract manufacturer, because you control the number of devices that gets programmed, you control the number of FPGAs that gets programmed, not one FPGA more or less. Finally, how do you ensure that your IP does not get extracted from an embedded chip? There are many ways to do it. We do it by providing anti-tamper mechanisms. We monitor clocks, we monitor temperature, we monitor IOs within the chip, and we provide an API to sort of provide the customer different ways to mitigate it once those hacking conditions are sort of determined. Reliability is, it was primarily due to software errors creeping up in applications today. Reliability was most used originally in the avionics space, where there is a high chance of stray radiation particles hitting a fabric. The fabric can be based on SRAM, it can be based on a flash, where your configuration files are stored. Again, reliability can sort of depend on various areas. You can corrupt the memory, which the system is reading again and again. You can corrupt the logic, which can potentially change the system functionality altogether. And you can change the flip-flops. Flip-flops, probably integrated logic, can be slightly easier to correct, but there are ways where a software can completely destroy the functionality that you have integrated in your systems. And the way to solve this is, like I said before, you implement single error correct, double error detect mechanisms. You ensure that all the memories within your architecture is protected. You ensure that if you are not protected, you implement triple module redundancy protocols, and maybe if you use a non-volatile flash-based configuration like PolarFire FPGAs, you are completely immune from the start because of the architecture. So we talked about the different challenges. Let me give you a reason why FPGAs are still being used for AI and ML today. It's still a nascent market, and because of the reasons I mentioned before, because the requirements keep on changing so many times, FPGAs just offer you the best way to sort of implement all your requirements through programmable IP. And VectorBlocks is our machine learning inference IP. It's part of the AI and ML sort of offering that is associated with our FPGA offerings as well. So VectorBlocks is here. It is essentially inference IP, like most of the IPs that you've seen in the market, most of the solutions you've seen in the market. It is configurable. It can be configured for different performance ranges. Based on configuration, it will basically use up more resources or less resources. It has a software overlay. I'm going to talk about this very briefly there as well. But our differentiation comes from power consumption. The top 3 lines are our examples of how we configure the IP, the VectorBlocks IP that can deliver as small as 80 gigaops, as high as 280 gigaops, can go up to 1 teraops depending on configurations that you choose. And I'm comparing it with a competitive FPGA that we see in the market as well. So if we take just the 2 rows over here, we are essentially outputting a similar giga operations per second number. But once you look at the total power consumption, it is almost 30% lower, 60% lower than the competition. So 4 watts versus 1.3 watts for similar ML output. So this is also referenced under this block and this block. So what we are essentially trying to focus is on applications that require low power consumption. They need smaller enclosures and fanless designs. You cannot put heat sinks, you cannot put thermal fans, because that's the overall requirement of your end customer. And we offer our ML solutions to be at least 2 to 3 times more power efficient in terms of giga operations performance per milliwatt. So that's really our niche where we are successful. Quickly on VectorBlocks, I think the main goal for VectorBlocks is to enable software developers, as they are the ones who are most likely to be evaluating neural network solutions for your customer, for you as well as your designs. So essentially, it enables software developers to start evaluating the solution without requiring any FPGA design expertise. It's a software overlay method where we provide the initial FPGA hardware design, and using the software the software SDK, it becomes a plug and play kind of an application where they can change around different neural networks, they can change the functionality of the neural networks, and so on and so forth. What we also provide is a bit accurate simulator. So even to get started, you do not even require a hardware to get your workflow started. You can just download the SDK, start hooking up your CNNs or our CNNs from the demo files, from the networks that we provide, and basically start seeing the performance, start looking at the simulator outputs, the design bandwidth, the DDR bandwidth, the latency numbers, all are sort of provided at the simulator level. If you think that matches your requirements, then only you need to sort of come back to us, maybe get a hardware kit, and then start seeing how actually the simulation results match the final performance. Not going to go into detail. This is what I meant by a software overlay method. Traditional FPGA flows, you start with creating an RTL. That's where hardware designers are required. You synthesize the RTL, then you place and route, and finally you program the FPGA. With VectorBlocks, we provide the neural network engine IP. I believe that's what most of FPGA vendors also provide. That enables the software developers to really work on the C++ based development and neural networks that are converted to an accelerator. So they are completely spared this hardware flow, which typically is expertise for a hardware engineer. Again, I think this was covered in the previous presentation, so I guess you see and know what it means. What I just wanted to convey is how we sort of come up with power numbers. A typical facial recognition algorithm has 2 CNNs at a minimum. The first CNN sort of identifies the heads in a video frame, and the second CNN basically landmarks those video images. And that's how a typical facial recognition algorithm works. So in an FPGA, you do get to implement the complete solution from image sensor interface to the last end output. and you see the performance numbers. Sorry, while you get the performance number, you do also see the power numbers, which is like extremely small, 1.2 watt to implement a facial
Mr.
vision.
Nandi, we are falling short of time.
Yeah. So this is my last slide. So this talks about what we have available today. I've given the links below for if you're interested. All our software development kit are available in GitHub, free to download. And you can get more information on the website with respect to what hardware are supported and what are the example projects we support today. Everything is free to use, everything is free to evaluate. And we have many sort of tutorials to help you get started with your designs. So that's all I had. I probably exceeded my time, so apologize for that. If you have any questions, I'll be glad to respond. Otherwise, feel free to reach out to me over email.
Thank you, Mr. Nandi. It was really an informative session. In the paucity of time, we would like to ask you only one question, which is from the audience. Can vector blocks support multiple CNNs?
Yes, vector blocks can support multiple CNNs. The way we do it today is by time slicing. Essentially, CNN1, CNN2, CNN3 can be switched instantaneously. So if you can afford to wait like milliseconds where the CNNs can be switched, and that is how fast the CNNs are switched, then you can realize the same function. But if you want multiple support, that is also available today.
Thank you so much. Thank you for your time.
Thank you. Yeah.
The next company today, which is showcasing their product, is Blaze Inc. Blaze offers transformative computing solutions for AI data collection and processing at the edge of network with focus on smart vision applications, including automobility, retail, security, and industrial. We have with us Mr. Tapan Kumar Joshi, Director of Product Engineering at Blaze. Mr. Joshi is a Director of Engineering at Blaze and leads Blaze Client Engineering Group. He has been building, driving, and delivering engineering teams in areas of AI systems, software, algorithms, embedded systems, DSP, and mobile communications. So now I would request Mr. Tapan to share a few AI edge computing use cases. Mr. Tapan, thank you for giving us your time today. Now the stage is all yours.
Thanks a lot, Sridevi, for the introduction. Hello, everyone. Good afternoon, good evening, based on the time zones you are in. Let me just bring up the presentation. Fantastic. So my name is Tapan Kumar Joshi, as Sridevi introduced. I work with a company called Blaze, and Blaze is one of the leading AI edge computing product development company. We make platforms and systems which enables our customers to make their AI-based edge products, right? So let me quickly walk you through the quick introduction of our products. We make accelerator-based platforms as well as embedded platforms. And the heart of our products is our core IP called data streaming processor. So this is the processor that we researched for a couple of years, architected and designed, and it is definitely reaping the benefits of all the hard work that we have done. This is a 16-core system producing a performance of 16 TOPS with a typical power consumption of on an average 7 watts. The another salient benefit of our product is it is 100% programmable, right? So this enables AI developers to do Say, for example, you can develop your own custom model. You can build your own custom kernels, right, or custom layers and plug into your CNN or DNN models, right? So that's a benefit of this architecture. We also incorporated very efficient memory design, right, and certain optimization. And this enabled us to get a better memory utilization, right? Having less of a memory bandwidth traffic on the memory bus, having the lower latency, and as a result, producing higher performance, and definitely the higher utilization of the compute engine, which results into a better efficiency, right, of the compute. So these are the comparisons that you see. These are the comparisons like 50x less memory bandwidth, 10x lower latency. This is our own comparison with general purpose GPUs, and we have derived our benchmark results in terms of multipliers here. So these are our core products. We have segregated that into two batches. One is the software, right? So AI software piece has a traditional coding environment, the traditional SDK having, say, a low-level kernel driver, the compiler, the set of libraries, the vision driver, et cetera, right, including debuggers and profiler. The another environment is the visual code-free environment called AI Studio. AI Studio is an environment which is very beneficial for data scientists who want to stick to their core job rather than becoming efficient AI coders, right? So without knowing much detail about the programming, data scientists can make their models, can train their models, can deploy their models onto the hardware, and they can do inferencing very efficiently. Going to the hardware products, we have two main batches of products. One is the Pathfinder generation of product, which is embedded. Here we have SOM, which is a system on module product under Pathfinder. This is pretty small. I mean, a very efficient form factor. You can compare this with size of your credit card or debit card, right? It's such a small system on module package. The other is the Explorer. Explorer is our hardware accelerator product line. We have various form factors here. So you can get the half length, half height PCI card form factor. We have EDSFF form factor, which is enterprise and data center small form factor. And we also have the half height, again, half height and half length accelerator card with 4 SoCs on it. So this is to generate high compute for products that need this level of compute. For example, data centers, right? For example, the heavy compute that you need and acceleration that you need in, say, a video aggregator box, right? Which does which takes a lot of AI camera feeds and does the security surveillance, right? For example. Okay. Now we shall move to demo section. We will show some examples that we have executed with our customers in real world environment. And we have taken small samples out of it, and we would like to share with you here. Right, so the first example is multi-camera object detection. This we ran on our EDSFF card that you can see in the picture. We took 5 independent 1080p, that is HD video quality streams from 5 different cameras. Here for the demo purpose, I'm going to use the stored videos, but in real case, we took 5 video streams from 5 cameras. We fed that to 5 different YOLO 3 networks, right? YOLO 3 models. And we ran the inference in less than 100 milliseconds. So this is another example which is very typical in medical imaging industry as well as in automotive, right? So here we took a feed of a full HD camera stream and fused it with LiDAR sensor input and did the sensor fusion. So this particular sample, this particular demo, we ran it on our Pathfinder P1600 SOM system on module. This demo does some pre-processing as well. Same was the scenario even for the previous demo that I showed, right? So it uses ISP filters in the pre-processing. Then we are doing the semantic segmentation using a network called SwiftNet. I think many of you would know about it. And we are doing a sensor fusion where we are fusing the feed, the video feed from the camera and the LiDAR point cloud data, right, to do the sensor fusion and create the fused image, fused segmented image. So let me show you the demo.
Audio in your video is not audible to us, Mr. Tapan.
Oh, is it?
Yes. Can you replay it?
Was that the case even with the previous video or?
At least this video I couldn't hear.
Okay, sure.
It's better we play both the videos.
Okay.
While sharing, please enable the audio. Video sharing.
Okay. I'm sorry, I'm playing the previous one again.
Even now, we are not able to hear again.
Okay.
In the bottom left, share audio checkbox is there. That has to be enabled.
Okay.
Alternatively, you can share this video to us. We will play it after our session towards the evening. Shall we move on with the rest of the presentation, if it's okay with you, in the paucity of time?
Sure. I mean, this is really surprising because
We will surely share this after a few sessions or in between sessions.
okay. second. I don't know why you're talking about the features that I'm unable to. Okay, sure. Sorry. So shall I proceed with the previous one, the second video? At least I will. I'll be able to narrate it when we play it. Is that okay, Sridevi?
Pardon?
Can I play the second video and I'll do the narration of it?
Yes.
Okay, fantastic. Okay, so what you see here is we are feeding the bare image from the camera, right? And then we are using the ISP to convert that into the RGB stream, right? And post that we are feeding that into the SwiftNet network, which is a semantic segmentation network. You see all the segmented objects here, which are color coded, right? And finally, we are feeding that and clubbing with the fusing with the point cloud data from LiDAR, right? So this is the sensor fusion algorithm running, which is fusing two data and creating this image for vehicle to navigate. Okay, this is the third demo, which shows the multi-network use case on our Explorer, which is accelerator platform. Here we are using two back-to-back networks, right? The first network does the object detection. The second network does the pose estimation. So for detection, we are using YOLO2 here, and for pose estimation, we are using PoseNet. In the beginning of the pipeline, we are processing the input, camera input through ISP filters that you can see on the screen. And finally, we are doing the key point tracking. So as you know, the pose estimation, right, the PoseNet network that we are running detects the key points on body joints, right? So after that key point extraction happens, we are tracking those key points using a tracker called KLT tracker. So let me play the video and do the narration. So here as well, you would be able to see you'll be able to see the bare input, which is being fed to the ISP filters, the set of ISP filters that you saw on the previous slide, which cleans up the image, which converts into RGB, and that is being fed into the object detection network, which is YOLO2 here. So here on the screen, what you see is the programmability feature that we spoke about. So this is our VS Code IDE GUI, right? Where developers can code, debug, execute their written code, right? So this example was also, I mean, if there was an audio, we were also trying to show. We are also trying to show the programmability part of it, and by showing the VS Code Studio screen. Right. Here you see a tool name again, which is called NetDeploy. NetDeploy is our the conversion tool, which converts your model into an intermediate representation, does the quantization and pruning if required. A user can set it, and then generates an application out of it. An application which can be compiled and run onto the hardware. So this is a very intelligent tool which supports several machine learning frameworks, just to name a few: the PyTorch, the NetDeploy, Caffe2, Caffe, TensorFlow, etc. Right. Why we are talking about high accuracy here? Because NetDeploy also hosts our own researched optimization algorithm, quantization and optimization algorithms, which ensures that even with 8-bit integer, we retain the maximum 99% of the accuracy, and we boost the performance. Right. So this is more of, I'm sorry. So here is the screen that you see. The objects are being detected. Their body key points are getting detected. You see the pose estimation here. And the green arrows that you see, yeah, that shows the key point movement. So say your shoulder joint is moving towards some direction. So arrow would be pointed towards that. So this is the functionality of a key point tracker. This is the last two slides. AI Studio, as I told, it's a code-free environment that we have, which helps data scientists to do their core job, right, without having to learn the coding, right? So we also have a conversational assistant in this, where you can talk about what you want, or you can type, right, what you want, and then the tool takes care of giving you the proposals, right? And you make your own choices and go through the entire journey of making your own model, training the model, deploying the model, right? And getting the inference done. So a short presentation on that quickly.
Mr. Joshi, we are falling short of time, and in this presentation again, audio is not audible.
Yeah, sure. So as I said, this is the same flow where we talk about what we want to do, right? We want to build, say, for example, an ISP project, right? There are pick and choose kind of options available. There is something called Blaze Marketplace, which is our own marketplace where you can go choose your filters, build your pipeline, and do the execution. This also provides you the selection of models, data sets, which you can choose and train and deploy on the hardware, which is on the back end. We have our own Blaze hardware running. So it can be run in our environment. It can also be, the environment can be hosted with the user, that is a customer. So Sridevi, in interest of time, I think I'm just rushing through this one. But in summary, that is what this meant. User can also set a couple of optimization parameters, and this is something data scientist can understand, right? Whether you want to do a quick quantization or you want to go through the whole data set and do a detailed quantization in order to achieve the highest possible accuracy, right? So this is the example of deployment. If you see on the top, right, it shows you the complete flow. You added the data, you added the model, you optimize the model through the parameters given on the screen, and you deploy on the hardware. This is creating a deployment environment on the backend hardware. So this makes data scientists' life very easy, right? Or even for novice level of AI developers or developers who are not much kind of expert in coding and AI algorithms. I think that this tool certainly makes their life easy. So Sridevi, this was my last slide. Thank you, and sorry for the audio glitch.
I would request you to share your videos to us. We will ensure that they are shared to the audience at large in the next few hours, intermittent in between sessions. So thank you so much, Mr. Joshi. Thank you, and have a good day. So that's all, folks. That's all, folks. The product demos. Thank you for attending the product demos today. Now over to Mr. Kamal Jain, who will spearhead the next session. See you all tomorrow.
Thank you, Sridevi. Very interesting product demos from 3 different companies. Good afternoon, everyone. This is Kamal Jain from Blaze, and I'm your host for the rest of the day. So very welcome to you all. As we all know, artificial intelligence has been disrupting practically every industry that we can think of, and robotics is no different. The powerful combinations of robotics and AI or ML has opened the door to entirely new automation possibilities. And this is precisely the topic of our next session, AI ML applications for robotics. And the speaker of this talk is Mr. Vijay Seelam. It is my pleasure to introduce Mr. Vijay. Mr. Vijay Seelam is a serial entrepreneur with more than 25 years of experience in starting and leading deep technology companies. He founded Swaya Robotics with a mission to bring human-centered robots to help shape new production landscape that are adaptive, data-driven, and retrospective. Under his able leadership, Swaya has developed India's first collaborative robotic platform with pioneering advances in zero-code human-robot interaction, safety, advanced robotic perception, and adaptive workflows driven by AI ML. Prior to Swaya, he founded Zuti Engineering Solution and shaped it to be a leading provider of end-to-end solutions in development of highly engineered product and integrated manufacturing to help enterprise realize their business visions. Vijay started out as a product development engineer at Ford Motor Company in Michigan. After that, at Altair USA, he was a worldwide product line manager for optimization and CAE analysis products. Subsequently, he was director of business development for Southeast Asia at Altair. He holds a master's degree in mechanical engineering from University of Florida, Gainesville, USA. With that, I welcome Mr. Vijay Seelam for your presentations.
Thank you, Kamal, for your kind introduction. So I'll just bring up my share screen. Okay. It's okay. Yeah. Can you see my screen?
Yes, we can see your screen. You can put in the No.
Great.
Slideshow mode.
Good afternoon, everybody, and thank you, Kamal, very much for your kind introduction. So, as you said, and at the outset, thanks to IASA for giving me this opportunity to talk this occasion. So we had a lot of, I've attended a couple of sessions in the morning, excellent perspectives and presentations, and also in the last 1 hour, a lot of demos. And looks like machine vision is almost synonymous with artificial intelligence now. So my presentation is going to be slightly a little bit different. We have seen a lot of automotive applications, but we are going to talk and focus more on industrial robotics. We feel like industrial robotics is a prime candidate, the combination of robotics and artificial intelligence to really transform the, especially the manufacturing industry, if you will.
Mr. Vijay, sorry to disturb you. Can you put your presentation in the slideshow mode, presentation mode?
Yes.
That would be great. Thank you so much. Yeah, now all good.
Great, thank you. So I just want to give you a little bit of an historical perspective and where we are coming from and where we are heading to. Apparently, 2021 happens to be the 100th anniversary since the word robot was first coined by the Czech playwright Karel Čapek. And as you know, it was played, it was called Rosum Universal Robots, staged in 1921 in Prague. And you know, the rest is history. The reason I'm saying this, until 1961, we didn't have anything called a physical robot. The first robot was Unimate, and it didn't look anything like Apex robots. As you can see on the picture on the right, it's basically robotics has come to mean more as impersonating humans or taking human form, and a lot of negative connotations with it, especially when it comes to like employment and taking away the employment and all that, okay? So now the question is, how can this industry transform and where we, and what the industry looks like today? So most of the industrial robots are out there in some of the very mature industries like automotive, semiconductors, or like a clean room kind of manufacturing operations. And they're predominantly like caged behind safety fences because they're not safe to intermingle with people, or people are not allowed to go besides them because they're huge and they're not completely safe. So they're basically deployed for hard routine work, but they're not smart by any rudimentary sense, if you will. And one of the biggest barriers for wide adoption of robotics in other industries, other than automotive, semiconductors, and few others, has been one, they have not been very adaptable and they needed experts to program and operate them. And then safety is also one of the biggest concerns. And they needed highly structured environments to get them going. So when I say highly structured, everything had to be pre-planned and laid out. So any small disruption anywhere in the production line, the robots just would come to stall and then you would stop the entire production line. So, but that is expected, like, you know, in a mass producing industry like automotive and semiconductors, but not so in other industries, which are more discrete in nature and a lot of flexibility and adaptivity is needed. So now the question is, can we graduate robots to work alongside people? Because this is the need of the hour, especially in a lot of industries, because we don't believe that the robots are going to take away people's jobs. So it has to be a mix and match of both, to use the ingenuity and creativity of people and combine it with the precision and the reliability of the robots. So can we transform them from utilitarian to augmenting smart collaborators to human beings? And now, Swaya, we have started this company on this premise, and we definitely believe the advances in artificial intelligence can make a transformative changes, especially in robotics. And we can bring about to connect people, process, and purpose to make the manufacturing environments or wherever the robots are deployed in different environments to be more adaptable, data-driven, and responsive. Swaya is a full stack company, and our platform, we call it unrestricted robotics. And the reason we say that, we have, you contrast this to the current industrial robots, which are one, very expensive, and which take a lot of expertise to program them and deploy them, and then a lot of bells and whistles go around them to really make them work. So your production line, the entire production line has to be planned and structured. But in contrast, what we are saying is we can have these robots like, especially the human scale automation, we call it like 1 kg to 20 kg payload robots, typically where human beings are deployed and work. Okay, the payload may not be an issue, but definitely it could be an occupational hazard if you're doing repetitive work. And in today's world, as your education levels are increasing, you have a challenge of finding the skilled people wanting to work in manufacturing, especially the dull, dirty, and dangerous jobs. And you need something to take over this. And these robots, you can just unbox them, and within 1 or 2 hours, you can get them to deploy for automation of simple tasks. And this essentially relieves the human worker for essential work or more creative work. And then comes like, how we can mix and match with people, and where we can augment the people, where people are used for more creative and thinking jobs, as I said before, and the robots can be deployed for more precision and reliability, where we can increase the combined productivity of people and robotics. And the Swaya's unrestricted robotics platform is completely ready for autonomy. We have, and in the future, it's going to be more and more software driven from the virtual space, rather than you deploy the hardware once, but it's essentially software is what is going to drive the automation or the robots. And now that's so much for Swaya. I just would like to focus on the artificial intelligence, the challenges and the applications in the industrial robotics area. So the 3 main challenges as you come across in industrial or warehouse robotics. One is understanding the environment around it, which we call the ambient intelligence. So the robots need to know what's going around them. And then the contextual intelligence, which are how things are changing dynamically around the robots and what do they do with it. And third one is the task intelligence, which is more intrinsic and intimate understanding of the task at hand and how they can get better at it. And the ambient intelligence, or the understanding of the environment around the robots, is a pretty well understood problem. And in the last 10 years, there have been a lot of companies which have been designing robots and also applying a lot of advances in machine vision in warehouse kind of applications, or even in service sectors. The contextual intelligence problem is a little bit a tough one to crack, because this is what human beings are very good at. Even the robots, even as we speak, they don't come any close to even a small kid, because this is very innate nature of what is to be a human. So we perceive things very quickly, but the robots have to be told explicitly. Now, can artificial intelligence and machine learning, the advances in there, can this change? Because if it changes, this can open up huge application areas to penetrate for robotics into. The third one is the task intelligence, which is, if you take one example in the industrial area, the understanding of the geometry of the task, essentially the features, the color, the size, grade, and things like that. Some advances have been made there, but still there's quite a bit of work that needs to be done. And as you could see, like from what I said just now, the implication is that these models have humanistic learning features. see more like how humans learn about things. So it's not necessarily us as adults, but if you have somebody starting out in a kindergarten, right? So one is the communication, and then you learn more as you get more experience and you keep practicing. And if we have to apply artificial intelligence or machine learning in robotics, and they're not going to be any different, but with different nuances and different flavors of it. Now, the four pillars or the framework for implementing or application of AI in robotics, as we see it, is one is the problem of sensing, then the perception, then the decision and policy, and then finally the execution through the robot. See, at the end of the day, robot is a physical manifestation of what you think in the virtual space, and which could be your artificial intelligence or machine learning, and how we are going to deploy that and get things executed in the physical space. So through this, we can make or physical actions more and more intelligent. So now the sensing, we have heard a lot of presentation, nice presentation about edge computing, and definitely this is quite relevant, and this can make a lot of things applied in robotics, especially the sensing, because one, you have the sensors inbuilt into the robots, like your vision, or it could be your encoders or proprioceptive sensors like your accelerometers, gyroscopes, and things like that. And then you also, because robot is not an entity that's going to work by itself, especially if you're talking about the industrial environments, because they have to coordinate with other machines or with the rest of the ecosystem. So, which obviously implies that there are going to be other sensors which it has to talk to and get data from, right? Or it's a bidirectional or a multi-directional communication, because there are a lot of agents involved in this environment. So now in the perception, you need some kind of a sensor fusion where we are going to integrate this data both from the inbuilt robots and also the ecosystem. And we can bring about a comprehensive awareness or understanding about the environment to the robot. And if anything is changing in the dynamic environment, we can pass on the cues to or the robot will notice the cues, right? So that it can plan its motion or actions in real time. And later, I think we'll show with a couple of applications how this is going to be. And then once you have the perception, obviously you need a decision model or the mental models of the robot of how it's going to assess the motion or plan the maneuvering. And also when we're talking about robots getting involved or intermixed with people, safety becomes a very important issue, and there are a lot of regulations here. So obviously these all have to be complied and built into the models. So which is basically the policy, if you will. And then the robots may be working along with other robots, and they need to coordinate with each other. And then finally, the execution. So you need to execute this decision through the robot's actions. Now, although we are saying like, the electronics and the technology sector is concentrating more on the artificial intelligence, machine vision, and a lot of edge computing or cloud computing, and a lot of this kind of technologies. But the robot we see right in the physical space is a complete whole product, and they are completely interrelated to each other, because how robots are constructed, their kinematics and all those also matter to make some things possible, and some things could be hindered because the way things are done in the physical robots. Now, as you see here, the sensing is definitely, I think, edge computing can bring about a lot of changes here, especially in the robotic vision, and also, especially when we are talking about a large factory and we have to coordinate among several robots. And we also want to know what is the trending data in the production line so that we can make it more data-driven and more objective. And the robot also seeing the data, learning from the data, and getting better and better every day. So edge computing becomes very important. And then of course, there's some challenges here, how we are going to integrate, because the form factor is a very important issue. And then for the sensor fusion, so partly can it be done on the edge for simpler applications, or probably we have to go to cloud for, especially for perception or sensor fusion with, like, integrating the data from the robot sensors with the environmental sensors. And then, of course, the decision and policy making. Are we going to do this like the decision models constructed in the cloud, or like dedicated computers which are tethered to the robot? And tethering the computing device to the robot is also a restriction itself. But in the industrial sector, we have what is called deterministic communication, because you don't have your regular Ethernet and all that, but we have more like field bus kind of communications like EtherCAT, Modbus, DeviceNet, Profinet, because you can't use Ethernet IP as it is, because you're sending the packets, and sometimes the difference between life and death can be a split second. So you can't afford that there. But with the 5G technology and wireless communication, the expectation is that it's going to be a lot more reliable, and this can unchain or cut the umbilical cord from the robot to the master controller, and it can communicate in the cloud. So that can remove a lot of restrictions of how the robots can be deployed. And now coming to some of the applications, one of the challenges is object detection, and AI and machine vision especially can play a big role. Apart from, here the basic challenge is, one is obstacle avoidance, especially if we want the robots to be working in human-infested or human-centric environments, or they're coordinating with other robots. And more so if the workspaces are unstructured. So let me say, qualify this. When we say structured, everything is planned and everything is deployed as per the plan. But in unstructured environment, things could be not necessarily planned. They could be say, for example, a fixture could be slightly oriented differently. But if you can tackle this problem of allowing the fixtures or the objects to be placed slightly different, and not necessarily creating specialized fixtures to position them accurately, right? This can remove a lot of barriers, although this sounds very trivial, but it's a big deal actually. So this can make robots even more, much more adaptable, especially in SMEs, small and mid-sized companies. So obstacle avoidance. So yeah, you have your humans and other robots, and if they're moving into your space, then how does the robot recognize that and then come up with an alternative plan so that the robot and the people are completely safe. Then shape and size is another different challenge altogether. Again, this looks very trivial even for an infant. You can handle it very easily, but for a robot, it's not that easy. And then other thing is, especially in a dynamic environment, things are moving, the approach and time of flight, all these things become an issue. So, so there's a lot of learning and learning models, and especially the computer vision and artificial intelligence can have a huge impact in coming up with new applications in this area. And one more application is the manipulation, if you will, the fine tuning, the final process of the robot acting on its action. Like say, for example, gripping. What is the gripping strategy based on the size, shape, orientation, or even the texture, right? So as you can see on the left-hand side, the shape of the object has to be known for the robot to plan its gripping strategy. So for example, if you have some kind of a pyramid shape and if you hold it at the tip, then it's going to fall off. So that is something that it has to become cognizant of. Then on the right-hand side, you see there is flask with a glass flask with water. Obviously, it has to be handled more sensitively. If you apply excess force, then it's going to break. Then you have a lot of different kind of permutations and combinations in the industrial area, where you have like soft materials and then they're juxtaposed with hard materials. So we need to know how much force is applied and how they have to be oriented and fixed with each other. Then, and more recently, especially in the light assembly, if you will, like in electronics applications or assembly in cell phones or even a lot of other electronic assembly applications. You have like, we need tactile sensing because these are very sensitive parts, especially if you are inserting some of these parts onto the PCB, the connectors and things like that. If you apply excess force, then the parts are going to break. So you have something called tactile sensing incorporated into the robot, especially in the end effectors, if you will. So they basically give you a force feedback or a torque feedback, and basically based on that, the robot can adjust itself. And we teach the robot with several, like, multiple examples, and then it can start learning a little bit about the properties of the material, and it can act accordingly whenever it sees or faces that. And another good example is when we are doing a complex assembly like a gear, because as you can see here on the right-hand side, we are trying to assemble the gear. This can be a very trivial thing for a human being, but for a robot, because if it's not going to slide in perfectly, then you might end up damaging the parts. So here we have what is called a wiggling, and the wiggling is based on tactile sensing. It has to sense forces in all the 6 directions so that the part gets inserted correctly without damaging the assembly. And a lot of applications on inspection, especially with machine vision and artificial intelligence. The companies which are implementing this as a standalone product, but this can also be done with robots, especially if you want to implement in-process quality control rather than you produce it and take it to the quality room and do the checking there. So this can save a lot of money and a lot of time for manufacturers. So especially the defect identification, you have the parts, and if there's a certain part that has not been assembled properly, or like, there was a defect during the manufacturing assembly part process, how do you detect that? And if you detect in process, then probably we can stop the assembly line and prevent other similar kind of damages happening for other parts, and you can end up saving a lot of money. Otherwise, it could become a costly affair, which we see all the time. And today, even
can I request you to conclude in the next 2 minutes, please?
Yes, yeah.
Thank you so much.
Yes. And then surface quality is another thing. And then functional verification, as you could see in the middle video, like, where we are using the tactile sensing, we are trying to verify the capacitive touchscreen of a tag. And you can see here, you have to apply gent was depending on whether it's a glass or what kind of material it is. And so you have also can detect missing parts in the, like, especially in complex assemblies like PCBs and all that. Now, this is my last slide. Just to conclude here, as you can see here, artificial intelligence has the potential to make robots as ubiquitous as personal computers in our lives. We wouldn't have imagined 40 years back that computers would become so pervasive in our lives, both at work and at home. And maybe with all the advances, both on the hardware side and the robotics, and also combining with artificial intelligence and edge computing and the cloud computing, in 10 or 15 years, robots, we might take robots for granted, both at work or at home. And they might become as ubiquitous as your personal computers. And now the product community where we come from, where we're building the end product, we have to overcome several challenges to make it happen. And we have a lot of technologies, and I'm hoping that they're taking notice of this one. So the 2 challenges, one is the physical stack. The adoption of technology into products poses several engineering challenges, especially the form factor, the thermal issues, cost, processing power at the edge. and the reliability of the communications, and so on and so forth. And the other one is the software stack. Now, creating training models requires data, and this is a big challenge, especially in unstructured environments and especially with small and mid-sized industries. Although we are tackling a small subset of the problems like in warehouses and pick and place or packaging, but there's a huge number of applications that are yet to be tackled. And this is where the data is lacking, and this data has to be created on the fly. And this is where the human-robot interaction becomes even more important. And humans can act as mentors to teach the robots, and then as the data is getting generated, the robots can also keep learning and keep getting better. So for this, we have a paradigm. We have our human-robot interaction platform is based on a paradigm called learn, teach, and learn. So where both the robot and the human is learning, and while you're learning, the human is also teaching the robot. So you don't have to run tons of materials. As I said, you can unpack the robot and you can start using it in 1 hour. And then as we go, as we see more data and we learn more from the task examples, we are also learning both. And then robots can become good augmenters and good collaborators for humans. And I think that's basically what I had to say. Thank you.
Thank you very much, Mr. Vijay. A very, very interesting topic and very, very interesting presentation. And I want to thank you for your time and participation in this AI Summit. In the interest of time, we'll skip questions, but take those offline. So
Sure.
Thank you once again, Mr. Vijay, and we'll move to the next session.
Thank you, Kamal.
All right, next session is a panel discussion. And we have all the panelists lined up. And since the early 90s, the IT and IT-enabled services sector in India has been of tremendous importance to economy, eventually growing to account for 7.7% of India's GDP in 2016. In an attempt to capitalize on this foundation, the Indian government announced in February 2018 that the government think tank, which is Niti Aayog, will spearhead a national program of AI focusing on research. The question is whether India will see a similar growth in AI software as we saw in 90s with IT. Let us try to understand it through the next panel discussion, which is India's role in building AI software. It is my pleasure to introduce the panel. Please welcome Mr. Manish Singhal, founding partner Pi Venture. Manish Singhal, a 1992 graduate from IIT Kanpur, is a technologist turned entrepreneur turned venture capitalist. He aspires to help put India on deep tech innovation map of the world through his work at Pi Ventures. He brings 28 plus years of experience across diverse set of fields, building cutting edge deep technology products at global scale, mentoring startups, investing in them, and building a deep tech venture fund. Manish started Pi Venture in early 2016 with the vision of accelerating the development of artificial intelligence startups in India. His ability to have a deep level understanding of technology helps to fund in evaluating tech startups in a unique way and build a reputation of being a lead investor for AI and deep tech startups. Before Pi, Manish co-founded letsventure.com and led it to become the leading marketplace for startups and early stage investors in India. After completing his electrical engineering from IIT Kanpur, he was instrumental in building products and team in different startups and established organizations like Sling Media, Lithium Systems, and Motorola. Welcome, Mr. Manish. Our next panelist is Mr. Purushottam Kulkarni. Mr. Purushottam Kulkarni has been working with Microsoft for more than 30 years in product engineering. He relocated to India in 2002 from Redmond. His expertise include leading incubations and concepts to shipping products with a strong passion and focus on user experience. He has engineered multiple products, including DOS-based productivity apps, developer tools, Internet Explorer, data storage, and currently leading customer success engineering and office intelligence team in India Development Center. He spends a lot of his time to mobile productivity applications. He's a graduate of Pune University and has master's degree from Florida Institute of Technology. Please welcome Mr. Kulkarni. It is my pleasure to introduce Mr. Karthik Natarajan, President and Chief Operating Officer of Cyient. Karthik Natarajan joined Cyient in March 2020 as the President and Chief Operating Officer. In this role, he is responsible for global business operations, including sales, delivery, and business development. Karthik has over 27 years of experience in the engineering industry, including about 21 years from the engineering technology services, with a strong focus on product development, digital transformation, and R&D. He has been instrumental in implementing engineering strategies for Fortune 500 customers, developing market expansion programs, driving partnership, and enhancing domain expertise across industry verticals, including A&D, automotive, telecom, industrial, and medical devices. Karthik is widely recognized as a thought leader across the industry and also serves as a co-chair of the Engineering Services Forum at NASSCOM. Before joining Cyient, Karthik was the global head of Tech Mahindra's integrated engineering services business, including digital technologies like mobility, IoT, and Industry 4.0, among others. Karthik holds a degree in mechanical engineering from the University of Madras and MBA from Symbiosis Institute of Business Management, Pune. A very welcome, Mr. Karthik. Our next panelist is Mr. Kaushik Raghavan, Head of AI ML and Data Science at Micron Technology. Kaushik Raghavan is an AI ML leader, data science enthusiast, and software product engineering expert with hands-on experience in designing and building AI ML-based real-time analytical engines and recommender systems. Prior to joining Micron, he has led data science teams in Flick Inc., Applied Materials, and successfully delivered ML products across the semiconductor business spectrum. His areas of expertise include virtual metrology, recommender system, predictive modeling, prescriptive modeling, cognitive analytics, high-frequency time series data analysis, n-dimensional mapping, spatial analysis, statistical and stochastic modeling, NLP, and combinatorial optimization. Kaushik has, to his credit, 20 plus inventions, including 6 patents with the USPO and several publications. Kaushik is a mathematics graduate from the University of Madras and holds a master's in information technology from Anna University and another master's in degree in computer science from Chennai Mathematical Institute. Please welcome Mr. Kaushik. Our last panelist and also the chair of this panel discussion is Mr. Ajay Agarwal from Happiest Mind. He's a serial entrepreneur. Ajay has been instrumental in building world-class products and led multiple startups from incubation to successful exits by building high-caliber teams, adapting to dynamic market conditions, and demonstrating keen understanding of customers and market needs. His Silicon Valley-based startups were funded by likes of Intel Capital and Philips. His most recent venture, Cupola Technology, an IoT engineering company, was acquired by Happiest Mind in May 2017. As a senior vice president at the Analytical Center of Excellence, he spearheads this group of leadership around artificial intelligence, data science, big data, and data engineering, among other innovations. Ajay holds a master's degree from BITS Pilani, Rajasthan, and is a speaker at various industry forums. Please welcome Mr. Ajay and the entire panel once again. I now hand over the stage to Mr. Ajay to chair the session. Thank you.
Thank you, Kamal, for the kind introduction. A warm welcome to everyone, and I'm sure all of us will be looking forward to this session and discussion around India's role in building AI software, especially with our esteemed panel around. As we all know, India is the third largest startup ecosystem in the world. And what it means is that most of us in this fraternity get to work and experience the latest cutting edge AI technology, and more importantly, the transformation at our own backyard. AI, as we know, is touching across all aspects of our life, right from the AI-driven decisions that are powering our loans or claims approval, the autonomous cars or the AI-assisted vehicle, which is powering our commute, the conversational AI-enabled digital voice assistants, which are actually empowering us with the information that we need, and more importantly, getting it in the context and the channel that we prefer. Similarly, at our workplace, we are adapting AI tools to improve the operational efficiency, all around. AI also has been leading the way in the product and the software development across industries like digital health, where lot of on-demand healthcare, early and accurate detection of diseases, the predictive healthcare, asset analytics around adoption of wearable devices, drug discovery, etc., are all finding great adoption, with the advent of AI. Similarly, in the e-commerce space, which is heating up, we have seen AI improving the customer experience, at the same time help manage the operations at scale, and also allowing a lot of startups and businesses to innovate their business models. There's wide scope of adoption across industry, and having said that, I think we are just at the start of the journey, and there's a lot more for us to continue and reap the benefits of AI. More importantly, there is a lot of initiatives that are happening, with the government, like Government of India with the AI for All program with Niti Aayog, and the Digital India intends to leverage AI in the sectors of healthcare, agriculture, and e-governance, both for India and the global market. Given that context, what seems very exciting for me is that, from an India perspective, unlike in the past, AI, I see that academia, industry, and government, all of them are coming together to accelerate the adoption by enabling various aspects like availability of infrastructure, the adoption of digital initiatives, aligning policies, and incentivizing and promoting the talent as well as the startup, among other initiatives. What we intend to do as part of this discussion is to touch upon some aspects on entrepreneurship, some exciting use cases and transformation involving AI, enablers in terms of the infra and the platform, and more importantly, the objective would be to get you the relevant perspective for you to succeed as an entrepreneur, as an engineer, or a decision maker for your, for your organization. Now, with that, a small context setting, and I would once again welcome Karthik, Purushottam, Manish, and Kaushik to this panel discussion. And let's try to figure out their opinion on India's role of building AI software, and more importantly, why there is so much excitement around this area. Karthik, you want to go first?
Sure. No, thanks, Ajay. First of all, good morning, good evening, everyone, depending on whichever part of the world that you are joining this session from. And thanks to IESA for inviting me to be part of this panel. And first of all, I want to start off by saying that the artificial intelligence that is being talked about is getting more into augmented intelligence. I think it is not about replacing jobs. Yes, it will at some point of time, but it is going to really make a lot of our jobs easier. And given what India has been able to do on the IT and ITES with about $190 billion industry that has been built over the last 3 decades, and this is likely to grow to $500 billion by 2030. I think this is very important segment of digital technology that is going to really pioneer our growth. And the second aspect is this is more for global customers. But if you also look at for India's own survival, I think whether it is about private corporates or government institutions or any of the agencies, this is going to be the biggest lever of differentiation. This is going to be driving the competitiveness. This is going to really improve the productivity significantly. And this is really going to make whether the healthcare for all or education for all, or to secure our cities, to make sure that all the citizens are living safely and securely, and to deliver services to citizens. I think you take any walk of life, I think AI will be pervasive. And there is absolutely no question in my mind saying that we have to really start nurturing AI as a key differentiator for the country, for the corporate, and as an individual engineers or people who want to really be employed in this country. I think this is going to be a most important element for everyone. The second element I also want to bring out is about the consumer related artificial intelligence versus enterprise. I think it is definitely known how well things are getting personalized, whether it is e-commerce, retail, or media and entertainment. How do I really get my recommendation engine which reads or which knows about what is my preferences and all of them? And banking, financial services, insurance, I think this is essentially very well known. But I think the biggest adoption for the next 10, 15 years is going to be around the enterprise side. I think every leading enterprise, whether it is in manufacturing, healthcare, or anything on logistics, transport, I think all of them have to really bring in AI as a key differentiator. And in the next decade, you will find that the enterprises would be segregated, like the rich enterprises and poor enterprises. The enterprises which are AI-led and the other enterprises would be classified as miscellaneous. And India is likely to add about $1 trillion to the economy on AI. over the next 15 years. And we already have about 250,000 people who are employed in some form of analytics and AI. And we need about 1 million engineers in the next 5 to 10 years. How do you think we are going to add 1 million more engineers who will really bring the thought leadership? US and China have taken a significant lead. I don't think India can afford to wait for some more time. And the amount of patents, the amount of research that is happening across facial, text, speech, or video analytics, I think there is significant amount of progress that has been made by US and Chinese startups and governments and private enterprises. I think India has to catch up, and this is going to be a decade for India to catch up on this front.
Thanks, Karthik. And very interestingly, you brought up the point of AI being a differentiator across the industries, and the other important aspect around AI being augmenting human rather than replacing human. I think with that, Purushottam, what is your viewpoint on this topic?
So first of all, thank you, Ajay. Thank you all the panelists, and good afternoon to the audience. Well, good afternoon from my side, based on the time zone I am in. I truly appreciate you taking the time to join the session today, to all the audience. So thank you. Let me talk about why this is such an exciting time for India, right? Worldwide, this whole phenomenon started. I was just reading Manish's article on AI, and yes, he talked about, AI has been in winters for decades, right? So in some 1956 or thereabouts, some research started in Dartmouth, I think I got the name right? And, since then, it has kind of lived in that narrow band of innovation for a number of years, right? Now, what makes it then opportunity for India, right? And I think the way I look at it is, this is our opportunity to show the leadership in building the intelligence services and software. I equate this to the VNext of the software rally that started in the 80s. So Ajay touched upon it a little bit. Karthik talked about in the large numbers of software analytics roles that are already existing in the industry and other things, right? So it is like the rally that started in the 80s, which continued to accelerate in the 90s and into the new millennium, right? And in now 2020, we have all the ingredients to kickstart. It's almost like a get, set, go kind of a state that we are in building all of these services, applications, whatever you want to call it, right? Just look at what we have in front of us. We have a large number of skilled software and hardware engineers, right? We only talk about software engineers all the time, but hardware has played an important role in this. Innovations have played an important role here, right? We have world-class AI researchers. Just look at the number of AI research papers that are originating from our region. It's a large number compared to what it was 10 years back. You'll see that number almost kind of like a hockey stick kind of going up every year, right? We have lots of advances in the hardware, like the NPUs, the data transfer speeds, like in 5G, that are happening. Every university is also augmenting their curriculum to incorporate the data science basics, the basic analytics, and all of those kind of basic skills, right? In addition to that, we have the proliferation of the smartphones, the smart devices. I read somewhere that by 2021, the number of smartphones is going to be some 760 or 750 million, right? That's 3/4 of a billion devices, and these are just the smartphones. There are going to be many other devices that everybody keeps talking about, to make the entire space intelligent. And on top of that, we have this new generation of entrepreneurs, right? Government is kind of promoting that. The entrepreneurs are ready to take those risks. We have venture capitalists who are kind of helping them. We have mentors who are kind of helping them as well. So put all of these things together. When you put all of these things together, it's very clear that we have the huge potential to innovate in the space of not only on the service side, server side intelligence, but on the edge kind of intelligence, to kind of ethically and responsibly build these intelligence services. One of the things that Karthik said was about, hey, the enterprises are the ones which are going to be the next phase, right? There's a lot of consumer intelligence personalization already in place, but the enterprise is the one that is going to take space. And I absolutely agree with it, because that's where the building these services, building these solutions in an ethical way, in a responsible way, keeping the privacy, keeping all of these stringent compliance requirements in place, is going to give us the edge in building all of these solutions. In all, we are kind of sitting on this gold mine, right? It's a gold mine of all of these pieces if you put them together. And that's what excites me. That's what is exciting for me. I started my journey as a software engineer. I've been software engineer all my life, right? But this new aspect is something that is truly exciting, is like truly a learning opportunity for me personally as well. But for the industry, I think this is where we will go forward in the next decade. And this is our time.
That is fantastic. So when there will be a lot of people who will resonate that they will remain engineers for life, me being one of them. Now, I think couple of things that you actually resonated well was that this is our opportunity to take leadership, and there are signs around it, signals around it which we should pick up. And the other aspect is the ability to use AI responsibly, and again, to do that, you again go back to Karthik's point where you look at, augmenting human to basically eliminate those biases and make those, software better. Manish, now, coming back to you, I think you bring a very interesting proposition to the table. You have been, technopreneur or an engineer yourself, and then from the last decade plus, you have been actually enabling the ecosystem, startup ecosystem in India, around the AI and deep tech technologies. It'll be interesting to hear your perspective on this topic.
Sure. I think one experience summarizes how AI has grown in our own mind. When I was raising money for our AI thesis back in 2016, one of the investors asked me, I know Air India needs money, but why are you raising for them? And today, if you look at it, even a kid knows what AI is, right? So that is the kind of mindset change or exposure change that has happened to a technology like artificial intelligence today. With every such thing comes a lot of hype, comes a lot of crap, if to use that word. And in that haystack, you have to find the needles. That is my job. So I think what I'm excited about AI is not the general propagation of AI, which may be useful and may be important. But what truly excites me in my capacity as a venture capitalist is companies who are using AI to solve disruptive problems. So what does that mean? I'll give you 2-3 examples from our portfolio. We have a company called Iesa, which has created a whole mental health conversation platform using AI, where you don't need to talk to a human therapist, but a Iesa platform can actually help you resolve your anxieties and depressions and whatever it may be, right? It's very, very difficult problem to solve, but these guys have done it, and they have now 3 million plus users across the world. We have a company like Niramai, which is solving breast cancer screening in very, very early stage using thermal and AI. We have Locus, we have Pixis, which does marketing automation. So generally what we have found is that if, and this is very heartening for me to see, because I have seen last 30 years, we were primarily a service nation to say, and then we sort of somewhere became product nation or did not become partially done. But I think truly we can become a deep tech nation in the next 10 years, where we can find these global problems which are getting disrupted on the back of good use of AI, in a very smart way of use of AI, and solve those global problems right from here, from India. That is what truly excites me about AI.
That's fantastic, Manish. And I think truly AI is everywhere, and that gets symbolizes by the amount, by the investments that you have done in the health tech, logistic, and marketing companies. So pretty much covering across various domains. Coming to your Kaushik, very interesting profile from maths to data science to all different aspects of data science, from recommendation to advanced analytics. You have covered it all. It will be good to understand your perspective, especially from a technology point of view.
Oh, thank you, Ajay. And it was wonderful statements put forth by the industry leaders. And interestingly, I come from the software side of the hardware, right? So I've been in the manufacturing for almost 2 decades. And one of the things that has really amused me today is the amount of data that was collected, right? So I look at it as 2 sessions. One is pre-COVID, the other one is post-COVID. When I started in the technology around 180 nanometer, and they were talking about 90, and then 65 was in the R&D, because they always work on n+1 and n+2 nodes, right? And now, from then to now, if I look at it, a typical wafer, the amount of life the wafer spends on the chamber going through the process is still the same. It's about 120. But then how do we create, because we don't have too many fabs. The fabs are shrinking, it's getting consolidated. And how do we achieve the volume that we have seen today is purely based on the amount of data collected and analyzed. The best part is, in the entire 120 days the wafer spends, right, it either sits going through some thermal changes on top of it, or waiting for an inspection to be done. An inspection being cost. There are multiple ways in terms of different algorithms started from India 2 decades back. I can proudly say that I would probably be the first generation to have been in India, gone through the global problems, solving global problems, by having one foot in India and one foot in the air on the flight, not on Air India though, but in the flight to solve the global problems, right? So today, every minute the wafer spends generates about 1 million data points. And imagine today we have end-to-end traceability on the wafer front end for the entire 120 days of whichever tool, whichever process line, and whichever chamber, and which node and which chuck. Now, post-pandemic, this has exploded by means of digitization, right? So the entire organization are looking to digitize, and what they say is they can gain up to 18% of their revenue as a value kickback when they digitize multiple value chains, right? And that's predominantly, we are looking at $1 trillion, as Karthik said, and this is tons of money that's waiting to be. And not only that, today we are even collaborating with our suppliers and our clients, customers as well, so that they create this end-to-end traceability. This is not something new, because if we look at pharma, this existed, because it is a drug which goes into the field. Let's say the drug starts behaving differently after 10 years, they would need to go back and prepare an antidose and trace all the things that had gone into it. Aviation had it almost 50 years back, and they were pioneers. Those things were there predominantly because it was touching people's life. Today, it started coming because we are enriching people's life. So as much as the value that has come into the life, today the time is also equally valued. And these are the things that are coming back to it. And today I'm sitting at a place where I look at end-to-end traceability pre-silicon. So this 4,500 steps, all I talked about until pre-COVID, talked about the entire front end, right? There is a whole life before the birth of the first design. When I say the design is ready, the chip is ready for, let's say, for a data center for Microsoft, or a particular memory that goes into any of our hardware, there is a whole new world of pre-birth. And this is where we are working towards complete traceability. And that's really exciting. And reflecting back, AI, when the whole world started AI, predominantly it started in US. India was very quick to adopt because of our very, very strong math DNA, right? Be it Aryabhatta and Bhaskara 5,000 years back, or to Shankara and Madhava in the medieval period, or even towards the millennials, right? We talk about Siddhar, you talk about Sankarsha, you talk about Ramanujam, right? So math has been, STEM has been our strong point, right? Whether you call it as trigonometry or 3D geometry in canonical forms, we've been able to measure the Mount Everest even without having to scale it, right? That was possible. All we are doing is we are taking our software knowledge, which gained over the last 4 decades, and marrying it to our math DNA, probably activating it and combining that to provide this. And in fact, one of the article Karthik wrote last September, if my memory serves right, for NASCOM, right, engineering R&D space. So he talked about how the engineering R&D, we have about 1,200 global development centers in India, and close to 700,000 engineers working on it. And it's about $100 billion value waiting for us to go and grab a pie. And then on the other end, we have a $400 billion software market. And this AI in software is definitely as much as the engineering R&D, and definitely.
That is, I think, fantastic, Kaushik. I think, you gave a great perspective on the pre-COVID and the post-COVID.
Yeah, right.
And more importantly, how India is adapting and playing a larger role in this, in this field of AI. Moving on to the next discussion topic, Manish, I want to come to you. You have been in forefront, in terms of investment in India around startups in the AI technology. And to me, it seems that the PE and the VC community has a view that anything to do with AI related solutions, they have to be valued, valued better. Now, as an early investor in this area, especially in India, how has the focus and the maturity of the startups evolved over time?
I not necessarily agree with that philosophy that it has to be valued differently. I think I keep saying, actually, at least for us, we are an AI focused fund, but we don't look for AI companies. We are very, very clear about that. What does that mean? We look for companies which are solving problems in logistics, in problems in marketing automation, healthcare, etc., powered by AI. And that is a fundamental difference. If we put AI first in the whole thing, then it just crashes the whole thinking about what problem we are solving. And they get valued by the business they're solving. Now, sometimes what happens is, and I'll give you a couple of examples. One of our companies went from $0 to $9 million in ARR in less than 16 months. At least in last 20 years, I've been involved in startups. I've not seen that kind of growth in any company, right? And why is this happening? Because what they did is they used AI very smartly, and they were able to turn that problem statement around and solve it in a very disruptive, we call it the 10x way. And suddenly you find all customers coming to them, all investors coming to them, everything coming to them, right? So essentially, it is about the goodness of the solution more than just being an AI company. If you are doing peddling incremental innovation, then your life is sucked out. You will have pricing pressures, you will have competition, etc. So what we look for again is that disruptive edge where you are able to solve that problem 10x better than anybody else. And then because you're solving that problem 10x better, it attracts capital, it attracts customers' capital as well as investors' capital at a premium pricing.
Fantastic, Manish. So basically, it's a business first, enabled by AI is what we are,
absolutely
looking at. Now, Kaushik, coming back to you, you bring in a very, different perspective from a technology perspective. Both you and Micron have been hugely focused on enabling the compute infra, especially around the memory. At the same time, you have customer-centric solution. Can you share your perspective on the change in the landscape in terms of how it has enabled the acceleration of AI?
Oh, definitely. So if you look at Micron's results over the past, every 6-7 quarters, the demand was fairly, by the NAND and the DRAM, and predominantly driven by the mobile and also the memories associated with the data centers. We are still waiting for the surge to open up for 5G. That's without taking 5G into account. So if you look at the whole, let's say if we look at Microsoft's backbone, right? Micron provides the memory. So predominantly the focus is about having an in-compute memory, and where we at an R&D center create softwares at even at firmware level, which can quickly react at the chipset level, at the hardware level, make some decisions at the root real time. So you would have come across this chipagadon term that came up recently, where most of the production car companies stopped their production because the chip shortage, right? It was not just restricted to high-end cars where we say, oh, it's all high-end cars, everything is electronics. Most of the normal cars, which has these ADAS systems, right, had been put on hold, and predominantly because these things are required to make decisions at the compute level. And as soon as you get a hardware looking at an image which is predominantly large, it has to be processed and reacted and course corrected almost immediately, right? Whether we are looking to channelize their thing, or blind spot detection, or an autonomous emergency braking. So all these things are coming into place to enrich people's life. So going back to the memory, the in-compute memory, where VLSI design, as Purushottam also rightly said, right? It is not just the software. There's the hardware and the software. How do the software enable the
I think let's for Kaushik to
marrying these two is the key.
Sure. Thanks, Kaushik, for that. And I personally have seen the exploration in the huge amount of growth in data, the ability to consume data, the focus, coming from enterprises to mine data, and obviously the infra has scaled, to basically make that happen. Coming back to you, Karthik, you and Cyient have been at the forefront of enabling digital transformation for various industries like energy, utilities, aerospace across the globe. What are the key digital transformation stories augmented by AI that we'll want to share with us? And also, more importantly, if you can give the India context around those stories, it will be helpful to us and the audience.
Yeah, sure. Thanks, Ajay. Very interesting perspective from other panelists as well. So to start off, what I also want to take us to the last 30 years. If you look at what has happened in terms of whether it is compute or storage, and the storage cost of a GB was about $500,000. Now it is about 5 cents in 30 years. So you can imagine that it has improved by 10 million times. And with compute, which is going to be available at near edge or close to the device, and with cloud, I think this is going to really be ripe for disruption in terms of the number of use cases. So what will happen is whatever the use cases that we worked on in the last 5 years may not be relevant for the next 10 years too. Because the reason why I'm saying that is there is close to about 45 zettabyte of data that is available today globally. And interestingly, 80% of this data has come in the last 3 years. And this 45 zettabytes is likely to be probably 175 to 200 zettabytes by 2025. And interestingly, the 3 years of 2022 to 25 are likely to contribute to more than 70-80% of this data. So you have to really understand the context of where we operate, and also bringing in the cognitive security. I think Manish talked about the needle in the haystack. I think you really need to bring in security, which is going to be a biggest challenge that need to be overcome. And what we have seen across the industries, I think many leaders talked about it, be it on healthcare or smart cities, and how do you think you can provide security surveillance, which is going to be based on extreme value distribution. They are not normal distribution, right? Because in a 24-hour period, you may not have an incident. Maybe in a 200-hour period, you may not have an incident, but you have an incident for a few seconds. How do you think it can be detected and acted upon? So that's going to be very, very critical as compared to many of the use cases that you will find. And similarly, for the fraud detection and anything about security intrusions, I think all these cases are extreme value distribution, where you really need to look for those one instance that you are really waiting for that to happen. And the second important thing, what I also want to bring out is the importance of data governance, because it is not so much about garbage in, garbage out. How do you make sure that you are able to get the data cleaned up, whether you are analyzing for time series or unstructured data, and what is the best way to really go through a structured process before you can really start making it for ingestions. And we have seen many use cases, whether it is on healthcare, be it on radiology, oncology, or cardiology. And I think if India were to solve 600 million people who don't get access to basic healthcare, I don't think we can really solve that without technology. I think it is to be definitely going to be addressed through AI, and it's going to augment the doctors. And that's the only way by which we can solve this problem in the next decade. And similarly for education. And if you want to really get probably 200 million children to be educated in the next 10 years, I don't think we can do it with our conventional system. So it has to be done through a smart intelligence that has to come into play as far as education is concerned. The third, which is the automotive one, which many people talked about, I think thanks to the advent of GPUs and ASIC designs, and I think this is really powering the image recognition and the video analytics. And I think that's going to really drive the usage-based insurance. And how do you think you can really drive more safety? While I don't want to use the word autonomous, because yes, autonomous is an interesting concept, but to me, autonomous is equal to safety. So how do I really drive incremental safety year on year, which is going to be creating a more perpetual way of a safer environment that we are going to deal with? I think all this with addition of 5G, I can tell you that this is going to create the new set of use cases in the next 5 years, which is a lot different than what we have seen in the last 10 years, because 5G is going to make cloud and edge to be seamless. And if that's going to be seamless, you can really imagine the new set of use cases that is going to get built up. And whether it is AI-based inspection, I've come across startups which can probably, they said, don't give me your manufacturing process, don't give me your inspection process, just allow 2 cameras to be positioned in front of your machining center. and we let you know how good your manufacturing process is or not. To me, that was a shocker, because I said, I need a process plan, I need the complete methods plan. And they said, you don't need to give me anything, because I will tell you how good or how bad your process is and what are the inefficiencies that has been built into that. So it is about trying to be contextual, trying to look at the business case and make sure that your data governance is assured, and don't lose thread of the security part, which is going to be paramount importance as we start deploying AI at scale.
This is fantastic, Karthik, and you touched upon various sectors like automotive, edutech, e-com, the cyber analytics and things like that. I think they're so very relevant to the context in India. The other important aspect that I want to highlight is, in most cases, we see data governance as an afterthought, where, as you rightly pointed out, it should be at the top of the stack, because if you're putting up a data strategy, if your enterprises have to run with data being, in the forefront, it makes sense for the data governance to take, prominence, in your end-to-end strategy. Purushottam, now coming to you, you and Microsoft have had a huge focus on data and AI, and this goes back, a long way. You have been pioneers in terms of accelerating AI adoption around cloud platforms, especially the cloud data platforms. And Microsoft also has invested in the India ecosystem, in a long way, in terms of the sales team, in terms of the startup ecosystems and things like that. Now, it will be interesting to hear from your experiences of AI adoption in India.
So let me kind of split this in a couple of parts, the question. One is about in what way Microsoft as an organization. So let me wear a Microsoft hat for a few minutes. I'm not trying to kind of go overboard on what Microsoft has been doing, but there are 3 different initiatives that Microsoft has, right? And I'm sure other companies who are in that position have done that as well. One is a global sales has something called Startup Pod, right? Where the startup on tech, helping the startups in partnering with the leading VCs and advisors is what the sales team does. There's a scale-up program where for the organizations where we work with partners and the startup to kind of tailor the ready-made solutions for B2B startups. It's narrower focused than a broad initiative like a Startup Pod, right? And then we also have something called, we call it M2 program, M12 program, where we act like a VC, which is a narrower focus. It's very handful companies that Microsoft funds and Microsoft invests into. So that's one part of in what way Microsoft has been kind of building these accelerator programs in not just AI space, but across the board. The other aspect that you talked about, which is the cloud first and the data. Everybody's been talking about the data multiplying to such a degree, which is almost humanly impossible to digest in any way, shape, or form, no matter how much you clean up or other things you do. And that's where the cloud first aspects come in, and that's where Microsoft has been kind of spending a lot of energy through Azure as a product. And there are other companies. AWS has been on the forefront. Google has been working on things. So there are different companies that are providing platforms towards the cloud first kind of architectures, cloud first things. One of the things that is going to, like Karthik said, is going to start to blur the lines where because of the fast 5G kind of networks or whatever comes after that, are kind of the need for the heavy computing and the need is going to blur, where you have to have heavy computing done on the cloud, and then something on the very lightweight models on the devices and other things, right? Once you have the smaller and smaller latency, it starts to make these applications richer and actually for the end users, right? And the new scenarios will emerge out of it. So the aspects that are big challenging things that I see for a software engineer like me or architects is the scale of the data collection in a compliant manner. There are a lot of complex restrictions in every geography, right? We can't just willy-nilly collect data from every application from every user and things like that. All right. There are the policies for retention. Again, the different geos play a lot of a lot of restrictions into it, right? The data privacy aspects, the data pipeline at scale, right? Building inferencing engines at scale. Take any of these large used applications. PowerPoint, we saw some of the presenters using PowerPoint in earlier presentations, right? The slide designer of the PowerPoint, the slide designer recommendations in the PowerPoint designers. All of these are getting powered by the intelligence, right? Powered by different models that get built. Now, it is at scale. It has to be compliant. It has to be ethical. It has to be responsible, right? And I think all of those become the big challenges for not only from the scale perspective, like operating at scale for the billions of users that we talked about, but also in terms of how do we kind of enable these things in a responsible manner, right? And I think those are the aspects that I would like to kind of just put in front of the audience.
Yeah, I think you bring in a great point, Purushottam. It's just not building a functional product, but it's also important to have the ability to scale, the ability to manage, and basically deliver the continuous intelligence that will be the need of R as we go along. And more importantly, with restrictions like GDPR and other things, compliances coming in, you got to be compliant, around that as well. But more importantly, thinking all of this ahead of time and getting a product, basically fit to market as soon as possible. I think those are key enablers from the cloud platform that we see around. Now, moving on, I think a lot of our audiences, as entrepreneurs, as engineering mindset, they will be interested in knowing, how do we enable ourselves. So, Karthik, you know that IT skills are very dynamic in nature. The COVID has only aggravated that situation with the adoption of technology and the newer skills that are there. Now, the IT professionals are always challenged to learn newer skills and stay relevant in the market. Now, can you throw some light on what and why certain skills will become more valuable or are more valuable at this point of time? And what are your recommendations to sort of address that?
Sure. No, I think that's a very important question. In fact, this is going to keep many of the CEOs and CXOs not to sleep well in the night, because how do they really build the talent pool at scale? I think this is the biggest question mark in front of many of us. So the question that I would really like to answer is, see, if you really see that you need a pyramid for this. For example, if you look at, you need 1 million engineers in AI for the next decade. And if you try to break down like an engineer does in terms of breakdown into smaller problems that you can solve, you may still need about 800,000 people who can help in doing the data engineering, which is like plowing the data, making sure it is clean, it is neat, and it is ready for ingestion. I think that's going to be still the majority of work. You may still need about 50, 60,000 people who are more on the algorithm side. You need PhDs, and you need people who can really specialize in many of these areas, who can write those algorithms. So you need to really find a way to get this mix right, and also encourage more academic participation, and ensure that most of the academia are relating to solve some of the industry problems. I think this is the time for industry and academia to collaborate to build this 1 million+ engineers that we need for AI. And NASSCOM has already launched this future skilling program where there are more than 50,000 people who registered already. And how do you think this would probably be scaled up over the next 5 to 7 years? And also trying to go to tier 2 cities, because in AI, the interesting part is, if you really go down to the lowermost end of the value chain, whether it is data annotation, so you're talking about video analytics, you're talking about perception data, and the data annotation part. And I've read in one of the articles in 2017, China was building a tier 2 city, which is a rural part of China, and saying that they are building about 100,000 people whose job is only to do the annotation jobs. So maybe you'll find that there is a new KPO or a BPO that is emerging on AI. How do you think you can also take some of them to the remote cities? So I think this is going to be a way by which you are going to break down this into 3 or 4 chunks. And how do you think you have to solve this problem? The other element I also want to leave for us to consider is every device is going to find some mechanism of, it's going to see us, it's going to learn from us, it's going to hear us. And we really need to think about how do we build scale at individual points, whether it is text recognition or speech recognition, or trying to really look at voice recognition along with video analytics. How do you think you're able to bring a level of scale that you can do for certain pockets of AI? I think that is going to really help if you do some clustering, saying that there are some cities which will build on speech and some will build on video analytics. I think it can really help us to scale in the next decade for sure.
So Karthik, you bring in very interesting point. First of all, you basically build a pyramid in terms of where the requirements are. And I completely agree with you. Basically, 50% of a job, even for a data scientist, goes in basically cleaning up the data. And if ever so, the data is clean enough and mature enough for any inferences to be done on top of that. The second element that you brought upon is like you can work from anywhere. Can you enable people at the remotest places to work and contribute? And the third element that you brought in, can you find the right solution for the right problem, and hence invest in building the right skill sets around automating and utilizing that. Now that brings in very, very interesting perspective, Karthik. Thanks for that. Now let's look at the other side of the pyramid, the other side of the pyramid, isn't it? Now Manish, from a entrepreneur angle and his viewpoint, what is the advice that you'll want to give in terms of leveraging AI, for their ventures?
Yeah, I think it's about just a simple thing, right? It is not an end, but a means. And the focus should be on solving the problem that the market needs or your customer need. And then don't go by the hype and sandwich and try to over position AI and everything. Try to see what that problem needs, what can AI do differently for that problem. Let me put it this way. And in our thesis, we say, so that is a general advice for everyone. But for us, Pi Ventures, we say, what can AI enable 10x difference to the business problem that you're solving, right? So that's the disruptive AI part. And not just use it for the namesake or just use it because others are using it and things like that. So I think it has to be goal driven. It has to be business driven. It cannot be AI driven per se.
Fantastic, Manish. Now, Kaushik, coming to you, especially with regards to the customer-centric product that you are involved with. Now, every company or every enterprise, in a way or form, has grafted AI as part of their initiatives. If not at a surface level, you will find it across all architectures and infrastructures. Now, what would be your advice to the decision makers of the company on the approach to either build or buy, a right-sized, AI-driven, package or a solution, so to speak?
Wonderful. This can be looked at in two bins, right? For ease of clarity. Bin one is small and medium enterprises, and then bin two is large organizations. So if I look at large organizations, as rightly thinking, there are multiple packets of AI effort being done in their own individual value chains, right? If we are not going to solve a problem that is not going to be niche, which doesn't involve the intuition of the business that needs to be in place. For example, if I have 1 million pictures with me and labeled as dogs and cats, I just have to train them. But instead, if I have only 8 wafers and I do not know where the complexity of my chip failing in these 8 wafers, I do not know which temperature to be gauged, where I will need 3 million plus experiments to be done to do a full design of experiments. That is where we need to go deeper to understand it. So depending on the use case and the business case, and depending on each of the value chain, we should pick and choose. You can always start with buying, because you will understand how much you will not, when initially people are investing, we will not know how much we need to. So we can go to the existing ones. But for people who are into deeper AI space, look at it in the pyramidal form, 90% or 80% of them in the lower part of the pyramid can, depending on whichever bin they are, they can make use of the buy farm. But people who are into niche, for example, can I understand my previous 2 generation and look at where is my complexity for my next generation chip which is going to come, because the rates are dropping by the hour, right? The cost of the new die and the technology is dropping by the hour, and the complexity is increasing multifold, which means I will have and the volume of sales is going to be really 10x times. So if I'm going to bring in a new technology which is 2 days before anyone else, then I'm going to take that 300 million additional units of market share, for which my work started almost 2 years before. So in those cases where we know very clearly this is the high value problem that we are going to solve, we got to go deeper. When we are going deeper, we should also build in the domain intuition and the SME intuition into the AI solution. So in those niche cases, we have to build it. In most of the cases, for us to extract the value through AI, we can just go and buy it at farm.
That is great, Kaushik. So basically, there is no one size that fits all. Depending on your use case and what you intend to achieve. You got to go and pick up whether you want to build or buy, or you want to build and then get converted into a buy as you mature. I know, Karthik, you have to you have a hard stop in few minutes, but before that, any summary or any comments that you want to make?
Sure. I think some of the points about the business models and pricing, Ajay, it's going to be another interesting one that's evolving. And I've read in one of the analyst report which says that the customer experience is about 8% margin improvement. And if some companies which are adopting AI more successfully in making a new customer experiences are likely to command 8% premium than others. So nothing more is critical than trying to get that 8% through adoption of AI. So the business models that are likely to evolve, which is going to be whether it is per scan or per travel or per device kind of thing. I think it is going to be really evolving in a as a service or a SaaS or a PaaS model. I think that is going to be pervasive. The third important thing is dynamic pricing. I think this is going to be the word that all of us will start hearing. I think this is about what we heard in smart grid or in terms of air travel. I think this is going to be pervasive across every segment. And depending on the demand supply, I think you may need to agree on a pricing. And if you need to really get to that, AI is going to really facilitate this particular aspect of it. I'm personally fascinated and excited with what AI can offer for us. And I'm sure there is a future that we would be a lot more intelligent, smart, and connected. And this is going to be an exciting period for all of us in this area of semiconductors, engineering, and trying to really look at the future technologies. I think all of us should be blessed to be part of this segment and see this growth happening right in front of our eyes. And thank you everyone for patiently listening and providing me an opportunity to share my views.
Thanks, Karthik. A pleasure having you. And the margin utilization of 8% coming from the CEO, makes adds that much more value to your statement, so to speak. Now, Manish, I know you also have a hard stop. Before you summarize, Manish, is it I just wanted to understand, when you look at innovation at scale, isn't it like what are your inputs on that, especially with regards to human augmentation with AI, and then you can summarize, your point of view on this, on the overall topic as well.
Sure. I think there is a lot of opportunity. So we are a big fan of what we call as human plus AI. The fact that okay, let me step back. So first of all, I think in the initial part of when AI was just coming to fore, especially in 2016-17 in the commercial applications, one of the consistent questions I was faced in our thesis is whether it will lead to job loss, right? And somehow I don't face that question anymore, right? So I think somewhere people have understood that it is not about job loss. It's about augmenting and scaling more bandwidth for people and letting them do something else. Maybe it may be a job transition, but it is definitely not job loss. And to me, that is very critical, because if you think about a pyramid sort of a structure where you have a few quality resources, but you have a large demand to be met, like in education, like in healthcare, you just cannot bridge this gap by training more people. It is just not possible. So a technology layer has to come in the middle, which sort of learns from that quality resources and then makes it more accessible, right? That's another model of looking at how AI can augment the entire access to quality resources, right? So, and therefore, I believe that AI should be and will actually will obviously augment and further the human ability to do things. We've seen that in multiple experiments.
That's a fantastic perspective, using AI to enable skills, so
yeah, absolutely. And overall summary, I think there is a lot of hype around AI, and there is in that hype there is some genuine work happening. I think we need to just keep working on that, so find that genuine work. Whenever there is a technology disruption, it always happens like this, so there is nothing new in it. So don't discount AI because there is hype, and don't count on AI because there is not on high, right? So you have to just stay focused on the problem and use AI as a means to solve it.
I think that is fantastic, Manish, and thanks for giving a lot of those practical viewpoints on this topic. As always, much appreciated, always a pleasure.
Thank you so much. Thank you so much. You guys have a good day, and thank you so much for inviting me here. My apologies, I'm kind of rushing out of the panel. Thank you so much.
So
thanks, Manish.
Thank you, Manish. So let's continue. I think Purushottam, let me pick up your brains. One of the things that we see in AI is AI is moving out of the proof of concept or proof of value to actually getting deployed at scale. We spoke about the manufacturing example. You look at a product quality being monitored with multiple factories, getting video streams coming pretty much in near real time. And that would need that AI has to be operationalized. ML has to be operationalized. AI has to work, work at scale. Now, how is the overall ecosystem? Both the cloud platform and the ecosystem, as well as the open source, enabling this, this change in, change in behavior or adoption of AI.
So great questions. I think the scale aspect we kind of touched upon a little bit earlier. This entire once your user base kind of starts to increase, once the usage starts to increase, the amount of data that you are collecting and all the assumptions, baseline assumptions of responsibly collecting the data and all those things, once that starts to increase, the data ingestion at that scale, sending the data from your devices, whether they're wired, whether they're metered networks, all of those kind of networks, and then sending it for ingestion and all phases of cleaning up the data, all of that has to happen, whether it happens in a batch mode, whether it happens as a periodic thing or happens as a real time. One of the demos that I saw was the vehicles kind of thing, the previous session when somebody showed product demos, the vehicles moving in the traffic and doing the analysis of some of those. So some of those have to be real time, some of those have to be on. But the scale with which the ecosystem has to kind of operate, right? Right from the providers of the networks to the providers of the Azure kind of services where you're hosting all of this data, you're computing all of this, you have inference engines that are running, and then augmenting it back into the application, right? Augmenting back into the application, which is where your core application comes in. All of that operating at scale and having the higher and higher accuracy, because that's what the expectations of the users would be, right? I think that aspect is critical for any successful scenario to kind of feel successful, feel that the users are confident, users are going to trust that particular application. That entire augmentation loop, if you want to call it that way, or you can call it a looping back into the user's hands on the device. I think that scale is the ecosystem, and there are multiple players into it, right? It's the devices which allow you to have local inferencing. It is the services which allow you to have inferencing on the cloud and kind of augmenting that onto the device so that you can now provide richer experiences onto the device. It's the service providers who are going to provide a fast data ability, which are going to kind of move that data faster from cloud into your hands. And so it is that. So it's all, the entire ecosystem is kind of at play. And at the end of the day, all of this, and then we have to have the smart software engineers who are going to write the code, which is going to be efficient code to kind of take that and actually render it to the user, right? I think these aspects to me are kind of crucial going forward.
No, that's a great point, Purushottam. And what excites me is the ability for edge devices and the cloud platform to work in a synchronous manner to basically give the serverless compute kind of thing that is required. The ability to learn and transform, from one environment to another environment, and that makes AI and the AI applications, so very exciting. Any final comments from you, Purushottam?
One kind of a simple invitation to all the software and hardware engineers who are in the session today, right? It is to start investing in learning data engineering and basic analytics skills, right? That's what I would say. It doesn't mean that you get away from your coding, your design, your debugging skills, right? Don't treat the data engineering or basic analytics as a role. Treat that as a basic skill, right? And so by doing that, you're transforming yourself to kind of get ready for the next decade and not create a specialized stream of skills, because at some point that is going to get commoditized, right? But treat this as a skill as opposed to treating this as a role is what would be my invitation to all the software and hardware engineers in this room. That would be my closing thoughts.
That is fantastic. And I am a firm believer that you should know your adjacencies, because that gets you a better context, in what you do. Moving on to you, Kaushik, any parting comments from you?
Hey, that was a wonderful talk, Purushottam, so deep and so wide. So there are two aspects. Finally, it all boils down to um, when computers came, people were worried about losing jobs, and now all of us are tech savvy, all of us are gadget savvy. It has only enriched our lives. And when initial AI came, people thought about automation, and because of the explosion of the volume and the complexity, it is not possible for us to create multiple clones. At the same time, it is not possible for us to spend 21 hours, 22 hours, or even 28 hours a day to ensure everything is done, because most of the ones that we talk about today, people are making decisions based on it. So it is invariably real-time feed forward and real-time feedback mechanism that's happening today. My traffic live update is helping me to plan my time accordingly, and my network bandwidth update is going to help me so many things, and works so on and so forth. The VPN, everything is all about business and connectivity. So when we go back, there is again a dilemma of should I build it in the cloud, or should I build it or keep the data modeling at the node level, right? So often think about hybrid model, right? Because building at the cloud is going to give you a macro picture about the whole scenario that we are trying to talk about. But at the same time, the nature of the asset that we are trying to model and build is not going to change at a stroke of the second. So retraining or understanding state transition can happen at the node level. Whether you talk about IoT devices, you talk about edge intelligence, you talk about sensor intelligence, that doesn't change. Most importantly, today, COVID has taught us to try to do things remote. So imagine the entire country became work from home mode for 95% of its workforce in flat less than 48 hours. It is remarkable. It has helped us understand what is the potential that we have, what is the infrastructure, help us understand the whole new lot about what we did not know or what we did not dare to do a little earlier. So we got to make use of that, and it cannot be taken away without the AI and the support that AI provided. We cannot take that away from. It has really helped us enrich our lives. Last but not least, gone are the days of monolithic, humongous, single purpose, high performance computing, right? The nature of the problem data is different. The nature of the problem is different. So, and nature of the analytics is obviously different, right? All these are converging into what is the birth of a heterogeneous system. Today, what people need is a cheaper, smarter, real-time heterogeneous system which can tell them what's going to happen today, yesterday, right? Summing it up all, fire, water, and AI are very good servants, but bad masters.
Thank you, Kaushik, for that fantastic parting note. I know as we discussed with our panelists, I think India has the potential to lead the way to leverage AI and be a glue between both humans and machines, and bring about disproportionate amount of value to everyone in the ecosystem. Also, as a lot of panelists pointed out, I think we are well positioned to emerge as a global leader. And as we continue to adopt AI across all different segments, will only become stronger as we go on. Thank you everyone for joining this session. Thank you all the panelists, Manish, Karthik, Purushottam, and Kaushik, for enriching all of us, and thank you Iesa for arranging this wonderful summit. And in case you guys want to reach us, all the panelists will be available for any one-on-one questionnaires or any help that you would need beyond this panel. Thanks a lot.
Thank you, Mr. Ajay, and thank you all the panelists. It was very interesting. Subject matter expert was speaking, about this topic, and I want to especially thank Mr. Ajay Agarwal for chairing the session wonderfully. So thank you very much. So with that, we will move to the next session. It is on AI ML for automotive applications. Artificial intelligence uses data and algorithm to replicate human decision thinking ability. An algorithm which helps the system to learn and solve a problem independently are being deployed across various industries. Artificial intelligence finds application across the automotive value chain. Currently, AI is being implemented in automotive manufacturing, including design, supply chain, production, and post-production. In addition, AI is being implemented in driver assistance and driver risk assessment system, which is transforming the transportation sector. In the automotive industry, the implementation of artificial intelligence is at a lower rate compared to some of the other sectors. In terms of AI technology adoption and implementation, the automotive industry can probably be categorized as new adopter. To understand what it means from an expert, it is my pleasure to invite Dr. Ganesh Bokare, VP Technology, AI Vision and Learning with Smart and Technology. Dr. Ganesh is a PhD in Electronics Communication from IIT Mumbai with major in signal processing. He has 25 plus years of rich experience in computer vision, machine deep learning algorithms on embedded edge and cloud platforms. He has worked with various semiconductor companies like TI, Cyrus, Logic, Connection System, and Apical Limited. Please welcome Dr. Ganesh.
Thank you, Kamal. Can you hear me? First, I want to test this.
Yes, I can hear you. I can see your slides. Thank you.
Okay, great. Thank you. So thank you, Iesa, and all the members of the Iesa, as well as the audience for giving opportunity to talk on this topic. Let's jump into this because we are having a timing constraint. So what is the objective of this half an hour presentation? Here to address the what is the AI philosophy applications, especially focusing on automotive domain. In automotive domain, we'll be focusing on the ADAS, which is an advanced driving assistance system, and autonomous driving, which is a very, you can say the hot cake in the market. That is our objective of this oral session, and what is the takeaway for you? So basically the right approach to understand the AI concept, because it is highly hyped and majority of the people don't understand the core technology. Just I call them as a googly Google people. Just Google some top level stuff and throw the ideas. So that is not an AI. So we'll see. So objective is to understand AI with the right concepts, terminology, and perception. Second one is what are the practical problems and a future scope of ADAS and AD. And then what is obviously the future scope for the research. So that is a takeaway from this session. So we'll go to the next slide. I think introduction is already been given, so I want to skip this slide. Okay. Now we'll see what is artificial intelligence. It is a highly abused word. Artificial intelligence, people feel it is a god. It can do any damn thing, and that is absolutely wrong. So in AI, there is simple philosophy. If you'll see, no algorithm is good. People think AI can do any damn thing. That is absolutely wrong. There are a lot of algorithms are there, and no algorithm is good. But some algorithms are useful, and that you can transform into a product. So first thing, what is a AI? AI is basically a you can say the biological inspired concept of human intelligence, which they are trying to mimic into the machine. And here machine refers to computers. So first thing, what is a human intelligence? Actually, the human intelligence is a decision-making capability of the human. That is called the human intelligence. And human intelligence at top level works in two different ways. The first part is understanding the various objects or segregation of various objects and then recognizing the object. So such type of analysis is it is called a classification problem in AI terminology. And the second one is based on the history data, human does the processing and they are prepared to take the next decision for the better performance or better life, or you can say the better cost function. So that is a top level description. But for example, you are driving a car, you can see the surrounding and then you can decide whether I should speed up my car or I should brake the car. So this is called a predictive analysis. So overall AI analysis of a human intelligence system is classified into the two categories. That is a classification and regression. And the similar logic is implemented in machines, which is called the computer. So here, whenever I talk about machine, it refers to computer. So how does artificial intelligence is bring into the life. There are two aspects. The first part is a model, which is like a mathematical model. So that mathematical model gives you the decision-making capability. Either it is a classification or a regression problem. So here, both are modeled using a simple mathematical function y is equal to f of x comma w. So this is what we have studied right from school. Now here, normally we write f of x, nobody writes a w, but w, these are nothing but the parameters, and it plays an important role in the artificial intelligence or defining the artificial intelligence in computers. So what do you do about this function? So basically, just like a human, when we are small, we start learning, we'll start capturing the data and we'll start learning, and then our brain will get trained. So this equation is a brain, and that need to be trained. And how do you train? So basically, the training involves this estimation of weights, and also it involves the data and the output. So known data, known output, our brain gets trained, similarly the computer gets trained, and then once your model is trained, you can deploy in the real life, which is called the inference operation in AI terminology. So how do you train your weights of this mathematical model? So there is a training algorithm which is called stochastic gradient descent algorithm. So no need to worry about what is a SGD and all this stuff, but top level, you can envisage is some algorithm which will estimate the weights W using known data set. And data set is nothing but your input and the output. It is a combination of input and output, where very often in you can say the AI literature, people call the data set. So Xn is your input while the Yn is your output. How do you get this data set in real life? So obviously the answer is the sensors. And there are different types of sensors, which is like a camera, LiDAR, radar, sonar, audio key. This is not a complete set, I will say, but this will cover the major aspect. And as far as whenever I will constrain my discussion to the ADAS and AD, autonomous driving, I'll focus on these sensors only. So here, how these sensors are deployed in real life as far as autonomous driving is concerned. So you will find this is a car. You can see the car model. And these are the various typical sensors located inside the car. You can see the camera, MEMS, LiDAR, radar, and ultrasound. These are, again, I won't say it is a complete set, but these are the typical sensors used in autonomous driving. So here, this is a flow. So you will get a data. Right now, don't worry about the sensors. It is just for the understanding purpose. So we'll focus on the data. Now, how do you train the model? So you can train the model by feeding the known input Xn, and then you see the output predicted by your model. Now, this output initially in the training process is not good one, and that's why it is called a training. So your training will start improving the performance of your model by updating the weights W. And how do you update the weights? Initially, you'll find these predicted outputs are not good enough. So you'll get a lot of error, and error is our cost factor, which will decide how to update the weights. Okay. Now, these weights can be updated using a Taylor series. Right now, again, don't worry about this mathematical aspect, but the conceptual part of, if you see this equation here, I'll use it. Interruption is laser, yeah. So if you see the mathematical aspect, this is a Taylor series. If you'll expand, then you'll find these weights, equation for the weights, and then these are the simple tricks used to update the weights. Now here the idea is you can update the weights W in such a manner, or in every iteration, you'll get improved performance. Now this improved performance will depends on your overall performance expectation from the model. Typically, we call it as an accuracy or error, or you can say the error should be less than 1%, or accuracy should be more than 90%, 95%, 99%, depending on your application requirement. And if that one is not satisfied, means there are some problems in your training of the model. Now, very often I saw the oral discussion since morning. People are saying the models are not perfect, models are not working, there are some issues. The issues are lying here. Very often, if you don't train the model properly, then you won't get a desired performance in the real life. And there are two answers for that. The first answer is overfitting of the model or underfitting of the model. Now that are the mathematical aspect which very often the top level management people don't understand, and they simply start fighting on this issue. But one has to understand that part, and that's why you have to go in a repeated training of your model, especially for the deep learning model or bigger models. So once you're happy about your model weights, and if you see your performance is good, so there is a validation process as well before you deploy the model in real life application. So you apply on the unknown data, validate your model, and then if you're happy, then you deploy in the real life. So in real life, this process is called the inference process. So you apply unknown inputs and see the output, and you benchmark your result. Once you benchmark your result and you get a same performance as whatever you got it in your training process, you are ready to go. You are ready to deploy your model, and then you can deploy it on any hardware platform. So that is there are many platforms. One is a SoC, system on chip. Second one is a GPU platform. Third one is a vector DSP, and the software. Now here, what is a software and what is a hardware? So your mathematical formula is implemented as a software, and that will bring the intelligence into your hardware. Now, what is a hardware requirement? So hardware requirement should be such that it will provide the computing power for running that software in real time. That example I will give it in the next slide. Now, once you got a training model, deploy in the real life, and then you put it on your hardware, so it will become a tangible solution of a you can say machine learning or a deep learning model. Now we'll see one of the use case, that is a ADAS and AD. Now here, as I said, your y is equal to f of x comma w. Typically, this operation is a dot product. So this is a very simple operation, and this is implemented as a part of the hardware as well. Most of the hardware, all these GPU, SoCs, DSPs, or hardware accelerator, the basic computing cell is a dot product. And dot product is nothing but the neuron model of the human, which basically projects unknown data on the known data and derive one quantity, which is a C, which is a scalar quantity, that gives the amount of correlation between your known vector and unknown vector. And that is the way the human brain works. And that is exactly mimic into the various models, whether it's a neural network, CNN, that is a convolutional neural network, LSTM, any machine learning model, the fundamental operation is a dot product. Now here in ADAS and AD, we'll see you have the model y is equal to f of x comma w, and that is nothing but one of the CNN, that is a convolutional neural net, which we'll see it in the next slide, LSTM or neural net. So here, what you have here? So basically, you'll have a classification model or a regression model. Now in classification model, you'll find a CNN and LSTM. Basically, CNN acts as a feature extraction, while your LSTM acts as a the timing analysis. So we'll see these models later on, but you'll have a top level, you'll have two models, regression and classification. And then what classification will do? So basically it is a object detection and recognition, while regression will do object tracking. Okay, that is it predicts a future. So that is a tracking operation. And object tracking can share the data from object detection, because the tracking of the object, you'll need the information from the object detection. And that's why they are connected like this. So what are their various object detection? Now we'll go in details of that, which are nothing but the pedestrian, traffic sign, vehicles, roads, markers, driver emotions. So these are the various machine learning model or deep learning models which are used in ADAS and AD operation. So what is there in the tracking? So in tracking, people implement collision detection, line assist, path planning, routing, and there are so many. I won't say these are the algorithms which will form the complete set, but that will give the overall idea how ADAS and AD algorithms are implemented as a part of artificial intelligence and how they are deployed. So deployment is already explained in this first block diagram, while these are the algorithmic development in the AD and ADAS domain, that is automotive domain. So then you take the smart decisions here, and the smart decisions are applied to the intelligent vehicle kinematics, which are going to drive your steering or your gears, clutches, so which are called actuators. So all these actuators are controlled by your AI, and then you will get a driverless car. This is an extreme example I have given. It is a driverless car, but there are many versions of that, which we'll see which we'll address in the next session. Now here, the first part we saw the AI model, its designing, training, and then its use cases. Now we'll see what is a ADAS and AD? So first thing, how people think about it, how to make this understanding very simple, because this is a very, very complex domain and there are a lot of confusion and the development in the industry is going slow and there are multiple reasons for that. So first try to understand what is a autonomous driving. Okay, that is a driverless car. And then we'll see why they are segregated into the different levels step by step. So driverless car is basically you just remove the driver and give the complete control to your computer, which is running your intelligent software. Now, what is that software? We'll see it soon. Okay, so that is going to control your various aspects of driving, like your steering, your clutch, your brakes, and your gears. So how do you do that? What is the principle applied? So the simple principle is you sense the complete surrounding, then you make a plan, and then you act. These are the three-step process with a minimum risk maneuver and maximum safety standard. So once you follow this principle, then you will understand how the algorithms are developed. So here, the first thing is what do you mean by sense? So basically, you'll have a complete surrounding picture, and actually you can implement this. I have implemented this algorithm, and you can see the 3D surrounding around your car. Actually, when I was working with the company, there was a actual real car with the lidars and various sensors, and on computer we can see this complete 3D world. And this is a real picture. This is not just a simulated picture. This is a real picture. And if you'll see the orange color circle and what your car is, that is your ego vehicle. That is the car which is using the autonomous driving concept. So here, this is a 3D world. How do you implement this 3D world? So obviously, you will get a data from sensors, which we already talked about. And these are the various sensors, radars. There are multiple radars, short range, mid range, and long range. Then lidars are there, which are used for the implementing or simulating or seeing 3D world and sensing range of various objects. And that is a very important thing. You are not supposed to only recognize the object and detect the object, but we have to understand their distance from your ego vehicle. And that's why the radars and lidars will come into the picture. The camera won't give the accurate measurement of the distance, but lidars and radar, these are the two sensors which gives the accurate measurement of all the objects surrounded by your car. And that's why they are required in real life. So here, once you get the sensor data, you can apply sensor fusion algorithm. This is another research area, because implementing fusion algorithm for these various sensors into a single image, it's another challenging job, but one can do it. There are a lot of papers available, a lot of algorithms are available, and obviously there are a lot of challenges, a lot of computational power is required. So many aspects are there. Okay, and then first part we'll cover, which is ADAS. Now in ADAS, which very often it is called a L0 or L1 level, where there is no autonomous driving, but ADAS is a advanced driver assistance system. It is a ease of driving, and nowadays you'll find in most of the cars these features are getting deployed step by step. So in ADAS, what do you do exactly? There are various algorithms which will help the driver to avoid the hazardous conditions, because nowadays a lot of people are getting killed in various accidents because people don't understand the traffic sign, or they get, because of some problem, they don't see the traffic sign, they don't see the pedestrians, or suddenly somebody is coming to the road. So in this situation, you can give some control to the computer and they can apply their intelligence to, for example, emergency braking. If some kids comes onto the road, the car will get automatically brake. So that is one of the algorithm which will assist the driver. This is one of the safety feature. So here you can see the various algorithm, traffic sign recognition. So it will, when you are overspeeding the car, it will give the alarm to you that you are crossing the speed limit. So that's why traffic sign detection is there. Vehicles, surrounding vehicles are there, so you can avoid the collision with the various vehicle. Pedestrian detections are there, so it will alarm you there are a lot of pedestrians are there. So these are the safety features, which is also an integral part of ADAS, or autonomous driving. Autonomous driving, and that will control your actuators like emergency braking or cruise control, collision detection. So all these will finally will control the actuator. But still here, we are not talking about autonomous driving. Here the driver is still there inside your car or vehicle, you can say. Now we'll come back to the autonomous driving. Now, what do you need in autonomous driving? We want to replace the driver. That is a simple concept. So there is a very important algorithm, and you'll find many flavors of this algorithm, which is called SLAM algorithm, which is a simultaneous localization and mapping. So it does the two things: localization of your ego vehicle. So what is the exact position of the ego vehicle? And here the GPS and camera systems are used together to identify the position of the vehicle. And then you find the map. The mapping is nothing but whatever you see in this picture. It is a complete perception model of surrounding world, which can be 2D or 3D, depending on what kind of sensors you use. There is a lot of debating is also going on this, how to implement, whether you want 2D or 3D. And obviously, when you go for 3D, you'll need more computational power. So here, you'll get two results from the SLAM algorithm, which does localization, that is a step one, and second one is a mapping. So here, what applications are for the SLAM? So once you SLAM outputs the results, you can do the route planning, which are the separate algorithms, and that will take the input from the SLAM. And the second one is a perception algorithm. It will create this 3D world. You'll get the complete picture of 3D world, HD maps, surrounding objects, and then the car will actually start the maneuver operations. How does it start the maneuver operation? So it will do the path planning based on this route planning, and then it will control the actuators. How it will control the actuators? As we already saw, there is a vehicle kinematics and dynamic models are there, which are going to control your actuators in a optimal sense. Now, in this implementing this algorithm, we have to pass the compliance standard for both hardware and software. I don't want to go inside this because we are having a time limitation. But this is a standard used. Okay. Now here, now we'll go the details of every block. What are the various sensors used in autonomous driving? So basically, the first part is the odometry sensors, which odometry and GPS are used for the are used for the positioning of the vehicle, and that is one of the integral part of the SLAM algorithm, because it helps in localization of the vehicle in the 3D environment. Second one is a camera. There are different types of cameras: RGB camera, RGBD camera, or stereo cameras are also coming to the picture. And in the cameras have the limitation. In daytime, you can see the various objects, but in the nighttime, how do you handle the situation? So you need the infrared or night vision cameras. Second part is a LiDAR and radars, which are of two different types, 2D and 3D. Now see, these are so many parameters are getting involved, and it is very, very difficult for OEM manufacturer, especially car manufacturer, a drone manufacturer, robotics manufacturer, to decide which LiDAR should be used, 2D or 3D. So there are so many parameters are coming to the picture. One part is a technology part, second one part is a money. So whether it is affordable or not. So these are the two aspects, and people can do the brainstorming on that. Then next one is a radar, which are again three types: 2D, 3D, 4D, and we'll get a mid-range, short-range, and long-range radar, and that will get deployed inside the car in this fashion. Okay. Another part is ultrasonic sensor. Some car manufacturers use ultrasonic sensor as well, which is used for short distance parking assistance. So there are new generation cars are coming. So you just leave the car and it will do the automatic parking or valet parking. So there ultrasonic sensors are used. GPS is used for the localization. Then there are some specialized sensors are there, which probably will get deployed when 5G and autonomous driving, okay, or autonomous driver algorithms will start working together. And these are called V2X. Now X can be your V2V, V2I. V2V is a vehicle to vehicle communication. V2I is a vehicle to infrastructure communication. And there are multiple flavors are there. But these are the two top level things, which is called a V2X. So there, the 5G technology will be used in your autonomous driving to give the directions to the driver or car. Now here, autonomous driving can have a driver, may have a driver present in the car. So that we'll see it later on. But that technology will also come into the picture, and a lot of virtual computing, edge computing will come into the existence because of the data centers. Right now, we are having a physical data centers. In future, when 5G technology will evolve, you'll have virtual data centers also, and that will bring the revolutionary, you can say, development or improvement in the car technology. But there are so many challenges are also there. 5G, a lot of people are excited, but the major problem of the 5G, it is suitable only for a short distance communication. And still you'll need a 4G. And many people are not aware about this because of the channel fading and so many limitations are there. 5G can transmit data at very high speed. It can go up to around 10 gigabits per second, but over a short distance, not over a long distance. And therefore, the 5G won't work alone. It will work along with the your old technology, that is a 4G. And then this complete sensor technology will bring overall autonomous driving at top level into these three categories: mapping, localizations, which we already discussed. Mapping is just building the map, 3D world. Localization is the positioning of the car in the 3D world at every millisecond, microsecond, and that is another big challenge because human lives are at stake, and that is a limiting factor to bring the technology in the real life scenario. And the third one is a perception model, which collects the data from various sensors and build you can say the final data for object detection, object recognition, tracking, and so many algorithms in the machine or deep learning. Now I'll go to the next slide. What is a design flow? Now we saw the two aspects. One is the AI aspect, and second one is its application in the area of ADAS and autonomous driving. So what is a design flow? What is a top level design flow? So first we'll see how machine learning or deep learning algorithms are designed. So first one is a design phase, in which you decide the different types of models and their architectures. Then you train the model, which we saw it in the first slide. How do you train the model? You need a data set and annotation. That is a, you can say, the label data. And then you optimize your algorithm. That is a trained model. If you are happy with that, then you go to the next stage, which is a performance evaluation. And once you are happy about the performance evaluation, you can do the benchmarking here. So you can compare with the reference model. Now this designing of this deep learning model or artificial intelligence model, there are various frameworks are available, and the most popular are Caffe, Caffe2, Keras, TensorFlow, Torch, Theano. These are the various frameworks available in Python. You'll find the framework in MATLAB as well. Now Keras is an integral part of the TensorFlow nowadays. If you go for a TensorFlow 2.x, so Keras is an integral part of TensorFlow because very simple and easy interfaces provided by the Keras compared to a TensorFlow, and that's why it is now integrated into TensorFlow, Google TensorFlow. So once you do the benchmarking of this, you can go to the next step, that is a quantization, because a lot of people talk about AI, but they don't understand how much computational power is required. The computational power, we'll see it in the next slide. We'll go in details of that. So this is a very important process, which is called quantization, because all the models you'll find, if you'll design using this various framework, they are 64-bit floating point. And implementing these algorithms in 64-bit floating point is almost impossible because it will consume both huge memory as well as computational power. And that's why the quantization will bring the 64-bit model into 32-bit, 16-bit, or 8-bit. So the designer has to decide what kind of the precision is required depending on their hardware and software requirement and available computational power. Once you finish that job, you again do the performance evaluation with the previous benchmarking. So this is a logical step. And once you finish this, these things will happen in Python design framework. Normally, I saw the 90% people are using Python rather than MATLAB, because MATLAB you have to pay huge money in crores or maybe in lakhs, okay? Or you can say a couple of $100K. So these are all free, okay? And I personally use TensorFlow with the Keras. Once you are done, how do you deploy? So you have to go for
Dr.
transform.
Ganesh, sorry to bother you. Can you please request to conclude in 2 minutes?
Okay, I think I'll close it here. Okay, because
please,
previous people have already consumed extra half an hour.
Sure, please.
So I'll close this here. Okay, I think I'll stop it here.
No, please conclude your thoughts.
No, I cannot conclude in the halfway. So basically, I will close this.
Yeah, no, let's go ahead and take a couple of more minutes.
No, it's fine. Yeah, I don't want to. So there is nothing because previous people, they have amazing, great, fantastic, beautiful, all these. You have given extra 20 minutes, and you are now asking me to conclude.
Sure,
it's fine. I'm closing this session.
Yeah,
Sorry.
Please take your slide.
No. I know. It's okay. Thank you.
All right. Thank you very much, Dr. Ganesh. It is very, insightful, session. Sorry, we are behind schedule, so we would move to the next topic, next session. It is the advent of artificial intelligence is not just an incremental change, but a paradigm shift which must be harnessed for humanity's well-being. The world needs to manage this transition effectively so that it does not aggravate societal disparities. AI for social empowerment seeks to leverage AI for inclusive growth and empowerment while addressing concerns over exclusion and job redundancy. The vision to use AI in healthcare, agriculture, education, logistics, and languages has inspired many organizations to use AI for social empowerment. Let us hear about this topic from the industry expert. It is my great pleasure to introduce our next speaker, Dr. Manish Gupta, who is the director of Google Research in India. He holds an additional appointment as an Infosys Foundation Chair Professor at IIIT Bangalore. Previously, Manish has led Videocan, a video technology startup, and the research centers for Xerox and IBM in India. As a senior manager at IBM P.J. Watson Research Center in Yorktown Heights, New York, he led the team developing system software for the Blue Gene supercomputer. IBM was awarded a National Medal of Technology and Innovation for Blue Gene by US President Barack Obama in 2009. Manish holds a PhD in computer science from the University of Illinois at Urbana-Champaign. He has co-authored about 75 papers with more than 7,000 citations in Google's Scholar in the area of high-performance computing, compilers, and virtual machine optimization, and has been granted 19 US patents. While at IBM, Manish received several awards for excellence. Dr. Manish is a fellow of ACM and the Indian National Academy of Engineering and a recipient of a Distinguished Alumnus Award from IIT Delhi. Please welcome Dr. Manish Gupta.
Thank you, Kamal. It's a pleasure to talk about our work. I hope my slides are visible.
Yes, those are.
Okay. Thank you. Okay, so I'll be really talking about our work, again, AI for India, which has been done by my colleagues. So while at Google Research, I mean, we are doing also a fair amount of fundamental research on the basic technology, in particular deep learning technologies behind AI, including kind of understanding and improving these technologies for issues like fairness, safety, explainability, and also understanding the human factors as these AI technologies interact with humans. I'll focus in this talk on some of the work that we are doing in applying AI in areas like healthcare. We also have a formal AI for social good program where we work with NGOs to work on problems that are motivated by, again, what they are doing for the communities. Some of our work with satellite imagery processing, which we are now applying to agriculture. And finally, trying to democratize access to information in Indian languages. So let me begin with our work in health, where I believe AI is really going to help transform the healthcare system pretty much globally. Because I would argue there's not a single country today which is happy with its healthcare system. I'm illustrating that with this slide, which is showing the per capita expense on healthcare in various countries. This is from the year 2018. The numbers for every country have now gone up. from what these numbers, the numbers that are shown here. And you can already see, again, I mean, there are countries like the US where these expenses are out of control. In the US, you are spending over 10,000 US dollars, not when a person falls sick in a year, but this is on an average person. And countries like even UK, which have much lower amount of spend compared to the US, they're also struggling with rapidly rising costs. So trying to figure out how to really reduce these costs. And then when it comes to health, nobody wants to do it at the expense of quality, right? So you're also trying to improve the quality of the healthcare system. And the one country where these numbers are very low, below $1,000, is India. And somebody might think that India is doing a wonderful job with health. Whereas the reason this number is very small is because this is the average number. We don't have decent healthcare for much of our country. And therefore, that spend on healthcare when divided by our population of 1.3 billion becomes a small number. But as India goes about providing decent healthcare to every citizen, we simply cannot afford to take the path of countries like the US or even UK. We need to do much better. And what's that better path? I would argue it's a combination of a business model change and also something where technology can play a big difference. The business model change is to make healthcare more consumer-centric, where it is really trying to deliver value to the consumer for every rupee that is being spent on healthcare. The area where technology can make a difference is making it more proactive. We've all heard the term prevention is better than cure. And again, I mean, in COVID times, it became so much clearer, the emphasis on prevention of COVID, right? Through simple techniques like masking, social distancing, if we can prevent COVID, right? That is so much better than having to treat COVID with all the medication and so on. And the same argument holds in general for almost every disease. So in fact, the healthcare system tends to be built in different tiers. And if through technology, we can take care of a person's health at an earlier tier, it leads to lower cost and it also leads to better outcome for people. And that's illustrated, for instance, in the slide, where the most expensive tier is the ICU of a typical hospital. So ICU is not a fun place to spend your night, and renting out this bed in an ICU is usually much more expensive than renting out a bed in an expensive 5-star hotel in an exotic location. So if you can take care of this patient before they enter the ICU, before they need to enter the ICU, when they are at the earlier stages in the hospital, it can both lower the cost as well as lead to better outcome for them. And taking that argument even further, if we can take care of people while they're living their normal lives at home, at work, and prevent them from falling sick, or when they do have symptoms or risks for specific diseases, if we can warn them ahead of time and encourage them to take timely action, that can lead to better outcome for people as well as lower costs. So, and it is in this early intervention, it is in early risk prediction where AI can play a very significant role. So what I'll do is I'll give 2 examples of the use of AI in this more proactive health, and show how many of these examples can generalize to multiple other diseases. So let's start with one example which is on screening for diabetic retinopathy. So diabetic retinopathy is a fast-growing cause of blindness for people across the world, and it can potentially impact any person with a diabetes condition. So regular screening is really key to preventing blindness. And what happens is, in a country like India, which has a shortage of eye doctors, and in fact, this aspect is true not just for eye doctors. You take any specialty, India will have a shortage of that specialty relative to our population. So what ends up happening is, as a result of this shortage, for instance, for eye doctors, roughly half of the patients, 45%, end up suffering a vision loss before they are diagnosed with this condition of diabetic retinopathy. So, and the way it is diagnosed is through a special camera, the retinal fundus camera, that captures this image of the eye, the retinal region, and based on that image, usually the doctor basically looks for signs of hemorrhages in this image, and then they rate this case on a 5-point scale, where 1 indicates no diabetic retinopathy and 5 indicates proliferative diabetic retinopathy. So what our team, our AI team of researchers, starting with one of our researchers, Varun Gulshan, he did this work, in fact, before our research lab got established in India, when he had moved to India for personal reasons. And he started talking to various physicians, trying to identify an area in health where he could make a difference using his core capability, which was computer vision. So in computer vision, we've actually seen deep learning kind of really show that tremendous impact by showing that ability to analyze these images, right? And we have seen deep learning algorithms analyze pictures to be able to automatically classify these images. Is this an image of a cat or a dog? In this case, what we are trying to do is feed this deep learning network this image, this retinal fundus image, and train it to automatically classify whether on this image on this 5-point scale. So our team started with a whole bunch of these labeled examples, which were labeled by the doctors, and trained this neural network to automatically come up with these grades. And again, I mean, I'll skip some of the details. After a fair amount of work and a lot of improvements, they were able to show an algorithm that was able to achieve results comparable with a general ophthalmologist. And they published that work in 2016 in the Journal of American Medical Association. And this work got a fair amount of recognition and praise from the medical community. So in fact, you can see some of these quotes by a doctor from Harvard Medical School, that the study by Gulshan and colleagues truly represents the brave new world in medicine. And in fact, last year, this paper was rated among the 10 best JAMA papers, this journal's papers in the last decade. And in fact, later, this team went on to improve these results further and showed results on par with retinal specialists. And not just that, they were able to start to show additional kinds of things that they could do with this analysis of these images, including predicting your risk for cardiovascular risk factors like heart attacks and strokes. And so this, I also want to kind of, sometimes we get carried away in the hype. So while on one hand, these results are extremely impressive, there are still some outstanding challenges that researchers are working on. And one of those challenges is that on the overall, on the average, algorithms like these deep learning networks are achieving results comparable with the specialists. However, there are still cases where these algorithms could make really terrible mistakes that no human doctor ever would. And unlike a human doctor, who normally, I mean, when they are presented with a complicated case, they know that this is a complicated case, and in that case, they might seek a second opinion. Deep learning algorithms can often make mistakes very confidently. So that's again, so trying to estimate your uncertainty better is an active problem that many researchers are working on, including, I mean, our own team at Google Research India. And we have a collaboration with one of the professors, Professor Sridhar Devarajan at Indian Institute of Science on this problem. Now, to me, I mean, this example of screening for diabetic retinopathy, this is again representative of similar ways in which you can screen for other diseases. And in fact, researchers at Google have likewise shown deep learning based techniques through which you are able to detect, again, you can screen for breast cancers using, again, deep learning applied to mammography images. There are startups like Niramay, which are trying to do this by applying, again, machine learning over thermal images. There are researchers at Google who have also shown, again, similar success at applying deep learning for screening for lung cancer, various kinds of skin cancers, and so on. So again, this is a very promising area where applying these AI-based technologies, you can warn people early of potentially serious diseases. And when you warn them early, often the treatment is much simpler and much more effective. Another major disease that we are looking at our lab in India is cardiovascular disease, which is actually the #1 killer for people on the planet. And in fact, including India. So in fact, in India, a number of people who die of heart attacks or strokes, there are two kind of issues I want to highlight. One issue is that most of the people who are suffering these heart attacks and strokes, unfortunately, are not even aware that they are at a high risk of these adverse events. On the positive side, which is the silver lining, I mean, you can view that as a negative. So in this work, we are collaborating with a cardiologist, Dr. Satish from JIPMER in Pondicherry. And Dr. Santosh tells us that in his analysis, a typical Indian is suffering a heart attack or a stroke at an age which is roughly 10 to 15 years lower than what, I mean, a counterpart in, let's say, a Western country would. So you can view that as a negative, that Indians are suffering these heart attacks and strokes at much younger ages. To me, the silver lining is that through early intervention, you can actually delay these heart attacks and strokes, potentially by, again, that at least a period of 10 to 15 years, and in many cases, help prevent them altogether through some very simple lifestyle interventions. And the goal of this particular research is to see if we can use, again, the combination of things like mobiles and wearables that we are all, I mean, that people are beginning to use. Can you extract out meaningful health signals from these wearables and mobiles, things like your blood pressure, your body mass index, heart rate variability, as well as your lifestyle factors like how much exercise you're getting, are you smoking or not, what kind of food you're eating, and so on. So in many cases, you have to take some of these signals you're getting out of these wearables and mobiles and further apply a combination of signal processing and AI to recover these health related signals. Then you build risk disease models based on AI again. And you can then, as you identify people with a high risk for a certain disease like cardiovascular disease, you can then also suggest simple interventions. So in case of something like, in case of cardiovascular disease, in fact, there are some very, very simple interventions which we are planning to now test through a clinical study that we are planning jointly with the doctors in JIPMER. The idea is to look at patients who do have hypertension and see if a combination of simple automated lifestyle suggestions about, look, you need to do more exercise, you need to start walking for about 15 minutes every day, or start increasing your intake of fruits and vegetables on your food. Please cut down your salt consumption to no more than 5 grams. These kinds of simple suggestions the idea is to show that through those simple suggestions, you should be able to bring down the blood pressure of a person with hypertension. And ultimately, a lot of these kinds of lifestyle suggestions, and if they don't work, if let's say the person still continues to have hypertension, then things like medication to keep your blood pressure and things like blood sugar levels under control, they can have, clinically it's well known that they can have a tremendous impact on improving your cardiovascular health. And so this work, again, in my view, can generalize to many, many other conditions as well, such as diabetes, as well as you can start to intervene early for other serious conditions like mental depression, as well as mental illness. So one obvious concern that comes up when you look at some of these kind of technologies is that they are doing all of this analysis over data that tends to be very, very sensitive. Because what's my blood pressure? What am I eating? Am I smoking or not? How much sleep am I getting? These tend to be very sensitive kind of pieces of data, which I may not want anybody else to know about me. So another area which is really gaining a lot of attention from the research community is privacy-aware machine learning and privacy-preserving machine learning. So for a healthcare setting, one of the fundamental technologies that we are looking at building upon is called federated learning, which was initially developed at Google Research. And at this point, it is being used by many, many companies. And also there's a lot of research happening in academia on improving these technologies further. The idea in federated learning is to help you to do this machine learning in a manner, in a very federated manner. And in this case, back to this healthcare example, you can do it by essentially assuring the end user that their data is not to be stored, is not to be shared with any centralized system, including cloud. So in that original system, right, the way I was describing, you kind of bring all of the data from various individuals to a centralized cloud, and there you analyze it. In federated learning, rather than doing that, you will build some initial models with proxy data on a centralized server or cloud. You will distribute those models on individual devices, and then you will be running those machine learning models just locally on the mobile device of the person. And in this case, the sensitive data about this individual is not being sent anywhere beyond their device. It is not being shared with any centralized server. And the idea in federated learning is that you still want to be able to learn global models from each of these individual kind of data sources, right? When you have millions of users, each using their own mobile device, how can you train your machine learning models without getting access to the raw data? How can you still take advantage of the data on all of those millions of devices? And this is what you do in a federated manner, where you never share the raw data, but you start to share certain machine learning parameters like gradients that get used in the gradient descent algorithm of your deep learning system, and you're able to update these models and ultimately distribute them. Now, somebody who's familiar with attacks, with privacy attacks on machine learning model would recognize that even if you're not sharing the raw data, somebody could still essentially attack the deep learning model and be able to recover back the data for an individual through those specific attacks. And again, to prevent those, one can combine something like federated learning with the differential privacy techniques, which essentially guarantee that the overall machine learning model that you learn, from that you're unable to recover the raw data, unable to identify any given individual. I know I am kind of out of time, so very quickly I just wanted to go more into depth in one of the areas, which was health. In this, let me just give you a few more examples of where AI can be applied in other domains. So let me talk a little bit about agriculture, starting with some work that we have done. So our, again, computer vision team has been now looking at analyzing satellite imagery to see what kinds of interesting analysis you can do and what kinds of interesting problems you can solve by analyzing those satellite images. And they started by working with our Earth Engine team on this problem of land use, land cover classification, where the idea was for any point on the map, you want to automatically identify, is this a water body? Is this a forest? Is this an agricultural area? Is this a human settlement? And so on. And the idea is that once you do this classification automatically, it can help you with some very, very interesting and useful kinds of analysis, like what's happening to the forest cover in a given region, what's happening to water bodies in a given region. And so let me now talk specifically about some use cases in agriculture. You could also infer that, okay, this is a particular field. Now you could do further analysis of the satellite image and be able to infer what is the crop which is being grown. Is this wheat or rice? And what is the current stage that the crop is in? When is it likely to, ready for harvesting? So the idea is that by doing some of this analysis at the scale of by analyzing satellite imagery, you can do these analysis at a much larger scale in a much more cost-effective manner than if you were using traditional kind of techniques, either manual methods, which are often used today, where, let's say, for a bank which is trying to decide whether to give a loan to this farmer, or an insurance companies which has to provide crop insurance to this farmer, they want to see, okay, how much of that farmer's, let's say, plot is under cultivation for a given crop. Now, today, with manual analysis, you may need to send an agent to the actual field of that farmer, which is a very laborious and expensive process. The next step in that evolution is you can start to have kind of drones or photographs that are taken, let's say, of the field. You can have ground-based sensors, IoT sensors, through which you are sensing things like soil moisture and so on, and start to help farmers with these analysis. What we are trying to do is work again with such technologies, with various ground-based sensors, to provide the ground truth and see if we can build effective models by analyzing satellite imagery. So starting with things like soil moisture readings that you have of a field, can you actually infer the soil moisture level simply by analyzing satellite imagery over that particular field? Because if you are able to do that, it helps you do all of that analysis at very, very large scales and in a much more cost-effective manner. And in turn, you can pass on those benefits to the insurance companies and banks, which in turn can then pass on those efficiency benefits to the farmers and provide them, again, that loan at a lower rate, or that crop insurance at a much more reasonable level. Because today, I was shocked to learn that crop insurance for farmers is often outrageously priced, where they might need to pay something like 25 to 30% of the price of the crop for getting that crop insurance because of all of those inefficiencies. The final quick topic that I'll cover very quickly is democratizing access to information. I know, many of us, the first thing that we do when we are trying to access any information is we start with something like a Google search. And what we are trying to do is to cater to all of those hundreds of millions of our fellow citizens who, unlike those of us who are kind of in this conference, so somebody like, let's say, a laborer's son in Chhattisgarh or a farmer's daughter in Assam, how do we empower them with the same kind of access to information as all of us, right, who are attending this conference? So a major difference is that for people like us who understand English, we have access to much richer information on the web. But for somebody who doesn't speak English, often the amount of information that is available to them is much lower, and often the quality is much poorer. So I'll skip some of these details, just kind of very briefly mention that there are some very, very interesting challenges, because often, for instance, one thing that we do in India is we do this code mixing. We mix up multiple languages. This is an example of Hindi and English being mixed in the same query, in the same sentence, which means that you cannot just have an English-based model or a Hindi-based model trying to process this query. You need a multilingual model to be able to process this. And at Google, we did have this multilingual technology, the multilingual version of BERT, which we realized wasn't doing very well on Indian languages. So our team here has developed this Indian counterpart, which is Mural, multilingual representations for Indian languages, which has been trained on, again, a corpus with 16 Indian languages and English, and is achieving significantly improved accuracies. We also have kind of related efforts that we call endophoneme, because we often see on things like Google search or the Google voice assistant misspelling or mispronunciations, which are often influenced by our native language. And what we are trying to do is to make these query processing engines robust to all of these different variants. Because when you think about them deeply, while the spelling looks a bit odd, but when you look at it, think of it phonetically, it does make sense, right? To think of writing furniture in this manner. So how do we make our speech recognition and query processing systems robust to all of these variants? This is something which is being done by this endophoneme team. And again, as more and more AI begins to impact the real world, it also becomes very important to look at, again, these basic principles, given issues like potentially biases that AI technologies can perpetuate. So at Google, we have also established a set of AI principles where we have started basically analyzing all of our research efforts and our products to see are they abiding by these principles. And also we have, again, identified a set of AI applications that we will not pursue that are likely to cause overall harm. And the idea is to be able to then take all of these advances in AI to be able to solve real world problems and make a positive difference to the world at large. So hope I've given you a flavor of what's possible. But again, in my view, that's just the tip of the iceberg. And there's a lot more that the external world can do and is already doing. And over the coming years, we look forward to both collaborations and enabling through frameworks like TensorFlow that we have been contributing to and so on, enabling basically a whole bunch of people, both inside and outside Google, to be able to solve many of these problems arising in areas like health, agriculture, transportation, education, and make a difference to the world. So let me stop here. Apologize, I think I've gone over a bit, and if there is time, I'm happy to take a few questions. Thank you.
Thank you, Dr. Manish. Very insightful, presentation, and I think there were few questions. But looking at your presentation, I think most of those were answered by you. And I'll just read one question, which probably you have already answered. Looks like AI is benefiting rich more than poor currently. Do you agree with it? I mean, would you like to make the last comment on that? Looks like we lost the audio here.
Network, I think you were saying technology benefiting the rich more than the poor.
AI is benefiting rich more than poor. Do you agree with it?
So I would both agree as well as disagree. I mean, I would agree that today the benefits of AI have gone much more to the rich. Is there potential to benefit the poor as much as the rich? I would say absolutely. And a lot of the emphasis of our AI for social good effort is primarily, again, these marginalized communities which have not seen the benefits of technologies like AI, and which is why we have been working with all of these NGOs, and I had to skip over some of that work. And in fact, we launched 6 projects last year, and we realized, I mean, while we made good progress on many of these projects, we realized there's so much more to be done. So this year we are expanding the scope to about planning to launch 30 new projects with NGOs supporting different communities. Again, our goal is to eventually impact over 1 billion people from the disadvantaged communities that are not yet touched by AI. But yeah, today I would absolutely admit that technologies like AI have benefited the rich far more, but there is clearly potential to, in fact, help bridge that digital divide using technologies.
Thank you so much, Dr. Manish. The future looks brighter, and we want to wish you the best. Thank you for the participation in this summit.
Thank you.
So with that, we would move to the last session of the day, which is much awaited keynote address by Mr. Srinivas Lingam. And this is about AI at population scale. With about 1.4 billion people, India faces significant logistical and interoperability challenges when implementing any technology solution across its many states and vast population. But this challenge also poses a significant opportunity to solve difficult problems at a scale large enough for the solution to be applicable worldwide. The keynote titled AI at Population Scale will talk about many of these aspects and more. It is my pleasure to introduce Mr. Srinivas Lingam, VP Data Platform Group and GM, AI Product Group, Intel India. Mr. Srinivas has overall responsibility for developing deep learning training and inference products to Intel's data center and cloud customers. He has built the Artificial Intelligence Group in India since 2016 and led the organization into a deep learning center of excellence with end-to-end capabilities. His team delivered Intel's first data center inference accelerator and won Intel Achievement Award. Srinivas joined Intel in 1997 as a design engineer on a CPU development team based in California. During his nearly 25 years of experience at Intel, he led the CPU design, SoC, chipset, soft IP, hard IP, and AI teams across United States, Israel, Malaysia, India, and Costa Rica. Srinivas holds a master's degree in electrical and computer engineering from the University of Florida, Gainesville, and MBA degree from the University of California, Davis. With that, welcome, Mr. Srinivas Lingam.
Thank you. I can start presentation, I guess, right?
Sure.
Sorry, I should have started. Let me know when you can see.
We can see, you can put in the presentation mode.
Okay, thanks for the warm introduction, Kamal. I know I'm the last, and hopefully I still have audience to pay attention to one of the most interesting topic for all of us in India to get AI to the population scale. Let me first give my opinion of where AI is in the big scheme of things. I know it's a IPL season, so I'm going to use an example that is not related to IPL. But if AI is a test match, in my opinion, we are barely in the first day of the test match, for 1 or 2 sessions in the test match. There's a lot of work ahead of us, and AI touches every aspect of the life, and the opportunities are immense. So for those of you who are thinking that AI is advanced and potentially we are missing the boat or something like that, my personal belief and belief of many experts is we have a long way to go, and now we need to make sure this AI not only just touches all the industrial applications involved. Yeah.
Sorry to stop you. Your presentation is actually coming half. Your speaker notes are visible. So if you want to change that would be great. Thank you.
So let me try to just share again. Just 1 second. Give me a second if you don't mind. Where do I share here? Share screen. There's an option to share screen, right? Okay.
I think you did something which was okay after that. Yeah, now it's okay. Great.
Can you see what I'm sharing?
Yes, this is good. Thank you.
Okay.
We can see your presentation.
Yeah, I have a problem on my side. Just give me 10 seconds, please.
Sure.
You can still see my presentation or
Yes,
the
yes,
split screen?
yeah,
Okay.
I can see your slide where the cricket thing is there.
Okay, sorry. So my point here is that there's a long ways to go for AI, and they're still in the early innings of this game. So let me move forward. Let's first talk about the AI opportunity for India, right? We have seen AI to make big economic impact in several areas like search and recommendation engine, voice bots, and targeted advertisements and many things. But one of the areas, the real application of AI beyond these commercial uses is to have its influence on the healthcare, the smart mobility, the industrial 4.0, agricultural, and financial services. I mean, what is very heartening for me is it's not just some of us in the industry trying to thrive for this. India is looking at it very carefully, and they're following a similar approach with NITI publishing the national strategy paper, AI for All. We worked very closely with them and collaborated with them on the strategy and direction. So this is an opportunity for India to lead the world and showing how AI can really help take care of the humans beyond the commercial usages of AI, and help societies in an inclusive manner, not in some kind of weaponized manner, but more inclusive manner to make AI reach the broader population. Like I said, where the opportunity is immense and AI will go almost to all areas of life, we need to pivot and look at AI from the human-centric area and from focus on more of a human-centered AI. And to address this, the next step is to see what are some of the national level problems and what we can deal with AI and what are the requirements. Right? AI can solve needs of India, that's very clear. But we need significant focus on 4 different vectors to make it happen. One is the talent, very clear. The next one is the technology and IP. The next one is on the policy, and 4th one is on data. Let's talk talent. Today, from the world talent point of view, 16% of the world's AI talent is coming from the United States. Around 9 or 10% is coming from China. And India is in good shape. We have about 8% of the world's AI talent being supplied by India. So we are in a good shape, but we should try to, with our population and our capability, we should try to take this to 20s or 30% over years. The second thing is technology and IP. Do you have access to technology? Right? Have you created enough IP? I mean, there are lots of patents being filed and IP being generated. For example, China took a big leap. They have like 40% of the world IP in the recent years is coming from China, and about 20-25% from the US. And Japan is at the 3rd place, 14%. So we need to focus on this technology as well. And the third one is, are we leveraging the policies and regulations to make sure that these technologies are used for the good of the humanity? I mean, do we have robust policy environment? Do we need regulatory help? So these are the areas we need to focus on as we scale AI to the population scale. And the last and one of the most important is the data. I mean, data is being generated in tons, right? Like any number we hear is like 175 zettabytes of data will be there by 2025. It's mind-boggling number. We need to make sure this data is secure, this data is accessible and rich. So to do that, we need a few drivers. We need to make investments across the board. And while India is making bold moves, our investment in this field of AI is about 5%. I mean, like I said, China in this area again is leading the pack with nearly 60% of the world's AI investment in the recent years. China just doubled down on this, and US is obviously making big investments, about 30% or so. India is doing okay, but we can probably enhance more. But let us focus on the key drivers that we need to pay attention to while we invest on all these 4 vectors. We need to build AI experts. That's first and foremost. And today we are about, like I said, 8% of the talent, but we need to increase the expertise on AI. And we need to amp our research output, right, to generate indigenous IP that is localized and help our local ecosystem. And we need to ensure we have the policy regime and a sandbox to test new technologies like AI, and make sure it is meeting the security and privacy and ethics and all other aspects of the policy. And finally, on the data side, we will need curated, annotated data to ensure we develop and deploy the correct AI solutions. I mean, this needs enabling across the board from different technology pillars, from platform for training, from compute, from software and hardware architecture solutions, safe and secure privacy protection technology, of course, the cloud and edge. So we need to fire on all cylinders to be able to realize our dream of addressing the national problems using AI. Now, I want to talk a little bit on the first two pillars I talked in terms of talent and technology IP. I mean, one of the ways to meet the population scale demand is to leverage on technology-led disruptions. I mean, if you look at the last 40 years, we have seen some amazing technology-led disruptions when we made a lot of performance available to a lot of people. I mean, the keyword here is a lot of technology, a lot of performance available to a lot of people. I mean, in the PC era, we digitized everything we could and we networked everything we could. In the end, we got 1 billion people onto the internet, and it changed the way we learn and the way we work and the way we entertain ourselves. So this is not new. These technology-led disruptions are population scale. I mean, in the next disruption was the mobile and cloud era that we all are aware of, where we have 10 billion mobile devices connected to supercomputers in the world, and that changed everything. Even more so, we can feel its power in this, in this pandemic phase we are in, where this touches every human being, and we thought that life would have been even more difficult than it is already today. Now, what is the next disruption going to be? In my opinion, and in the opinion of several experts, the next disruption will be to go to 100 billion devices that are connected and intelligent, right? It helps protecting and enriching our lives more than the ways we can imagine. If the first two disruptions are earth-shattering, I think the new disruption that we are entering into is going to be even more world-changing. Intelligence will require a ton of computing, I mean, from exascale and beyond, computing that should be equally accessible to anyone and everyone, right? It should be like free from wherever the data resides. We should be able to access it from anywhere in the world, and it's not just controlled by the few big companies or few big proprietary abstractions and all those things. It's an exascale computing that should be accessible to everyone like it's electricity today. So that should be the uber goal for all of us. And this is the future that really excites me and many of my colleagues. I mean, it's like 10x of the industry expansion, and it can touch every human being. So in the coming few slides, let me talk a little bit of where these computing demands are coming from before we understand how to reach to the population scale AI. The biggest place where this computing demand is coming from is, of course, the data is exploding, right? The key breakthrough in the recent decade is how we are collecting data. I mean, as you can see in the graph here, by 2025, we'll be having 175 zettabytes of data. For those of you who are not keeping up with these code, zetta is like 10 to the power 21 zeros, right? But they're just generating a lot of data. Are we leveraging it properly, right? Are we leveraging the data to build our intelligence? But as a world, we are generating a ton of data, but I don't think we have the ability to analyze and understand. I mean, this data is not only stressing on the need for more compute, but it also stresses the whole infrastructure. I mean, we need to have more capacity. We need to have more bandwidth at every level of the memory hierarchy. And we need to network. We need our networks to handle this data. And a lot of things ride on this exploding of data. That's the first challenge that is leading to the compute exploding that I talked about. The next one is the second challenge we're facing today is that the complexity of these deep learning models are growing in an exponential rate. I mean, the data I'm showing here is from June of 2020. The y-axis shows the number of model parameters. In some sense, it's a representation of the complexity of the model of the neural network, and the y-axis is the timeline. As you can see, in February 2020, what you see here is like we had about OpenAI came up with GPT-2, which has about 1.5 billion parameters. And then we have as much as 17 billion parameters models. These models are exploding, but that's just the beginning. And these are continuing to grow. Just the same open AI based GPT-2, the GPT-3 is about 175 billion parameters. You're talking just in 18 months, it's 100x growth in the complexity on a given model. And this trend seems to be continuing too much, right? It's too complex, but this trend is too complex to continue. We cannot sustain this trend. So what do we do about it? I mean, before I talk about what we can do about it and how to make, I mean, this is actually alarming. This tells us that as the compute and demands are growing and our uber goal of trying to get AI to the population scale, they can be at odds, because this can be only accessed by few if the compute demands are so high. But before I go into the growing compute demand, I'm sure many of you are aware of the good old times. Good old times is not that far ago. It's prior to 2010 and such, where the Moore's law was thriving, and the compute is doubling every 2 years, and life was good. I mean, whatever the hardware comes up with a new cool feature, the software takes advantage of it and comes with even more powerful programs, and then the hardware catches up. So we used to call it Intel as this as a software spiral, right? So this was going well till 2010 timeframe. But then came the revolution of deep learning, and it's no longer a two-dimensional linear equation. Now it's a three-dimensional equation, right? Life becomes complex with bigger models. These bigger models are driving need for bigger data, and this bigger data is driving more compute, and the more compute enables bigger models. So this software triangle is continuing. And the deep neural network models are increasing in complexity, and that is putting a huge pressure in compute. Now the compute demand is like double every 3 to 4 months. If you think about it, it's 10x computing power demand in a year, right? And this is definitely not sustainable. I just want to impress on how things are going and how complex things are getting. But we have a challenge of trying to get AI to the population scale. If you can see in the chart in the bottom, this is not affordable to meet the population scale if this is the compute demand, and it's also not sustainable, if nothing else, for the carbon footprint and the carbon emissions point of view. See this graph where it's charting the carbon emissions. Interesting study that shows to manufacture a US car and to run it for its entire lifetime versus training a AI model, it takes 5x the carbon emission just to train an AI model. And this data is from 2019, and add 10x to it, and it's just getting out of control. The point here is, back to my original analogy where I talked about, we are in the first innings of the first day of the test match. Things are still, there's a lot of ways to go before we can tame AI to go from becoming unsustainable to sustainable to affordable to take it to the population scale. But we need to work towards it to be able to realize this dream. So I just want to show these technology trends before I get into how we scale it back to the population scale. Now, we talked about all these data explosion, the model explosion, and the compute explosion, and all those things. But let me talk about one real life example. This is a real life customer example for defect detection. In the production deployment, beyond just AI, you see here, there's a bunch of other activities that go into the production. I mean, like deploying the model, the data preparation, and the data processing, the decision processing post AI phase, the broader application and refreshing the data. So there's a bunch of things that are outside the quote unquote, pure AI that we talk about, right? If you zoom into the AI step one click, even within the AI step, before we infer something, we need to train. And this training phase also involves a lot of things that are just not pure compute intensive things like, experimenting with topologies and tuning hyperparameters. These are the classic AI and deep learning activities. These are not the only things that exist in this pie. There are things like labeling data, loading data, augmenting data, right? And and after the fact, supporting the inference inputs, and doing many post processing that are labor intensive. My point here is there are several adjacencies outside the core AI that we talked about that we need to be prepared if we want to take AI to the population scale, right? These adjacency disciplines, if we work on it, we can make AI to work for us really well. And if we invest in these adjacencies in the form of data and algorithms and processes to deploy it at scale and maintain the solution to stay current, we can definitely grow our AI workforce from our existing 8-9% of the world's workforce to, like I said, 20-30% over years. So we have to pay attention to not just get caught up in the AI, but all the adjacencies around AI to make it happen. Now, we are not just talking the talk at Intel and many other corporations in India and other research institutions and government. We are creating some impact already with some of our ideas. It's very, let me build this slide. It's very clear we need to have the right data set. We need to have the right localized solutions that fit our local ecosystem. And we also need to reskill our people. Now, what we are doing in these respects as, from our viewpoints, I mean, we created Indian driving data set. It's a data set for India driving conditions to enable research in road safety and AI algorithms. That's one area. As Intel, we are contributing with other partners and the governments very well there. And also, we are using our ADAS technology. We have conducted collision avoidance pilots in few cities, which have shown that solutions can, these collision avoidance solutions can reduce the near misses by 45 to 75%. So it's really exciting. There's a lot of potential to enrich human lives through these AI-driven initiatives. We have also been working to create scalable platforms and deploying AI-based solutions for healthcare in India. And last but not the least, we have AI for youth. We are working with the Ministry of Education to impact nearly 22,000 CBSE schools. I mean, we are partnering with the CBSE board, and we helped in curating and coming up with outcome-oriented AI curriculum. And as of date, we have reached out to nearly 200,000 students with this format. The summary is, we were able to create meaningful impact. I know there's a lot of road ahead of us and a lot of problems to solve, but we are not starting from zero. We have, embarked on in this journey ourselves, several partners in Indian ecosystem, the industry, the academia, the governments, at varying levels of contributions. And we are able to create meaningful impact to these activities. I mean, this has also given us insights into how we can enable AI for the country. I mean, these experiments really help us, keep building how to make it AI for population scale. This is not only critical for national needs, but it also will help India accelerate our journey towards the $1 trillion digital economy we are talking about. So taking this experience that we built from our pilots and experiments we have been doing, I'm very happy to talk about what we did. I'm very happy to share that we formed in AI. It's basically an Indian AI Applied Research Center in collab for population scale AI. And it is done with collaboration with IIIT, Hyderabad, Government of Telangana, Public Health Foundation of India, and the Ministry of Science and Technology. I mean, this center is basically a distillation of all these learnings we collected over years. And we believe we have a blueprint for what it takes to do population scale AI. I'm sure we'll learn a lot, but at least we have a start point. To do AI at population scale, we need foundation to, we need to have a good annotated and curated data sets. We need to have open security data, and we need to have a way to exchange data. We need to have foundational AI technologies and algorithms and tools. All of this with keeping public good in mind. So to do that, we need to have a robust data governance in terms of privacy and security. So with this, I think we can definitely drive towards the goal of getting to AI at population scale. More importantly, we also need startups, the innovators, the researchers, the enterprises. We need all the platforms we have available at our disposal to propel this economic growth for the country, and thereby reaching AI to the masses. I mean, we cannot take everything in one shot. So our current focus is we will focus on deploying these public good assets in healthcare and smart mobility. Those are the two things, at least we in Intel India are collaborating with rest of the ecosystem partners and governments and researchers to drive this activity. And India has done really well with Aadhaar, with GST, with UPI. So it's time to show the world that we can deliver this human-centric AI at a population scale. I really think we can do it if we put our mind to it. And I'm really excited about that. Now, to conclude, I bring back the same slide I presented before. To address the national problems using AI, we need to have a parallel focus on all these 4 vectors we talked before. This includes the talent, the technology, the policy, and the data. On the talent side, like I said, we need to identify 3 or 4 problems and the skills needed to address those areas. We need to build AI solutions to impact them. Typically, the technology adoption can sometimes take a lot of time, 10 years, maybe the phone, some 3G or 4G technology. Some of these technologies took time. But with respect to AI, I think the demand and the outcome is so significant. I have this feeling that we can adopt this in much faster pace, maybe 5-6 years. But we need to act now. And we need to have access to technology. Like I said, US has 25% of the IP that they developed in the recent years, and China is growing really fast. Japan is at 14%, but they probably don't have the talent pool in terms of numbers or the data we have. Perhaps we need to think of some innovative ways. Maybe we want to partner with some other countries to come with better technology that helps our local needs. And we are ready to, as Intel India, contribute to the ecosystem, be it in terms of accelerators or programmable compute, CPU, GPU, FPGA, you name it. We will be part of this revolution for population scale AI initiative. What worries us the most is the policy with respect to AI. There's so much talk about biases. When we infer things, it's a function of what we train on. And if we don't have our localized solution, our inferences are likely to have unintended biases in the solution. So we need to make sure we have our policy that just not addresses the security, safety, and privacy, but it also pays attention to the biases and ensures we are bias-free. And last but not the least, in terms of data, I believe we have the workforce that can meet the data requirements of the world. There's a lot of world outside AI in terms of collecting the data, curating, basically labeling the data, cleaning the data. And we can convert some of our workforce that can be the data engineers for the world and help drive this data exchange program across the industries or government or academia or anything to make sure the data is the new oil. So we take advantage of that. We are a data-rich country and we are hungry to innovate. So if we can focus on these key vectors, I think we can really realize this dream of leapfrogging and making sure the entire population is uplifted with this population scale AI. With that, I'll end with this quote from our own Dhirubhai Ambani. If you don't build your dream, someone else will hire you to build theirs. Basically, we have been the talent for the world, and we have built our own technology, but we also have been building a lot of world's dreams. But we have enough challenges now. Perhaps we can tune a little bit more towards building our population scale AI goals and build our own dreams. Thank you very much for the opportunity. I'm here for any questions if you have time.
Thank you so much, Mr. Srinivas. It's very interesting to see how the ecosystem is coming together to solve this problem at the population level. I have a couple of questions that I got from audience. So first question is, we have heard of AI on X-ray solution for COVID testing, but this has not been in use so far that much. People are still relying on RT-PCR tests and other tests. Why is that world has not found a popular AI-based solution for COVID-19 so far?
That's an area a little bit outside my expertise, but I would think, like we talked about, AI is only as good as the data, is my personal view, data available. And the data is still very early and evolving and mutating too fast, I would assume. I don't know if this is the right answer. I think there's lots of advances. I read about it, but whether is it at the production scale where AI can be deployed to either diagnose or even project the trends and all. I'm not up to speed with all the technologies. I think it's growing, but I would still think this is an area that as the data pours in, this for the God forbid for the next pandemic or the remaining the tail end of the current pandemic, we will leverage AI even more significantly than I'm even aware of what is being used on. And research is going. I mean, at Intel India too, there are initiatives to help these AI to help some of this COVID research with AI. I can pass on to my my research team that can probably give better answer to that.
Sure, thank you. And there's one more question that I would pose to you. AI at population scale seems to be the need of India and China. Do you think innovation in this domain will come from these countries mainly?
I think it is necessary for us to innovate because, like we talked about it, the India and China are the most populous countries in the world for one, and we have our unique problems. Be it in agriculture, education. Every country has their own DNA, and India has its huge uniqueness. And innovations, we can leverage innovations of the world where it makes sense, the global innovations and global technology. But we can't wait for the world to solve our problems because our problems are unique to us. So yes, I think innovation should come from us, and that helps us, and we can leapfrog some of these innovations to solve the world's problems in several cases. So it is not just a nice to have; it's a must have because it is our unique localized problems and our own data that we need to focus on to create innovations that fit our population scale AI.
Thank you so much, Mr. Srinivas. It has been a delight to have you
as
a keynote speaker. And thank you so much for this interesting talk. Okay, with that, we end the first day of AI Summit. I want to thank all the participants and delegates to be throughout the day and made it a successful event for the first day. A reminder for tomorrow, we are starting at 9 a.m. India time tomorrow, and you will have a lot of actions tomorrow in the form of multiple panels, product demos, technical sessions, and so on. So look forward to have you 9 a.m. India time tomorrow with a lot of actions coming in day 2. Thank you everyone for joining us for this summit, and have a good evening.